In this Untitled Now course, we're going to take a look at a quick introduction to Node.js. Node.js is a huge topic, but this will provide a quick overview and an introduction to this great platform for building JavaScript applications on the server. In this course, we're going to take a look at first, what is Node.js? What problem does it solve? Then we'll take a look at installing Node.js. We'll look at the Node REPL environment. We'll talk about creating Node programs and actually putting our JavaScript source code into files. We'll also talk about managing packages with NPM, which is Node's package manager. We'll take a look at building a simple web server. We'll read a file off of disk. We'll do a little bit of debugging. We'll talk about creating a package. And then finally, we'll use NPM itself to actually run our package. So what is Node.js? I mean, why exactly do we need it? Why do you use it? Node.js is a cross-platform JavaScript environment on the server. Now, when we say on the server, what we really mean is a JavaScript environment that's not in a web browser. It can be running on what we'd think of in terms of like an actual web server. It could also run, for example, desktop applications. But the idea is that the JavaScript itself is not limited to a small sandbox environment as it is in a web browser, but instead can actually access all of the system resources, similar to what you might find when working with a Java program or a .NET program. Now, JavaScript itself is really nothing more than a glue language. It's a glue language for C++ modules. When you're inside of a web browser, you have certain C++ modules that you work with. JavaScript behaves the same way in Node, it's just the C++ modules themselves are different. Now, the JavaScript engine used by Node is Google's V8. It's the same one that powers Chrome. There are some efforts on the part of Microsoft to actually be able to use Chakra, which is Microsoft's JavaScript engine, and be able to use that instead of V8 with Node. So Node itself, while implemented with the V8 JavaScript engine, is not necessarily married to Google's V8 JavaScript engine. That just happens to be the one that it uses now. Now, Node.js itself, if you go and actually read the Node website, they'll basically tell you it's an event-driven, non-blocking I/O type of platform model. And the idea behind that is that JavaScript itself is single-threaded. So it can only ever do one thing at a time. And the way that it does the various things that it does are through tasks that are pushed onto something called the event loop, or that single thread of execution. Well, while JavaScript itself is single-threaded, the environment that it is in is multi-threaded. It's actually surrounded by a lot of multi-threaded modules. That's where the non-blocking I/O part comes in. When JavaScript encounters an I/O operation, it typically passes it off to one of those surrounding multi-threaded modules. And then while those modules are off doing their thing, they are non-blocking on the JavaScript thread, and JavaScript continues executing the next command. Now, Node.js is just like that web browser. It's just a different set of C++ modules. It provides modules that are specific for working with local system resources. Let's take a quick look at a diagram which shows this. So if you see here, we have the web browser on the left and Node.js on the right. You can see for the web browser we have JavaScript in the middle, just like we have for Node. So it's the same JavaScript engine that's kind of connecting all of these different C++ modules together. But then you can see in the web browser we have things for like WebSockets and the DOM and the XHR object and the file reader and timers and videos and such. And in Node we have in some cases similar modules, but we also have different modules too, like an actual web server or being able to access the process or being able to cluster various Node processes. We have similar things, for example, like the file system and the network, which are similar to the file reader and XHR. The difference is in Node, these actual modules can do so much more. They are not limited by the sandboxed security requirements of web browsers. Hello, my name is Eric Green, and welcome to this Untitled Now course on Node.js modules. In this course, we're going to take a look at working with modules. In particular, we're going to talk about organizing Node.js applications. We're going to talk about various module systems. We'll discuss AMD CommonJS as well as the new ES2015 format. And we're also going to take a look at actually using CommonJS and ES2015. and then we'll discuss using the transpiler called Babel to actually transpile the ES2015 module syntax into common JS so that it can actually be used by Node.js and the V8 JavaScript engine. So to get started with this class, we are going to be assuming that you have some basic knowledge of Node.js as well as the JavaScript programming language. You'll need to have Node.js installed on your machine if you want to follow along with the examples. Make sure you install version 6 or later. Also, if you don't understand the basics of these technologies, if you've never used Node or you don't know how JavaScript works, I highly encourage you to go take the Introduction to Node.js class first and then come back over here and take this class to understand more about how to work with modules in your Node.js applications. Now, organizing Node.js applications. Typically, Node.js applications are purely JavaScript code. What do I mean by that? When most people think of Node, they think of JavaScript, but the truth is you can actually write native extensions to Node in C++. And those native extensions can also be referenced as modules in your application. For our purposes, though, we're going to be looking at purely writing JavaScript modules for this course. We're not going to take a look at writing any C++ code and writing native modules. Now, when you write a really small Node app, maybe a couple hundred lines or something, you can put the whole thing in one file and it's fine. But any application that is of any significant size or complexity or has multiple parts that might need to be shared out with other applications or shared out to other parts of that particular application, you're going to have to divide it up into multiple files. Just putting 10,000 lines of code into one file just really doesn't make a whole lot of sense. When you do that, you'll have to have a mechanism by which you can have the different files basically work together. In Node, each file is considered to be a module. And Node uses something called the Common JS module system to basically import or require one module into another. So basically one module exports and another module imports. And so we'll take a look at how that whole mechanism works. Now the idea though for these modules is that modules should be divided up based upon functionality, what can be decoupled from each other, what might need to be reusable in other applications or even within this one. Now, ultimately, our modules, especially the ones that are shared between multiple applications, will ultimately be bundled up into packages, and then those packages can be included in the applications which need them. Making packages is going to be outside the scope of this course, but if you're interested, go check out Wintellect Now's course on Node.js packages, and it'll actually tell you how to create your own packages and then how to distribute them so that you can share your modules with other applications. When JavaScript was originally envisioned back in 1995, Brendan Eich, I don't think he really envisioned that JavaScript would grow to the size that it's grown to. And so there was no concept of namespaces, packages, modules, or anything built into the language. It was a great language for doing relatively simple UI types of things in a web browser, but in terms of building enterprise class applications, it just didn't have all of the programming features and capabilities that you'd find in other languages like a C++ or Java. Over the years, JavaScript developers decided to fill that gap with two popular coding patterns to basically create modules. One was called the Asynchronous module definition, and the other one was called Common JS. Now, the motivations behind creating these modules was basically the concept of reusing code and not polluting the global namespace. And so these two different module approaches, one was particularly well suited for web browsers, which was the asynchronous module definition, and then one was adopted by Node, Common JS. So the asynchronous module definition dynamically loads modules asynchronously. Basically, as the modules are needed, if they have not been previously loaded, then they are loaded asynchronously. That typically means that it's going to be downloaded like over a network connection. AMD modules were very, very popular with web applications because instead of downloading all of the JavaScript for the entire application on the initial page load, only the modules which were needed for that first page could be downloaded, and then all future modules could be downloaded as needed instead of downloading them all at once. And the advantage to this was that it actually reduced the amount of bandwidth that was needed in order to load up a web page. Now, the only problem with this approach, though, is that it really doesn't work all that well in a high latency or a poor network environment. Basically, the more requests you have to make back to the server, even future requests can introduce all kinds of problems into your web application. For example, let's say on the initial page load, I'm walking down the street on my cell phone and I load the page up and all is good. And then I walk into a building, and when I walk into the building, maybe my network connectivity drops significantly, or maybe I'm walking onto an elevator. And right as I do that, I click on a link or something like that, or a button in the application, and it takes me to another view. Well, what if that other view requires access to a module that hasn't already been downloaded? I basically have an application that was working, but now my application is going to fail because it won't be able to download that module because of the poor network environment. Also, when you're dealing with high latency, which is the amount of time it takes to go from the browser to the server and back, regardless of the amount of data being transferred. In a high latency environment, downloading lots of different modules and starting up a bunch of different HTTP requests can be very inefficient. So while the AMD module approach basically solved the bandwidth problem, in terms of an overall poor network environment or high latency, it actually can cause more issues than it really solves. The modules that are downloaded, though, through AMD are in fact singletons. So once a module has been downloaded and parsed and processed, and an object has been returned representing the module itself, then all future usages of that module will always use the same object that was created. So once the modules are downloaded, you're good to go, but in an environment where there's a poor network connectivity, you could have issues when downloading future modules. AMD is not used by Node, and the reason why this is not ideal for Node is that basically all of the code for your Node application is already locally there on the server. There's no need to make asynchronous requests like a web browser might back to the server to run your Node application, so AMD is not used for Node. If you're interested in learning more about AMD, you can learn about it. There's two projects, Require.js and Dojo. And Require.js actually came out of the Dojo project, but Require.js is a AMD module loader that exists independent of Dojo. And you can take a look at creating modules that use those technologies. CommonJS modules are a synchronous file-based module system. This is why it's used for Node. Basically, the modules all exist on the file system. When you need a module, if it has not been previously loaded, then basically it's read off the file system, processed, and then the module object is returned. Now, it is synchronous, and so what that means is that when you go to request that file, the time that it takes to load and process the file, the basically program execution blocks until that code has been processed, which kind of makes logical sense if you think about it. Until you have the module, you really can't continue processing whatever it is you want to process. And because the modules are all located there on the file system, it's a relatively quick process. These are also singletons, just like the AMD modules, and they are loaded dynamically. Now, the best example really of CommonJS is Node itself. Node uses this because all of the files are already locally available. Now, the new kid on the block are the ES2015 modules. These are actually built into JavaScript. While AMD and CommonJS are very popular, they are not actually part of any type of JavaScript standard. ES2015 modules, on the other hand, though, are. Now, when we say ES2015, we're also referring to ES6. ES6 was the original name for ES2015, and then they switched to actually using the year instead of a version number. And ES2015, according to the specification, adds support for modules. They're similar to CommonJS, but they can't be used dynamically. We'll take a look at what that means here shortly. Basically, modules are static, so you have to say import this, and whatever this is determined at development time. It cannot be changed at runtime like it can be with AMD or CommonJS. Now, unfortunately, none of the JavaScript engines actually support modules yet. Not even Node.js's V8 engine provided by Google. So instead, we have to use a transpiler, which is basically a tool that takes one type of source code and converts it to another type of source code in order to use modules. And basically the way that this works is the transpiler, in this case we're going to be using Babel, but there are several you can choose from. Basically the Babel transpiler will take our ES2015 module code and convert it to CommonJS module code. So when it actually runs with Node, it's actually running as CommonJS, But when we code it, we're actually using the new ES2015 module syntax, such that in the future, once that syntax is directly supported by the JavaScript engines, we won't have to use a transpiler anymore, and we can just use the code natively. This module system can also be used with web applications, not just Node apps. Basically, what you need to do is you'll set up a transpiler such as Babel again, and it will actually take the ES2015 syntax, create the common JS module syntax, and then you can use a tool like Browserify or Webpack to actually use the common JS module syntax to produce a single downloadable file. This has actually become the preferred way of doing it versus using something like AMD. Most internet connections these days don't have bandwidth issues. Even a person's cell phone can watch, Netflix videos. We can download lots and lots of stuff. The bigger problem is the network connectivity and the latency and things like that. And so by having a larger one-time download through a thing like a Webpack or a Browserify, we basically have applications that will also perform well in a poor network environment. Because JavaScript doesn't have to be continuously downloaded as it's needed. There is something called the System.js dynamic loader. This is not part of the specification, but it is proposed to be part of a future JavaScript specification. Basically, the dynamic loader will allow you to dynamically load modules just like you can with common JS and AMD. So the advantage of dynamic loading is, depending upon how your coding logic is written, you can choose to import one module versus another module. As opposed to the current ES2015 module syntax, where you can only specify what you want to import actually at development time, not at runtime. There are System.js polyfills out there. In fact, Angular 2 actually makes use of one. Polyfills that you can use to go ahead and start having that dynamic loading, and then hopefully when it's added to the JavaScript specification, you'll then be able to actually use it natively within the language. So our focus from here on out is going to be on Common JS and ES2015. Basically, we're going to take a look at what it means to export and then what it means to require and to import. A module exports a value or an object. If you remember back in JavaScript, things are either primitives or objects. So like a number would be a primitive and an array would be an object, or a function would be an object. Well, a value like a number, or an object like an array or a function or just a standard regular plain object can all be exported out of a module and be imported then into whatever module wants to import that. There's a special case when a function object is actually the exported object, and the special case with it is that it provides a very convenient syntax mechanism for basically allowing you to kind of configure a module in addition to actually importing it, and we'll take a look at an example of that. Now, behind the scenes, when you take a look at this module code, you're going to see where we have an actual module object, a require function object. There's going to be two string variables, dir name and file name, and there's an additional object called exports. And the question becomes, where do these actual objects or variables come from? And basically, what happens is with Common JS, your module behind the scenes is going to get wrapped inside of a function. And that function is going to have these variables as its parameters. And so when Node.js actually goes to invoke your module, Node.js is actually going to be passing these in to your module code, and then your module code can make use of them. So a lot of first-time Node developers think that when they see module or double underscore dir name, that these are somehow like global variables. They're really not global. They're just parameters that are defined by the function that wraps your module behind the scenes. And we'll use Node Inspector to kind of take a look at what that looks like. So let's go ahead now and do a little demonstration of building our first module. All right, so let's take a look at how to create our first module. So let's open up a command prompt here. Good. And then we're going to create a folder here for first-module. And we're going to fire up Visual Studio Code. And we'll come under here, open up a folder. There we go. Okay, great. So we have our first module opened up here. We're going to create ourselves a new file, index.js. That'll be the main application file. And we're going to create an actual module that we're going to pull in. So we'll just create a module here called first module.js. And then we'll come into here and we're going to go ahead and set up something to export. So we'll say module.exports, and then we'll say do it, and that'll just be a function object. Console.log did it. Put our semicolon down here. Then we'll come over to index.js, and we're actually going to pull in this module. Now to pull it in, we'll say use strict here at the top, and then we're going to say const first mod equal to require, and then we'll say first dash module, just like that, and then we can say first mod dot do it. So if you take a look here now, we have our first module exporting the do it, exporting an object that has a do it property, and then here we're requiring that object in, and then we're invoking do it. And then I'm going to open up a terminal prompt here, and I'm going to say node index and hit enter, and you can see that our first module has executed. So the key is assigning something to module.exports and then requiring it into another file and then working with the object that was exported.
Now, configurable modules. This is really more of a pattern, not so much a built-in capability to Node or even to CommonJS. Basically, modules that return a function object basically can be invoked. And when you invoke them, you can pass in configuration data as an argument. And then the parameter inside the module can then be used to actually configure and produce some type of object, kind of in effect creating a configurable module. The function object is actually what the module is, and that function object is the singleton. The returned object, unless you code it this way, is not actually a singleton. It represents a particular configuration of the module, if you'd like to think of it like that. Now, if you want to make that particular configuration to be a singleton, you can certainly code that if you'd like. But the only thing that is actually the singleton is the function object itself. But there's a lot of libraries out there make use of this pattern, such as Express returns back a function object, and then you can pass into it the configuration that you want, producing a new application. So it's a very common pattern. Let's take a quick look here at a demo of how we can create a configurable module and kind of explore how it works.
So we're going to come over here and create ourselves a new file, and we'll say configurable module.js. And we're going to come over to here and we're going to set this thing up to be configurable. Now remember, this isn't really a thing built into Node or CommonJS. This is just kind of a pattern. So we're going to say module.exports, but this time we're going to assign it an actual function. And then for this function, we'll set up an argument called config, and we're going to come into here and we can do something with this configuration. So for example, we could return back an object, and then we could do like a logging type of thing. So we could say log function, and then whatever we want to log, and then we could say console.log, and then we could come into here and say config.log prefix plus, and then we'll do our message. There we go. So whatever our configuration object is going to have a prefix property on it, and then we will prepend whatever message is sent in and actually log it out like that to the console. So get rid of our little extra space there. Let's jump back over to index here, and we'll comment that code out, and then we'll say const configurable mod equal to require /configurable module. Now you'll notice here we are putting a / at the front of this. This is to indicate that the module is on the file system relative to this file. If we simply had just configurable module there, it would go look for the module in the Node modules folder. But we actually want to find the module relative to where this file is, and it's part of the actual application that we're coding. It's not in the not in the Node modules folder. It's not a package we installed. So so it can reference it this way using the file system. Also, you'll notice that we're using const instead of let or var.
And that's because this is going to be an immutable variable that we're creating here. We don't really want to change the value of it. Really is a best practice in Node, especially in the latest versions of Node where you have full access to all the ES2015 features. You really should be declaring all of your variables as const. Only use let when you specifically have a variable that you are intentionally going to mutate. Otherwise, just try to treat all your variables immutably. So now we're going to come into here and we're going to create a configured module. So we'll just come and say const, and we'll just say configured a. And then we're going to take this configurable mod. This is going to be an actual function object. So we'll just simply invoke it. And we're going to pass in an object, and we'll say log prefix. And we'll just say app. Here we go. And so now when we say configured a dot log, and we'll come back down here and we'll run some code. We'll say node index. You can see it outputs a test, which is kind of cool. Now, from the common JS perspective, this is the actual module here. This function object is the actual module returned by common JS. But by making this a function object, it basically gives us the ability to create a configured object and almost view it like a configurable module. In fact, we could actually take this whole piece of code right here, copy and paste it. We'll change that to B and make that B, and we'll say test2. And now if we run this, you're going to see where basically we now have two instances created from this configurable module. So if we come over to here and run this, you'll see we have A test and B test2. And so this is a really useful pattern if you want to be able to do some type of configuration with your module before actually using it. Now, typically when you require a common JS module into your application, you basically get an object that has a lot of different properties on it that might point to different things that you can make use of in your application. Well, it might be desired that you don't actually want a reference to all of those things. Maybe there's one or two pieces of functionality that you're using from that module, and instead of actually having to use the module name and then the property, it would actually be easier to have some variables set up that actually point directly to those properties that you're interested in doing. You could kind of think of this as selective importing. So instead of importing everything, we're only going to be importing in references to the things that we want. Well, we can accomplish this through the use of ES2015 Destructuring. We can basically use destructuring to extract the properties we want off of the module object and then set those to variables that can then be used within our code. So let's take a quick look at a quick little demonstration here of how to use destructuring to So let's take a quick look at how we can use destructuring to import our modules. Destructuring is actually built into JavaScript now. It's part of ES2015. So we're going to come into here and actually comment out our code from the last demo and come into here and uncomment our first mod again. And we're going to come over to first module, and we're actually going to create a couple of different functions to pull in here. So we're going to have a function called doIt, and then we'll have another function called doSomething, and put a comma in there. And then we'll have a third function, paste that in there, and this one's going to be called getItDone. And we'll just change this to say did something and got it done. There we go. Okay, so we have these three different properties hanging off of this exports object. And what we want to do is over here, instead of having first mod and then being able to reference each of those, instead we want to use destructuring so that maybe we'll only bring in doIt or only bring in doSomething. So we can do that by coming over to here, and I'm going to just put a curly brace and then do my doSomething like that. And now this is actually going to look for the doSomething property
on the object returned from here and actually set this up as a do something variable that I can make use of here in my code. So I'll come into here and just paste this in just like that. I'm going to save that, open back up my console window, and I'm going to say node index, and watch what happens. It says did something. Notice there is no actual first mod anymore. There is no do something dot. I was actually just able to reference the do something function directly off of the property that was returned by the first module here. So this is kind of the coolness of working with destructuring. You can just pull in what you'd like. Now if I wanted to bring in another function, I could say get it done. And then I could come down to here and say get it done. And now when I run this code, you'll see it ran both of those. I also have the ability to rename these. Let's say I already had a variable in here named get it done, what have you. So now we'll just come in here and rename this thing. We'll say git, and then we'll just change this to it. And now when we run this code, you'll see that it still says got it done. So we have the ability to do aliasing as well with destructuring. So if we already had a variable named get it done, we could then use this alternative variable for actually running the function.
Modules are singletons. What does that mean? That means when they're imported the first time, the resulting object or value from the import will be used for all future imports of that same module. The advantage to this is that inside those modules, you can basically have data. And then that data can then be shared between the different parts of the application that are actually requiring that module into it. It also makes for faster execution because you're not always having to re-execute and re-parse all of the individual module files off of the disk. So let's take a quick look at how the singleton pattern works with modules. So let's explore the concept of a module being a singleton. We're going to take our code from earlier here. We'll just comment that out. And we're going to bring back in our first mod. We'll call that first mod 1. I'm going to copy some code up here. Just drop that in right there. And basically what this means is that if I come into here and I have first mod 1 and first mod 2, because of the singleton pattern, I can say console.log first mod 1 triple equals first mod 2. And if I save that, this should come out as true. They should be the exact same object reference. So if I come into here and say node index, you'll see it comes back as true. Now the reason why this is useful to know, in addition to the fact that you're always working with the same object, is that you can share data. So I'm going to come over to first module here and we're going to create a variable and we're going to say let, and we'll just say temp data, and we'll give it a value of an empty string. Now I'm going to come over to here and put two functions on here. We'll have one called put, and this will actually put some data into our temp data variable. So we'll just have d, and we'll say temp data is equal to d, and then we can have get, and we'll say function, and then we'll return temp data. There we go. Okay, so what we're going to do now, and let me fix that, put our commas in there properly. Great. So what we want to do now is we have this ability to save some temp data inside of first module. And so what we're going to do is we're basically going to set this up to where we're going to put data with the first object and then retrieve it with the second object. So we'll come back over to index and we'll say first mod 1 dot put, and then we'll assign it test data. And then we'll say console.log first mod 2 dot get, and that will return back that data to us. So here we're actually storing it with the first module, and here we're retrieving it with the second one. So make sure that's saved. Come back over here, run our code, and now you can see where we have test data. And this is true not only when you're referencing this in the same file, but anywhere in our Node application that we say require first module, it will always be the exact same object that we see retrieved here with first mod 1 and first mod 2. So next we're going to go behind the scenes. We're going to take a deeper look at how our code is actually wrapped up in a function by CommonJS. So when our module actually gets executed, CommonJS wraps this function around it and invokes the function, passing in 5 different parameters. The first parameter is called exports. This is going to be the actual point to the actual object that's going to be exported by our module. Next, we have an actual module object, the actual module our code is inside of. And this module has all types of metadata about our module, but it also has an exports property, which also points to the same object that exports points to, that first parameter. Next, we have the require function. The require function is what our module will use to require other modules into it. There are 2 additional parameters. One is called double_dir name, and one is called double_file name. Dir name represents the directory name of the folder where our actual JavaScript code is located for this module. And file name, of course, represents the actual file name of the source code file that has that JavaScript code. If the module.exports property is assigned a new object, that new object will be returned. Why do I mention this? You'll see in a lot of code where people use the export variable directly to actually set up all the various properties that are going to be exported. The problem is that exports variable is not what is actually being exported. It can be, but not necessarily. What actually gets exported is whatever module.exports points to. Now, it just so happens in CommonJS, the way they have it set up is that when your module code is initially invoked by CommonJS, by Node, the module.exports and the exports variable both point to the same object. But if for whatever reason you assign module.exports to a new object, then that actual exports variable is ignored. And the problem is that when this happens, you may be thinking you're exporting a bunch of stuff because you're setting up the exports variable. But then when you set module.exports equal to something else, then you realize, oh, wait a second, this thing is actually going to be exporting this other object instead. As a best practice, I always recommend just use module.exports. It's only 7 extra characters to type in front of the word exports, and that way you always know what is actually being exported. You don't ever have to worry about using the exports variable yourself, and then somebody else comes along behind you and they say module.exports, and now none of the stuff that you wanted to be exported is actually being exported, and instead this new object's being exported off of module.exports. So if everything just hangs off of module.exports, you'll be in much better shape. So let's take a look at this wrapper function using the Node Inspector tool. To do this, we're going to need to install something called Node Inspector. So we're going to say npm i-g, so we're going to be installing, but we're going to be installing globally, Node Inspector. And so this is actually going to go out over the internet and download Node Inspector and install it for us. Now, if you happen to be on a Mac, you may have to use sudo on Mac or Linux. You may have to use sudo, and while that's definitely not ideal, it's something you should definitely go fix. There's some great Node document or NPM documentation that explains how to reconfigure your Node installation so you don't have to use sudo in order to install something globally. All right, now that we have that installed, we're going to fire up Node Inspector. And we're going to come down here and we're going to highlight the URL. And if you're on Windows, just come up under Edit and you can click Copy. And then we'll jump over to our web browser here. Now you have to use Google Chrome for Node Inspector. So I'll paste that into there. Now that we have our Node Inspector loaded up, we're going to switch back over to Visual Studio Code. We're going to fire up a new console window. And we're going to say node --debug -break index. And now we're going to have our debugger listening on 5858, and we're going to jump over back to Chrome, and we're going to reload our web page. And we're going to see that now we have our code loaded up. So we're going to come into first module, and let's take a look at what we see. you're going to see this is that wrapper function. There's the exports, the require, module, double underscore file name, and double underscore dir name. So you can see when our code actually runs, it's actually wrapped in this wrapper function. So when we were referencing module.exports earlier, or if you were to say require to bring in other modules into your module, or you use file name or dir name, none of those things were global variables. They weren't just magically showing up. They were actually coming from this wrapper function and being passed in when CommonJS was actually loading up your module and then executing it. So there you go. And we're going to go ahead and let that run all the way through. I'm going to close out our node inspector. And what we're going to do next is I want to quickly show you this thing about exports. So if we come over here to our first module, you might have asked yourself, okay, well, why did we have module.exports here? Why not just put exports? So if we come in here and just say exports like that, how come that doesn't work? Well, if we come into here and we actually go to run this code now, so we'll just say node index, you're going to see we get an error. And the problem is it says put is not a function. Now if I come back over here and I say module.exports is equal to that object, and I run my code, everything works fine. The problem is that when the page first loads up, basically they say they have code behind the scenes that's saying exports equal to module.exports. And then module.exports is what's actually being exported. And so if you want to save a little bit of typing, you could come in here and say exports.put, and then you could have your function, so on and so forth, and that would work fine. But the moment you reassign this variable exports to a brand new object, like we did a second ago, where we had this, now exports and module.exports no longer point at the same thing, which means that when the module actually returns the exported object, it's not going to be returning what exports points to, it's going to be returning what module.exports points to. So I always recommend just use module.exports. That way you never have to wonder if somewhere else in the code if module.exports is being reassigned to something. And that way too, if you want to work with a nice fresh clean object in terms of setting up your modules, you can do that with this by using module.exports. Alright, ES2015 modules. This is the first official module system for JavaScript. Unfortunately, it's not implemented in any of the JavaScript engines yet, but you can make use of it through a transpiler such as Babel, Tracer compiler, Rollup, as well as TypeScript. This module system was actually inspired by AMD and CommonJS. It's similar to both, but also different in the sense that both of those are dynamic loading module systems as opposed to this one, which is a static loading module system. The destructuring we did earlier with our CommonJS stuff can also be done in ES2015. In ES2015, the term isn't really called destructuring, it's just part of the importing mechanism, but you can kind of think of it as destructuring. The advantage to destructuring in ES2015 modules, and this benefit does not exist in CommonJS, but the benefit to destructuring, if you want to call it that in ES2015, is because of something called tree shaking. And what this means is that basically JavaScript can be super smart and identify which actual parts of a module we're importing, and then based upon the actual parts that we're importing, eliminate code by shaking the tree and seeing what falls out, taking our code and eliminating the pieces of code that aren't needed for the parts that we're not importing. The ultimate advantage of this is resulting in less source code, smaller amount of size of source code to distribute, a whole bunch of benefits here. But that's the concept behind the ES2015 modules, is the ability to have this destructuring mechanism built into it to selectively identify what it is you want to import. Now, in order to work with this though, we're going to have to set up a transpiler. As I said, this doesn't actually work in any of the actual JavaScript engines at the moment. So we're going to take a look at Babel. Babel is an extremely popular transpiler, and we're going to use it to do our transpilation from ES2015 code to ES5.1. We're actually just going to transpile all the ES2015 code, not just the module stuff. Now, Babel is an extensible tool. It has a plugin architecture, and so you can use it to transpile many things to JavaScript, not just ES2015 code. You can do things like JSX, RelayQL, and such. Babel can be used through the JavaScript task runners like Grunt and Gulp, but it can also be used with other command line programs like Webpack. In this case, we're going to just simply use Babel to do our conversion of ES2015 modules to common JS. TypeScript, though, is also another great tool, and I kind of throw TypeScript out there as a separate thing from things like Rollup, only because TypeScript basically also introduces strong typing in the JavaScript. And in certain development spaces, it's becoming a very popular tool for basically doing enterprise JavaScript development because of the strong typing nature that it provides in addition to the ES2015 transpilation. By the way, TypeScript also works for JSX for any of you React programmers out there. So let's take a look at how we can set up Babel locally to do our transpilation. Let's take a look at how to set up ES2015 modules with Babel. This first little demo will just be the actual setting up of Babel to do the transpilation from ES2015 back down to ES5. So we're going to create a folder here. We'll say ES2015. We're going to change into that folder now. There we go. And we're going to need to install some Node packages in order for this to work. So we're going to say npm I, and then we're going to install Babel CLI and Babel preset ES2015. And so we'll install these two packages, and this is going to give us the Babel command line tool for actually doing the transpiling, and then the Babel preset will have the preset configuration for the ES2015 stuff, which includes the module support. Okay, excellent. Our install has completed. We'll go ahead now and open up Visual Studio Code, and we're going to open up that folder. So we'll grab ES2015. There we go. So here's our ES2015 folder. We're going to create two folders in here, one called source and then one called dist. There we go. The source folder is where we're actually going to do our typing. The dist folder will be the output from the transpilation process. So we'll come into source and we're going to create a new file, and we'll just call this index.js. And we'll make that a little bigger there. Okay, so what we're going to do is we're going to write a little bit of ES2015 code. Not any module stuff, but just some basic stuff so we can kind of see that the transpilation process is occurring properly. So we'll say constant, and we'll say test, and we'll make it equal to test. And we're going to save that. And now we want to run our Babel CLI. So we'll open up a command prompt here. And to run this is actually going to be located in our Node modules folder. So bin. And then we'll have Babel. And then inside of here, we're going to run some code to actually make this work. So we're going to say source. And then we're going to have ourselves an outdir, which is going to be dist. And then we're going to have ourselves some presets. And we'll set our presets to be equal to ES2015. And we'll hit enter. And then we can take a look at the dist folder to see if this was actually processed correctly. And you can see where this was transpiled to ES5 code. In ES5, there is no const keyword, so the transpilation just converts this to a var declaration. So now we have Babel up and running. We have our two packages installed, and then we were able to run our Babel command line program where we specified the source of our files, the output folder, and then which presets we wanted to have loaded to complete the transpilation process. All right, so in order to use ES2015 modules, we have to have one module that exports something and one module that imports something. So let's take a look at the code that we have here. We have this class B, which is basically going to be exported, and it has a doit function property on it. And if you look over on the left, you can see where we're actually importing B, and so we say import B from ./B. Now you'll see where we actually have the letter B in caps right there between the curly braces. The purpose of that is to say that there could be many things being exported from that module, not just export class B. You could have as many exports as you want. But what we're telling it is only actually import class B from the B file so that we can then make use of it here by newing up a new instance of B and then calling the doIt function. Now you'll notice in our from syntax we actually have ./b. That's actually looking for a b.js file in the same folder as wherever we're importing this thing into. And so you typically leave off the JS extension. And that's true for all the other implementations of working with modules. For example, in CommonJS, when you're pulling in a module, you leave off the JS extension. If you're working with TypeScript and you're importing a module, you typically leave off the TS extension. The extensions are assumed to be, the standard extensions you would find on a file. So let's take a look at how to build our first ES2015 module. So let's take a look at how to build our very first ES2015 module. So we're going to come under source here and we're going to create a new file and we're going to create a little widgets module. So we'll say widgets.js. And then inside of widgets here, we're going to put in some functionality. For example, we are going to throw it at the top. We'll have our useStrict. And then we're going to set up a list of widgets. So we'll have const widgets, and we'll just make it an array. And then we're going to export out two functions. We're going to export out a function to add a widget, as well as a function to retrieve all the widgets. So we'll say export const, and then we'll say get all. And we'll actually set this up as an arrow function. And we'll simply say return widgets. Now we could actually shorten this down if we wanted to. We don't actually have to put the curly braces in the return. If we wanted to be super slick, we could come up into here and simply just have this and have that actually be our function. And then we could do something similar here for adding a widget. So we'll say const add. And then we'll come into here and we'll say new widget. And then for this, we'll just simply say widgets.push new widget. There we go. You can see with the ES2015 syntax, things have gotten a whole lot shorter in terms of the amount of code you have to write to actually accomplish something. So now we have the widgets here, which is an empty array, and then we can get all of the widgets, or we can actually add a widget. So now that we have that, we need to actually pull this into index. So to import this, we're going to say import, and then we can bring in different things from our module. So for example, we could say get all, and then we could also bring in add widget. All right, and in fact, we just called that add, so we'll just change that back to add, and then we can say widgets like that. So now we're using the ES2015 syntax, and we're bringing in these two methods. So then we'll simply come into here, and we're going to say add, and then we'll add a new widget. So we'll just do name, first widget, color, red, and then size, we'll say large. There we go. And then we could simply call get all, and that'll return back all the widgets to us. And I'll come into here and we'll just do console.log get all.length, and that'll tell us how many widgets we actually have. So we'll save our code there, and we're going to come down here to Babel, and we're going to transpile this. So we'll run it, and you can see where it's going to output index and widgets. So let's close that and close this, and close that, and come into index here. And you can see where we have our widgets file being transpiled. Let's see here with our, I made a huge mistake. I edited the wrong index file. I'm actually going to leave this in the video to make a very strong point. Be very careful about which file you edit. And a lot of times what I'll do is I always mark my dist folder as basically git ignore. So depending upon the editor I'm using, sometimes the dist folder will be grayed out. Other times I'll actually configure Visual Studio Code to actually remove the dist folder from being displayed. But be very careful you do not edit the wrong file, because when the transpilation runs, if you edited the output file, then you're going to lose all the code you just wrote. So fortunately, it's not that much code. We can just come back into here and we'll just write it again real quick. We now have our console log get all length. We're adding our widget to the list of widgets, and then we're importing our get all and our add methods. So now we'll come back down to our terminal and we'll run Babel again. And now we come back up to here, we can see where we've now exported this. So notice how this thing has actually transpiled it. It's actually taken the import statement and changed it to a require. And then down here, it's invoking our function and then outputting our length here. And if we jump over to widgets, you see where it's actually setting up our module for being exported. So we have our exports.getAll, exports.add, and if we come down here and run this, and let's see here, we'll say node, and then we'll do dist index, and you can see we have one widget has been added to our array of widgets stored inside of our module. Now, we also have the ability to export a default value or object. This is not commonly done. There are existing modules and stuff from the past which will make use of this, but in terms of code that we code, this is something you want to stay away from. While it's definitely convenient to have a default export, if you take a look at our code there, we just have to say import B from B. If you have default values, A, it limits what you can actually export back, and B, you don't really have a way to identify the parts of B that you actually want imported into your code, which ultimately will then mean you can't take advantage of the whole tree shaking thing. And it's a lot clearer if you actually do import the specific things that you want as opposed to just importing everything. Nevertheless, here's the code, and you can actually export something that's a default, and then you simply just remove the curly braces around the B, and now it'll give you the default object or value coming out of the module that you're importing. So let's take a quick look at how default exports work. So let's take a quick look here at how we can export a default value from our module. So we're going to come over here to our widgets, and what we're going to do is, instead of actually exporting two different things, we're going to set this up as a single object. So we'll say export default, and then we're going to export an actual object out of here. So we'll grab our, and we'll pop that down into there, and then we'll come into here, and we'll also do our add as well. There we go. Okay, so we're going to export out the getAll function as well as the add function using this here, and I'm going to come up to here and actually comment these out so we don't have any confusion. You don't actually have to comment them, but we'll go ahead and we'll just comment them now so we can have our single default. And then we're going to come into index here, and instead of importing getAll and add separately, we're going to just import something called widgets. And then we'll take widgets here, and we'll say widgets.add, and then widgets.getAll. So now we have our default export, and we've set it up as our default here. And then we're going to put widgets in front of this since we're no longer exporting out the individual members. And now we'll come down here and run our Babel transpiler. Ah, looks, we have an error. So if Babel goes to transpile your code and there's an actual error in it, that'll come back and tell you what that error is. That can actually be incredibly useful when trying to work through source code issues. So come into here, we'll get rid of the equal sign. We'll save that. We'll run Babel again. Everything outputted correctly. And if we go and run our node index now, let's see. I ran node index, but really I want to run node dist /index. And there we go. There's our one widget. So if we go in here, we can take a quick look at the actual file structure here. So now it's just exports.default. And so what happens is inside of index now, you actually say widgets2, it'll say widgets2.default. So all the default really does is just set up a default property off of the object that require is going to return. As I mentioned a few moments ago, we can export multiple things. So if you take a look here on the right, we have our export class B and export class C. Those are in the same file, right? So we have one module that's exporting two different classes. Well, when we go to import it, we can simply say import curly brace B comma C, and we can pull in what we want. If we only wanted C, we could get rid of B. If we only wanted B, we could get rid of C. But we only have to selectively import what we want to. And then so tree shaking could come in and say, hey, oh, you didn't import B. So when we actually put together all the JavaScript files, we'll leave B out of the final executable code because you didn't import it, so you weren't using it. Now, another important thing to do with importing is actually to do aliasing. What if, for example, the thing that we're importing actually has the same name as something that already exists in our code? Do we have the ability to alias it? Yes, we do. If you take a look here, we have export class B do it. And what we're going to do is we're going to import B, but we're going to import it as D. So we're going to alias it as a D object. That's, what if we already had another B already being used in our code? Now we could alias it as something else and then make use of it that way. So let's take a look at how we can alias imported values and objects. So let's take a quick look at how we can do aliasing with ES2015 module importing. So coming back in here to our widgets, we're actually going to turn off the default export, and we're going to turn back on exporting the individual functions there. And we're going to come over to our index file, and we'll comment out this and pull that out. There we go. So now what we can do is we can actually come in here and we can do the aliasing like we did with the common JS aliasing. So we'll come into here and we'll just create a function. We'll say get all, and instead of a colon, it's actually an as, and I'll just say get all fn. And then we'll come into here and say add widget, and we'll save that. And so here we have the as. So in order to make the destructuring work for the common JS, it was a colon. To make the destructuring work with the ES2015 module syntax, it's the as. Now remember, this isn't really destructuring. This is not official destructuring as per the destructuring section of the JavaScript spec, but it does behave very similar to it. And so we have get all and get all fn, and then add, and then as add widget. So we'll come into here and we'll modify this code, and we'll change add to be add widget, and we'll just change get all to be get all fn. So now if we save that, you can see that we're going to be able to run both of these functions. Before we do that, we have to make sure we actually run Babel. Then we can run our code, and then we can see that one has been added again. So remember, the alias is useful if in the event that you already have a variable named whatever the name of the property is that's coming in from the import, so you can rename it so that you don't have a variable name collision. As you've seen, Node.js applications can be divided up into modules, with each file of the application serving as a module. The built-in module format for Node is CommonJS. The latest module format with ES2015 is not actually available because none of the actual JavaScript engines implement it, but we can still use it if we make use of a transpiler like Babel or TypeScript to actually compile out that module to the CommonJS module format, which then can be understood by Node. Modules are singleton objects, as we saw. We can kind of create a configurable module, if you remember the pattern that we came up with in CommonJS for creating configurable modules, and basically you can do that by creating a module that's a function object, and then when you import that function object or require that function object, then you can simply invoke it with a configuration object and then configure it. But remember, the singleton module is the function object itself, not the object produced by invoking that function object. Finally, there's lots of cool ways in which we can control what actually gets imported into our modules through the use of destructuring and aliasing. In this course, we're going to take a look at how to work with files, streams, and buffers with Node.js. My name is Eric Green, and this course is brought to you by Wintellect Now. So here's a little overview. We're going to talk about how to get started with files, streams, and buffers. We're then going to talk about a course project. It's not going to be anything too complicated, but we're going to set up a little simple web server using the HTTP module combined with the file, streams, and buffers to serve up some files, to compress our responses, to actually read post data, request body data from post requests, all types of good stuff like that. As part of that, we're going to learn about how to read and write to and from files. We're going to understand how buffers work. We're going to take a look at some file system tasks. We're going to talk about using streams, and then finally we'll wrap things up with a conclusion. There are some prereqs for the course. This course is going to assume that you have a good working knowledge of JavaScript, also that you have a good working knowledge of Node.js and CommonJS modules. To actually be able to run the examples and demonstrations from the course, you will need to make sure that you have Node.js installed on your machine. You can download it from nodejs.org. It is cross-platform. It will work on Windows, Mac, as well as Linux. Also, make sure you have version 6 or later to ensure that these examples actually work correctly on your machine. Finally, if you need a quick refresher on these technologies, don't hesitate to go watch the Wintellect Now courses on Introduction to Node.js and Node.js modules. So, file streams and buffers. So JavaScript with Node basically allows you a lot greater access to the system on which you're running. When you use JavaScript in the web browser, it's a very sandboxed environment. You don't really have access to the file system or the process or other interesting things like that. Instead, you have very limited access, and mostly what you have access to is just the actual capabilities of the web browser itself. But with Node, we're talking about basically doing server-side JavaScript programming. And as a part of server-side JavaScript programming, you have to have the ability to work with files or to read process information or work with binary data or be able to stream data in and stream data out. And so Node provides a number of APIs for us to work with to provide all of these different capabilities to us. Now, we have to understand something about JavaScript. When we talk about reading and writing a file off of your hard drive, we're not actually saying that JavaScript itself actually does that, because it doesn't. Instead, Node provides a set of C++ modules, which it makes available through an API to our JavaScript program. So what does that mean? That means JavaScript doesn't actually interact with these system resources. Instead, JavaScript simply calls the Node API, and then Node runs its C++ code to actually do all this stuff for us. Now this is really important because JavaScript is a single-threaded language. And since it's a single-threaded language, it only does one thing at a time, which means that if JavaScript itself was actually the thing interacting with these resources, we'd have a real problem. We'd have a lot of situations, a lot of times when our program code would be blocked waiting for these system resources to respond. Instead, by using the Node API and the C++ modules provided by Node, C++ is a multi-threaded language, and all of those modules are pretty much coded in a multi-threaded fashion. So they can go off and do a bunch of work to retrieve these various resources for us, while JavaScript can continue moving on to the next task while it waits for some type of callback mechanism from the Node API saying, hey, I have your information, here you go. And so it really results in a much more efficient processing of JavaScript code and being able to interact with these various resources. At the end of the day, when we say Node.js, what we really mean are a collection of C++ modules. V8, which is the JavaScript engine, is just one part of Node. Node itself is really an actual C++ API made available to our JavaScript code. So for our course project here, we're going to go through and do some basic examples, and then we're going to take those basic examples and translate that into something practical and interesting in terms of working with files, buffers, and streams. So we're going to code up a little web server. Now, typically when you create a web application in Node, you use something like Express. And Express is what actually goes out and handles your requests and handles your routing and figures out what to do with the data. And there's a bunch of other middleware modules that can, actually process your request body data, like a body parser, that kind of thing. And while all of that is awesome, and I highly recommend you use it when you're actually building real apps, what we're going to do here is we're going to write all of that stuff ourselves. And we're actually going to utilize files, streams, and buffers to do that here in our Node application. So we're going to use the basic HTTP module and then extend it out to basically work with all these different kinds of data and do logging and such. So we're going to set it up so it'll handle requests for files from the file system. So if you request index.html or about.html, it'll pull the right file. We're going to log interactions. So we're actually going to write data out to a log file in the file system. We're going to use buffers to work with the HTTP post data via a stream. We're going to rotate our log files. Now, we're going to have to kind of fake this because we're not really going to be like, having log files over multiple days. But we'll set up a little bit of a mechanism to where we can rename the file and create a new one, that kind of thing, and demonstrate some of the file system operations. And then finally, we're going to set up our HTTP responses to basically be compressed. So we're going to take our HTTP response data and pass it through the zlib library and gzip it using streams. And we can take a look at how those are beneficial to us. Now, there are two main Node.js modules for working with files. They are the path module and the fs module. The path module basically gives you a bunch of library code to work with file and folder paths on different operating systems, so basically POSIX and Windows. And then the file system gives you the ability to actually create files, write to files, work with folders, that kind of thing. So let's go ahead and do our first little demonstration. We're going to get our little course project set up. It's not too complex, but it'll give us something to get started with as we build out our application.
So to get this project set up, I have a GitHub repo that has some starter files for us to work with. I'm going to come over here and copy the link for the GitHub repo. We're going to do HTTPS. I'm going to copy that. I'm going to open up my console. I'm going to change to Git, Intellect now, and then we're going to git clone this to our folder, and we'll let that clone in there. Excellent. Now I'm going to come down here to Visual Studio Code, and we're going to open up this folder, and we'll select that. And let's take a look at our files here. Inside of here we have a web.js file. This is actually going to be the web server project that we're going to be coding. Make that a little bigger. And so we're going to be coming in and basically filling in all of these little blanks where we have comments. So for example, demo 1 will be including the path and file system modules. And demo 2 is going to be using the path functions to create a requested file name. Now, over here in our ww folder, we actually have an index.html file that has a simple form, and in one of the later demos, we're going to be posting the contents of this form up to the server and actually processing it. So to get started, let's come over to our web.js file, and we are going to go ahead and import the path and file system modules. So we'll say const path equal to require path, and then const fs equal to require fs. So to get started with the basic file system operations, these are the two modules that you'll usually want to work with. The path is used to work with path operations, and the file system allows you to actually interact with the file system to read and write files and make other file system changes.
So working with paths, this is a really, really important thing, because when we write Node.js applications, we're writing cross-platform programs. These things could be running on Linux, they could be running on Mac, they could be running on Windows. Node is definitely a cross-operating system programming platform. And so we have to make sure that we understand how those file systems work and then take those into account when writing our code. Now, to help us with that, the path module actually provides us a bunch of very useful functions which kind of hide some of these internal details from us. For example, if we want to get the directory or the folder portion of a path, we can use dir name. And so when I use the word folder, it means the same thing as directory, and directory means the same thing as folder. Base name will return the file name portion of the path, or ext name will return the extension portion. We can use format to actually format our file names. Whenever we have a multiple path segments we want to put together, we can use the join function to help us with that. If we ever have paths that have a bunch of dots or dots so that you either reference the current folder or go to a parent folder and then a child off the parent, Normalize will actually resolve all of those dot and dot segments to give you a normal path. And then finally, we can use parse, which is going to actually give us back an object with all of the various component parts of a path broken up. So let's take a quick look here at how the path module works.
So let's take a look at how we can actually extract the requested file name using the path functions from the URL. Now, typically when a URL request is made, the part of the URL after the domain name and the port is typically mapped to some type of file like an index.html or an image or a CSS file. And so what we have to do is extract that part of the URL out and then actually find that file on the file system. So to do that, we first need to figure out what the path of that file is going to be, and we can use the path functions to do that. So the first thing we're going to do is we need to extract out the actual directory name. So I'm going to come in here and define a new variable called dirname, and I'm going to say path.dirname, and then I'm going to pass in my request.url, actually my request.path. Okay, so from this request.path, I'll be able to get the directory name, but I'm going to have a problem. With certain URL requests, I'm actually going to end up with an extra / at the end of the directory name. And later on, this is going to be a problem when actually trying to format out my entire path. So what I'm going to do is I'm going to check to see if I have that trailing /. So I'm going to say if dirname ends with, and then I'm going to do a /. Then all I simply want to do is slice that thing off. So I'll say dirname dot slice 0, dirname dot length -1. And so that will actually slice off any trailing / on my directory name. The next step is to actually create my requested file name. So I'm going to say const request file name equal to path, and we're going to use the format function here. The format function is going to allow us to basically specify a directory as well as the name of the file and actually produce an actual file name for us to work with. So we'll come into here and I'm going to say dir, and then I'm going to say path.join. And what does path.join do? That basically takes different segments of our path and joins them together as part of one larger path. Of course, taking into account the proper separator for the file system that we're on. So for example, if we're on Windows like we are here, our path separator is a \. But if we happen to be on Linux or Mac, then our path separator would be a /. So the first thing we're going to specify is dirname. Dirname is a special variable available inside of Node modules that basically represents the path of where our file is located. And since our www folder is actually relative to our web.js file, we can use dirname to basically get that full path. Then we're going to specify the www folder, as that's the child folder from which we're going to be loading up our files. And then the last step is actually to specify our dir name. And this will actually give us the directory path of where that file is located under www. Next, we're going to come in and we're going to set our actual file name here. So we're going to say base, and then we're going to say path.basename. And this is actually going to extract the file name from our path. So we'll say request.path. And there we go. And so to actually test this out, we're not actually loading the file yet off the file system, but to test this out, we'll just say console.log request file name. And so once we've done that, we can now actually start up our web server, load up our web page, and take a look at the results. So I'm going to open up the console here in Visual Studio Code, and we're going to say node web, and there's our web server. And then we're going to come over to Chrome, and we'll reload our page here. In fact, we'll load up just plain old 3000. You can see there's our hello world. And if we come back over here to Visual Studio Code, you'll see there's the actual path to our file. So we have index.html and then of course favicon. For our little web server, we're just going to ignore the favicon request. but that index.html is going to represent that default file. Why? Because we wrote some code up here on line 23 that properly handles the default file if no file is actually specified in the URL. Now if we go back to our web server and we actually come in here and say, for example, index.htm with no L at the end, now we have an actual path. And so if we come over to here, back to our output, you'll see we have index.htm, but we have the full proper file path to our actual file. So now we have the ability to actually go read our file with this new path to it. So reading a file. With Node.js, you can read both text and binary files. Node provides two very convenient functions for this. You can either open a file and read it chunk by chunk, or you can read the entire file at once. Now, because JavaScript is single-threaded and these C++ modules are multi-threaded, the default behavior for all of these file system interactions is to be asynchronous. That way, JavaScript is not blocked and it can continue processing additional tasks while the file system operations are being accomplished. All that being said, pretty much all of these file system functions have a corresponding synchronous version. So for example, if you don't want to read the whole file asynchronously, instead of using the read file function, you would use the read file sync function. So you never have to worry about unintentionally synchronously working with data. The default is always asynchronous. In fact, you have to specify the word sync if you specifically want to make it synchronous. And we'll talk a little bit later about when it's okay to do that. But as a general rule, get used to asynchronous programming. That's what JavaScript and specifically working in Node is all about. So let's talk about reading a file chunk by chunk. This is not used as much as the read the entire file. Read the entire file, which we'll take a look at here in a second, grabs it all and then it makes it available to you. When you read a file chunk by chunk, you're basically going to be reading it based upon a certain number of bytes. So it could be 1 byte at a time, it could be 100 bytes at a time, whatever it is you want to set it up to do. But in order to do that, you first have to actually open a file, which is going to return a file descriptor. This is very similar to other programming languages you've worked with in the past. You open the file, and then once you open it, then you can take that descriptor and then go do various operations. Now, when you open the file, you have to signify what mode you want to do it in. Or you want to read, write, append, what have you. Since we're talking about reading right now, we'll set the mode to R because we're actually going to be reading the file. So once it's opened, you take that file descriptor and you pass it to the read function. And you're also going to pass a buffer into the read function, and it's going to be populated with data from the file. Now, buffers have a fixed size. So when you create a buffer, you have to say, oh, I want it to be 10 bytes big or 100 bytes big. And whatever that size of the buffer is, the read operation is going to read in that data into the buffer. And then it'll also give you back the number of bytes that were actually read. And so when you read stuff chunk by chunk, it's basically calling that read operation over and over again until the number of bytes read is basically set to 0, okay? Or is less than the size of your buffer, which means you've hit the end of the file. When you're reading stuff, you can specify the starting position of the read, or it can use the current file position. So, for example, if you're just iterating like through a loop or something, and you're just reading in all the bytes, then the current file position will move after each read. But let's say you want to go specifically to the middle of the file. You can actually specify the position. So I find that reading chunk by chunk is incredibly useful if I want to go to a specific part of the file and just read that one small part. Or I have some type of data processing that I want to do, a little bit at a time, and I don't want to read the entire file. Let's say it's a really huge file, and I want to do a little bit of processing and then read some more. That reading chunk by chunk is very helpful for that. Once you're done reading your file chunk by chunk, you have to make sure to close the file. Read file is going to close it for us when we read the entire file, but when we read chunk by chunk, because we use the open command, we have to explicitly call close to make sure that we close our file. Now we're on to reading an entire file. This one I use all the time. So reading an entire file is much simpler. You don't have to deal with the whole chunk by chunk process, as you saw from the slightly complicated code we looked at a few minutes ago. Instead, when you're reading the whole file, you have to specify what the encoding is, and then basically read file is going to return back to you that content formatted to that specified encoding. And you can actually just give it a string file name to actually open the file. You don't have to give it a descriptor.
But if you do give it a descriptor, make sure that you close the file later on, because refile will not automatically close that for you. So let's take a look at a demonstration of reading an entire file.
So now that we have our file name, let's go ahead and use the file system operation read file to actually read the file and send the content back to the requester. So we're going to come down here and we're going to go ahead and set this thing up to actually read the file. So we'll say fs read file, and then we have our request file name, and then we'll specify our character encoding, which is going to be UTF-8. And then we're going to have a callback function, and we're going to use the new ES2015 arrow syntax for that. We'll have two parameters. We're going to have an error object, so if that object is basically not null, then an error occurred. And we're going to have the actual file data that's returned from the read file operation. So now we need to set this thing up to basically handle an error, but also be able to send back the file data. So we're going to say if error. Then what we're going to do is we'll come up here and we'll copy this code here. There we go. And if there's an error, we'll just assume it's a file not found error. And we'll say 404, and then we'll just end. In addition to that, we'll actually write out the error to the console. So we'll say console.error, error. And then, of course, we'll want to come in here and return out of the function. Now, if everything works as expected, instead of actually returning out, we're going to want to send this data down to the requester. So once again, we'll just copy this code right here. And we're going to take our file data, and we'll actually come in here and just say response.end, and then we'll change this to a 200. Now, of course, if we were working with other types of data like image data, what have you, we would definitely want to set additional headers indicating the type of file. But for our purposes, we're just trying to demonstrate how to read a file off the how to read a file off of the file system. So for our purposes, just sending back the data will work perfect for us. So now that we have that, we'll go ahead and open up a terminal window, and we'll fire up our web server once again. So we'll say node web, and our web server has started. And then we'll come over to our browser window, and we will actually just go to port 3000, hit enter. We're still getting our hello world, so let's go back to our code. If we scroll up to the top here, we have our original hello world output. So let's actually save that, and let's move this down to here as well. So we'll go ahead and call resolve here at the end. Okay, perfect. Now let's go ahead and try this again. And let's reopen up our Node Web, come back over to our web browser, reload our page. There's our web page. So now we have our actual form has been downloaded. So to recap, literally all we had to do was come into here and specify our file name, specify the character encoding, and then we received back our file data, and then we simply responded with that file data to the requester, and the web page was in fact loaded. Now, let's say we actually came into here and specified a file that didn't exist, like index.htm. You'll see we get no data comes back, and if we actually come under our developer tools, and we'll go to developer tools right there, and let's go ahead and move these down here. Go to the network, reload again, and you'll see there's our 404 error for properly handling our error situation.
Writing to a file is very similar to reading, except that you specify some content to actually be written. Binary and text data can both be written to a file. We have the same corresponding functions here. We have open and write, and then write file. You can basically use open and write to write chunk by chunk, or you can simply use write file to write the entire file at once. When we talk about writing files, you can actually open up files in a read-write mode. You can open up files to simply be overwritten. You can also open up files to be appended to. And just as with and read file operations, there are asynchronous and synchronous versions, with the synchronous versions both ending in sync. So when you do this, you're going to open up a file, which will give you back a file descriptor. We're going to use the mode W to signify that we're going to open the file for writing. If the file does not exist, it will be created, and if it does exist, then it's going to be overwritten. Now, once it's open, we're going to pass that file descriptor to the write function, and then finally we'll pass in a string or buffer, and then that content will actually be written at the specified position. And if no position specified, then the data will be written at whatever the current position is. If you just open the file, the current position is at the beginning. If you've had multiple write operations, then the current position will be wherever that last write operation ended. Now we come to writing an entire file. Just like reading an entire file, this is much easier. You basically just specify a file name, you specify your string or buffer, you specify what the encoding is, and write file just outputs the data to the file, and you're done. Now, if you decide to use a file descriptor, just like read file, it does not close the file after it does the operation, so you want to make sure that you do that.
In addition to just simply reading and writing to a file, we can also append to a file. Typically, when a file is written to, that file is actually truncated, which basically just means that all the contents are removed and it's overwritten with new content. But sometimes we actually want to just add to a file, such as logging, that kind of thing. So instead of overwriting content, we can simply do append file or append file sync. And append file is going to allow us to add new content at the end of an existing file. Now, append file and append file sync behave exactly like write file and read file do. So it's the exact same pattern. Pass in the content that you want to write, and then you have a callback function where you can check for an error to see if something went wrong during the writing process. Now, you can also use the open function to open up a file for appending, and you just use the mode A, and when you do that, you'll be able to append to a file. We'll take a look at append file in our project code for actually writing out to log files. So let's do a demonstration and take a look at how we can append to a file by appending to the log file of our web server application. So let's take a look at how we can set up a log file for our web server. Now, with a log file, we're going to want to append each entry to the previous entry that was already there. So we're not looking at basically wiping away the whole file on every single write. Instead, we want to add to the file. So instead of using write file, we're going to use append file. So what we're going to do is we're going to set up a couple of functions here. We're going to have one function that kind of does the logging, and then we'll have another function or two that will actually be more specific for like error logging versus info logging. And once again, we're going to use the nice, neat, convenient ES2015 arrow functions in order to set this up. And it'll actually just be a few lines of code as opposed to a whole bunch of lines of code. So we're going to say const, and we're going to say log. And then what we're going to do is we're going to have entry. That'll be the actual thing that we want to log to the file. So then we'll put our actual arrow function operator there. And we're going to say fs.append file. Now the name of our log file is actually defined up here already. We have that as a defined constant, so we'll copy that. And we're going to paste that into there. And then we're going to actually specify what it is we actually want to log. So we're going to take this entry right here. And what we're going to do is we'll just come into here and we're going to do the new template string syntax. And we'll say $, and then we're going to paste in our entry, and then we'll put a new line here at the end. And then we'll come into here and we're going to specify the encoding. So we'll say UTF-8. Now, you'll notice I'm not putting a callback function in here. If I wanted to, I could put a callback function in here and we could check for the error, so on and so forth, like we did with the read file. The reason I'm not doing that is with logging, if the actual logging fails, there's not really a whole lot we can do to recover from that. It's not like you can log to the failed logger. So we're just going to allow it to silently fail, and for our purposes that'll be more than sufficient. So we're going to intentionally allow it to silently fail. So remember, if you don't include callback functions for your asynchronous operations, if they fail, you won't know. Now, I'm going to come into here and set up an error version of this as well as an info version of this. And the way this is going to work is that we're still going to pass in our entry, but then I'm actually going to call log, but I'm going to prefix this with actually saying error. So we'll come in and we'll say error, and then I'm going to say $entry, and that will be what's actually sent to the logger. And we're going to do the same thing here for info. So we'll have const info, and then over here we'll simply change our error prefix to be info. So now we have a simple logger here, but we can also be specific with an error or informational logging right here. And what we're going to do is we're going to set this up so that when we get a request into our web server, if there's an error, it outputs the error to the logger. If there is a successful request, then we'll just output the info. So we're going to come down here, and we're going to change this console log error to simply just be error. And then down here, we'll go ahead and say info. And then we'll once again use our new template strings. We're going to say request.method, and we'll put a space, and then we'll say request.original URL. And there we go. So now we have the ability to actually log our requests that come in, both successful and error ones. And let's go ahead and open up our terminal here, and we'll restart our web server once again. And we'll come over to here, and we are going to load up our web page. So let's go ahead and say localhost 3000. There's our web page loaded up. So let's come over to Visual Studio Code, and you'll see there's a web log, and you can see we have our info get. And the reason for the second get request is because of the favicon. So now if we come back over to here and we say index.html and hit enter, we get the same web page again. And if we come back over to our log file, let's see, we have an error being logged. Couldn't find index.htm, but it did find our index.html. And so now if we come back over to here and we just simply say HTML, now if we come back over to here, you can see now we get our error again. So it looks like Chrome is making a couple of extra requests for us on these other loads over here, which is why we're getting the extra error log entry. But if we come back over to here and then make the request again, now we get our web page. And if we come back to our logger, there's our index.html. So everything appears to be working as expected. We are properly handling errors, and we are logging successful requests.
So the question becomes asynchronous or synchronous. For folks who come from a Java, C#, C++ background, most of the code that you write is synchronous. What does that mean? That means, for example, if you connect to a database, you open the connection, your code waits for the connection to be established, then you issue a query, you wait for the results from the query, and then when you get the results back, you do something with it. But during those time periods where the database is either setting up the connection or processing the query request, your code is basically blocked. It's not doing anything. Now, with Java or C# or C++, this isn't a big deal because if you have multiple requests, for example, coming into your web server to run that database code, then other requests can be handled because it's multi-threaded. Other requests can be handled while your code waits. Unfortunately, in JavaScript, it doesn't work like that. In JavaScript, it would actually stop the one thread of JavaScript from executing and continuing on to the next task until that database operation was complete, which means that your server could really never handle more than one user at a time. Otherwise, everybody else would just be waiting for every other user to finish their database operations. And that, of course, would not be very efficient. So as a general rule, all of your code that accesses any type of resource should always be written in an asynchronous manner. That way you don't have this blocking mechanism. Now, there is one exception to this. It is okay to use synchronous file access if the file you're loading up is like an initial configuration file right at the start of the program. So basically before the users start interacting with it, and you're just doing that initial load and loading up that initial configuration, then it's okay to do a synchronous type of process, because you're not going to be having multiple users competing for access to that thread. Instead, you have to just go through and do your setup operation before you can start serving anybody. And so synchronous file access can be useful for that. But for everything else, it's got to be asynchronous, or your Node application will not scale at all. So file existence is kind of interesting. If you were to write a program in C#, for example, and you said, hey, I want to read a file off of the file system, you would probably write some code first to see if the file existed. And then if it did exist, then you'd go ahead and open it and try to use it. Well, this is kind of problematic for Node. It can be problematic for C# too, but it's especially problematic for Node. See, the problem is that when you go to check the existence of the file, it's going to run a callback function telling you whether or not it exists, which is great. The problem is that between the time you make the request, get the result of the callback function, then make the request, for example, to open the file, the status of the file could have completely changed. In JavaScript, because of the way the callback functions work, there's really no way to tie together the callback code from the initial existence check to the actual opening code, if that existence proves to be true. So instead, we have another way of doing it. We use the functions either stat or access if we just simply want to check existence. Now, if you go look through the Node API, you're going to find there is an actual exists and exists syncs function, but you'll also notice they're deprecated. And that's because you shouldn't use them. Instead, if you just simply need to know if the file exists, use stat or access, and in addition to telling you if it exists, it'll actually give you a whole bunch of additional information as well. So it's quite useful. So let's say that you did actually want to check to see if it existed and before you tried to open the file. That's considered an anti-pattern in Node.js. Instead, what you want to do is try to open the file, and then if the file opening fails for whatever reason, handle the error. That's the appropriate way to handle that. That way you don't have to worry about whether or not the file itself actually exists, or has it changed since you checked if it existed and 3 tasks before. Makes life a whole lot easier. Now, in addition to reading and writing files and getting file information, we can actually perform many file system tasks. We have the ability to create folders, create temporary folders. We can destroy those folders. We can read the contents. We can rename files and folders. We have the ability to watch for changes. This one's incredibly useful. People use this for development purposes all the time. Basically having Node programs using grunt or gulp that watch a file on the file system, and when the file changes, then running some type of process like transpiling Sass code to CSS or transpiling TypeScript to JavaScript. So there are some very useful functionalities available to you for doing file system types of operations. Also, a lot of the Unix file operations are available too. So for example, if you want to link or you want to change folder permissions, what have you, if the operating system that you're on supports that, you can make use of that functionality. So let's take a look at some of these file system tasks. We have make dir, which creates a folder, remove dir, which deletes a folder, rename, and that renames files and folders. Read dir can return back the contents of a folder. We also have watch and watch file. Now, watch is far better to use than watch file. Watch basically uses operating system specific functions to basically push a notification to Node that a file has changed. That is far better than watch file. Watch file actually does polling, which means from time to time in JavaScript, there's going to be a piece of code that checks to see if that file has changed. It's extremely inefficient, just conceptually, always checking that file polling. But it's also going to impact the performance of your Node program because it's going to be just another task running on that JavaScript thread. And when that task is running, it's blocking on other tasks that could be running in its place. So if your file system or operating system supports it, make sure you use the watch function and not the watch file. So let's do a quick little demonstration, take a look at some file system operations here.
One common feature of web servers is the ability for them to rotate their log files. Now, most web servers will rotate their log files either based upon the current date or based upon file size, what have you. Since we're not planning on writing out lots of log file data, and we're certainly not going to be recording this particular demonstration over multiple days, we have to come up with another criteria to do our log file rotation. So what we're going to do is every single time we start the web server, it will just automatically rotate the log file and basically take the last log file that was used and resave it under a new file name, and then start up a new log file based upon the weblog file name that we have here. And so what we're going to do is we're going to demonstrate some basic file system functionality. We're going to take a look at looking at the existence of a file, also how to rename files. We're also going to introduce some synchronous code into this process as well. Since this is going to be code that's going to be running when the web server first actually loads up, we don't actually have to deal with this in a asynchronous manner. We can actually deal with this in a synchronous manner. I know, right? Asynchronous and asynchronous, whatever, it all sounds the same. But basically, instead of it being asynchronous, it's going to be synchronous. So let's take a quick look here at how to do this. So the first thing we're going to do is we're actually going to do a try-catch block. So we'll say catch, and then we'll have our error. And then basically the way this is going to work is we're going to say fs.stat_sync, and then we're going to take our log file name right here. Now the way this is going to work is that if we try to actually get the file information about log file synchronously, then if the file is not there, it's actually going to throw a regular error in JavaScript. And so we're going to use our catch block down here to catch this. Now the only time we're going to actually get this error is that if there is not already a web log file in existence. So for that, all we're going to say is console.log, no file to rotate. And we'll actually say no log file to rotate to be a little more specific. So this is actually the ideal scenario. Basically, there's no log file. We can just create a new one and start rolling with it. But most of the time, we're going to have a log file because as long as you start the web server once, you're going to end up having a log file that's going to need rotating. So now we need to write some more complicated code to actually be able to do that process. So what we're going to want to do here is basically come up with a way to rename the log file. So what we're going to do is we're going to take a look at some functionality that will allow us to basically break apart this file name here so that we can basically produce file names that look like this. web_1.log, and then the next one, of course, would be web_2.log. And so we're going to write some code that's going to help us do this. And we're going to also be able to work with some more path functionality to actually see how we can use the path path module to be able to extract out the different parts of these file names. So we're going to use a function called path.parse. This will actually take our log file and actually give us basically the parts of our log file path back to us. And to make this really super cool, we're going to use ES2015 Destructuring. So we're going to say const, and then we're going to do our destructure operator here with our curly braces, and we're going to say name, and then we'll say file name, and then we're going to do extension, and we're going to say file extension, and then we're going to say path.parse log file. So basically, path.parse is going to return back an object that's going to have a name property and an ext property. We're going to take those and actually rename them to file name and file extension in terms of the variables that we're going to work with. That'll make our life a little bit easier and make it a little bit more clear about what name and ext stand for. Now the next thing we're going to do is we're going to come in here and we're going to set up a couple of variables. So the first one is going to be our counting mechanism. So we're going to say let I equal to 0. And then we're going to have another variable called next log file. And this is what we're going to use for actually basically testing out the next possible log file name to see if it actually exists. Now once again, we're going to follow a similar pattern here. We're going to set up another try block, and we're going to have a catch. And basically, we're going to know that the file name is available if it actually gets caught in this error. Otherwise, we have to keep looping looking for the next available file name.
So we're going to do a do-while loop. I don't actually do many do-while loops, but for this particular case, it'll actually work out really, really well. And so what we're going to do is we're going to come down here, and we are going to specify next log file, and then we're going to do our little backticks, and we're going to do our file name, and then we're going to have an underscore, and then we're going to have our I again, and then we're going to specify our extension. So we'll say file extension like that. There we go. And then what we're going to do is we're going to come into here and we're going to say fs.stat sync. And then we'll pass in our next log file. Now what's actually really slick about this is that if it actually finds the file, then it will return back an object, which will of course be a truthy value. So it will continue doing the loop. But if it actually fails, then it will actually throw the error, and then we can catch that error, and then we know that we have a file name that's not being used, and we can actually rename our file. And then we'll come in here and put our semicolon, and let's go ahead and write our rename code. So we're going to say fs rename, and then we can come into here and we're going to say log file, which is the original log file that we had, and we're going to say next log file like this. And then we could do this synchronously or asynchronously. It doesn't actually really matter all that much for our purposes. If we wanted to do this synchronously, we could say fs rename sync, make it sync to kind of keep it in line with our overall synchronous process here. And we're going to actually say log file, next log file, and then we'll just come down here and say console.log, log file was rotated. And there we go. So now we have our log file rotation. So let's go ahead and save that, and we'll open up our console again, and we'll start up our web server. There we go. Log file was rotated. You can now see that we have web_0.log. If we come over to our web page over here, we'll simply reload the web page. Then let's come back to our web server. We'll go ahead and kill it and restart it again. And if we take a look here, we'll notice that our web file index didn't actually increment, and let's take a look at why. If we come into here, we're actually going to notice that we never actually incremented I. So we keep looping through, but we never actually increment I. So what we'll do is we'll come into here and we're going to modify this code. We'll put our ++ here right in front. And let's save that, and let's go ahead and kill our web server here again. I'm going to come over here and just delete our web 0 and our web log, and we'll just move that to the recycle bin. Great. So let's start our web server again. So there's our web server, no log file to rotate. We'll come over here and just reload the page, make sure everything still works there. Awesome. So let's come back to Visual Studio Code. Let's kill our web server process, start it again. And now you'll see we have weblog1. And then we'll come back to our web browser and reload our page. Come back over to our terminal window. Let's kill it, start it again. And now we have web 2. So now we can see that our rotation process is now working as expected. So you can see you can do some really cool stuff here with the Node file system module, not just read and write files, but all types of other file manipulation operations. And in this case, we've built a log file rotator. Buffers. Buffers are used to hold binary data. They're created with a fixed size, and that size cannot be changed after it's created. But the buffers can be concatenated together or sliced to produce new buffers. So you can take buffers and slice them apart. You can put them together to build bigger buffers. You can also modify the contents of a buffer. So buffers are commonly used when you want to work with stream information, stream data, or you want to do I/O operations. They're a great way to store binary data for performing various I/O operations.
Node.js also supports the streaming of data. You can kind of think of a stream of water. The water continuously flows from a source to its mouth. Well, streams of data are like that stream of water. Basically, the data flows from some kind of source, and then code can be written to receive that flowing data. Now, just like a stream or a river can be dammed up, data streams can also be dammed up as well. For example, a writable stream can choose to cork itself or uncork itself to either pause or resume the flow of data.
A readable stream can be told to pause sending new data, and then when your code is ready to receive new data, you can then tell the readable stream to resume. But the basic idea is that data flows from one place into another, and through the process of that flowing data, you can write code to transform it, change it, write it out to the file system, send it over the network, compress it, all types of interesting things. Now, typically, streams in Node.js stream string and buffer objects. However, streams can also be used in object mode, and then they can stream any kind of data except for null. Node.js actually provides a stream module to allow developers to create new objects that actually implement the stream interface. That's not actually covered in this course. We're not going to show you how to implement that stream interface for your own custom objects. Instead, we're going to focus in on the built-in streams that are actually built into Node through the various APIs and take a look at how those work, both readable as well as writable. Now, there's lots of examples of these streams. For example, HTTP requests and responses. Those are examples of readable and writable streams. We can also take a look at reading and writing files. Now, all of the Node.js APIs actually only serve string and buffer objects. None of them are actual object mode streams. Now, to read data from a stream, you're going to be listening for the data event. Basically, no matter how the stream gets started, the actual data is provided through the data event. All streams implement the event emitter object. So basically, they're all going to support the ability to listen to events and wire up event handlers that can then listen, for example, for new data or for when the stream comes to an end, that kind of thing. In addition to listening to the data event, a readable stream can also pipe its data into a writable stream. We'll take a look at an example of that. And the data for reading a stream can be an actual string or it can be a buffer if you're not in object mode. If you're in object mode, it can be anything. So let's take a look at an example of reading from a stream.
So now that we're able to actually serve up files in request logs and rotate logs, let's actually take a look at how we can use the request stream, which is a readable stream, to actually process request body data. And this is actually pretty easy to do. It's pretty slick how they have this set up in Node. Basically, the HTTP module, its request object, is implemented as a readable stream. And so the request body data is actually made available through that stream, and then you can take that data and then do what you'd like with it. Now, common things is that people will take the URL encoded data and maybe expose that as a JavaScript object, or take JSON and parse that out to a JavaScript object. We're not interested in doing any of that. All we want to do is basically get access to that post data, and then we'll set it up to actually just output it to the console, and then we can see the result of our stream operation there. So let's go ahead and take a look at how to do that. So the first thing we're going to do is we're actually going to check our method. Now, there's lots of different methods that support request bodies like put and post, but what we're going to do is we are just going to look for post. We're going to keep it really simple. So if our request method is equal to post, then we want to actually process the request body. Otherwise, we don't care. Now, you might notice we have this resolve function here. We also made use of it a little bit in the process file in an earlier demonstration. Because we now have multiple asynchronous operations, basically processing the request body is an asynchronous operation, loading the file off the file system is an asynchronous operation. I've basically made use of ES2015 promises to help chain those asynchronous operations so that I can make sure that they all get done in the proper order before we actually try to send a response back to the user. Going over promises is kind of outside the scope of this course, but this is an example of using promises to basically chain multiple asynchronous operations, which actually becomes important just in Node programming in general because everything that involves a resource is pretty much asynchronous. Now what we're going to do is if we don't actually have a request body to process, we're simply going to take this resolve and we'll just resolve immediately. Now if we have a request body to process, then we're going to do that here inside of the if statement. So let's come into here and take a look at how we would do this. So if I want to start receiving data off of the request, I can say request buffer.on, and then I'm going to hook into the data event. And we're going to use our ES2015 arrow functions once again. And basically the type of data that I'm going to be getting here is a chunk. And it's basically going to be a bunch of bytes, and I'm going to use them to basically populate a buffer. Now the way we're going to do this is that we're actually going to get multiple data operations, possibly multiple data events. So I'm going to want to put all of these into an array of buffers. So I'm going to come into here and say post data. Actually, we'll make it request body data. And we'll just say, make that a new array right there. Actually, let's put our queue, and why not just call it buffers. There we go. Okay, so we've got our request body buffers, and then what we're going to do here is we're going to say request body buffers dot push, and then we're going to new up a new buffer based upon our chunk. So we've got our request body buffers pushing on our new buffer here, and now all of the data that comes in is going to be available here as this array of buffers. Now once the operation has completed, we're going to say on end. At that point we're going to actually want to output this data to the console so we can actually see it. And so what we're going to do is we'll just come into here and we'll set up another arrow function. And we're going to say console.log, and we'll simply take our buffers and concat them. So we'll then take our array of buffers there. Let's actually get rid of the S on buffer. Concat them, and then we're going to say toString, and we'll say UTF-8. Now, what's literally happening here is when you say buffer.concat, it's basically going to take the array of buffers and take all of the buffer objects and concat them together in one big buffer. And so we're then taking that one big buffer and we're calling toString on it, and it's going to take those bytes and output it with a UTF-8 encoding, which means we'll actually be able to see the data that we actually posted up to the server. And then of course once we do that, we do in fact want to call resolve, so the rest of our web server will continue processing the request, which in this case will be actually processing the file. By the way, the chain of promise stuff is actually down here. We have process body.then, and then it does the actual file processing. So let's come back up here and actually run this code. Let's take a look at what it's going to look like here. So we're going to come into here and we're going to say node web. It's going to fire up our web server, and we're going to come into here and we will go back to Chrome and we're going to reload our page. So far so good. And let's actually fill out our little form here. So we'll just type in some test data, and we'll just say age 12, and we'll do test at test.com, and then we'll just make up a phone number. So 123 1234. So now if I click send, you'll see I get my form back here. Everything seemed to submit properly. Let's take a look at our console here, and now you can see I have my URL encoded data. So this is my actual post data that was sent up to the server from the form request. Now if this had been like a standard AJAX call or something like that, this probably would have been JSON data. But the type of data for our purposes doesn't really matter. What's cool is that we were actually able to read this data off of this readable stream, produce an array of buffers, and then take those buffers and produce a single buffer, and then ultimately output the string encoded as UTF-8.
Writing to a stream. You can write to a stream. Examples of writable streams would be like the file writer or zlib compression. You can write directly to the stream through the write function, or you can also pipe data into writable streams through the pipe function. And when the stream is all done, you can have the end event to know when the writing has completed. So let's take a look at how to write to a stream.
So let's take a look now at how we can actually compress the data being sent back to the requester. One of the things that web servers and web browsers actually support is the ability to use gzip compression. So this will make a perfect example of actually how to take a stream and actually write to the gzip and have the gzip compress it, and then have that get forwarded on to the response writable stream. And so let's take a look at how to do that. So the first thing we're going to have to do is actually come up to here and actually comment out the original code that we had from the first demo, or from demo number 3. Because now we're going to be using a stream to do all this processing. We're not actually going to be using read file anymore. So let's come down here and get started with this. So the first thing we're going to do is we want to hook into when the stream has finished so that we can call our resolve function and also be able to output our log entry. So we'll say response on finish, and then we'll simply set up another arrow function here. And I'm simply going to grab our info log up here and copy that, paste that down there. And then I'm going to grab our resolve function here, copy that, and paste it down there. So now we have this thing set up so that once we're done with our response stream, we'll actually continue to do the same logging and same resolving that we were doing before up above. But now what we need to do is actually set this thing up to actually be able to output the information in a compressed format, and then we can actually use Chrome to see that it was in fact actually compressed. So the first thing we're going to have to do is create a readable stream. The readable stream is basically going to do what read file did for us earlier, but instead return back to us a stream that we can then hook into the compression process as well as the output process for the response. So we're going to come into here and we're going to grab our, not our file data, we're going to grab our request file name variable, and we'll copy that. And we're going to come down to here and we're going to say const raw equal to fs.create read stream, and then we'll simply paste that into there. So now we're going to have this read stream that we're going to work with. Now you'll notice this is not an asynchronous type of call. Unlike read file where you actually gave it a callback function, with a stream you hook into the events. And so it's through the events that you actually access the data and things like that. And so because of that, the actual creation of the stream object is not asynchronous, because the actual working with the events is the asynchronous part. But we've got our raw stream here, and so the next thing we're going to do is actually set up our head output. So I'm going to take our response write head, and we're going to take this and bring this down here, and we're going to go ahead and write out the head. But this time we're going to have to specify a header. So we'll say content encoding, and of course we're going to have to wrap this in quotes here. And then we'll set the value here to gzip. And the browser will actually understand what that is and know how to actually do the gzip decompression. Now what we're going to do is we're going to say raw.pipe. And if you are familiar with like a Linux command prompt or even a Windows command prompt, you can pipe the output of a command into another command. And so we're basically piping the output of a readable stream into a writable stream. In this case, we have a writable stream here for zlib, and it's going to be create, and that's going to create our compression stream. Now, gzip is going to be a duplex. It's going to be both writable and readable. And so we're then going to call pipe on it, and we're simply going to pipe it out to the response. And there we go. So now we're going to have a compressed response. And if we come down into here, we'll take out a few extra spaces. And we'll go ahead and start up our web server again. So we'll say node web. And our web server has started. And we're going to jump over to our form here. And we can actually reload this. Let's verify our form still loads properly. That's awesome. And what we're going to do is we're going to come down here to our actual developer tools, and I want to show you something on this index.html. Here's our index. Okay, so if we come down here to our response header, you can see the content encoding is gzip, and yet it was still able to actually load up the actual file itself. And so the actual content was compressed on the way down, and then it was unzipped once it was loaded into the web browser. So in conclusion, using Node.js to work with files, folders, and streams of data is extremely useful. While JavaScript itself does not actually interact with the file system,
Node.js provides a number of APIs which JavaScript can use to actually interact with the underlying C++ modules of the Node.js platform. The handing off of I/O operations to these C++ modules allows JavaScript to continue to process JavaScript tasks on its thread, while the C++ modules and their multi-threaded nature can interact with these system resources. Once the C++ modules finish, they can then push on the supplied callback functions from the JavaScript onto the JavaScript thread with the data that they have retrieved. This entire pattern of programming is called asynchronous programming, and you will actually see it all throughout JavaScript and especially Node applications. Also, in addition to standard reading and writing of files, Node also supports useful features such as streams and buffers, allowing for the processing of streaming data, as well as buffers where binary data can be worked with as well. Welcome to this course on Node.js packages. We're going to take a look at how to install, uninstall, upgrade, manage, as well as create our own packages and publish them to the NPM repository. My name is Eric Green, and this course is brought to you by Wintellect Now. So for a quick overview of the course, we're going to take a look at getting started with Node.js. We'll talk about understanding what packages are, how to install and uninstall packages. We'll understand the versioning of packages and how to see if a package is outdated, global packages, and how file system permissions can impact their installation, updating and configuring NPM, as well as developing and publishing with packages. Now, getting started with Node.js, this course assumes some basic knowledge of Node.js and the JavaScript programming language. To run the examples on your machine, make sure that you have Node.js installed. You can download Node.js from nodejs.org. Be sure to download version 6 or later. Now, if you don't understand the basics of these technologies, then we encourage you to check out the Wintellect Now courses, Introduction to Node.js, and Node.js modules. The Node Package Manager, commonly known as NPM, is the package management system for the Node.js platform. Now, technically, NPM is not really part of the Node project. In fact, if you look at their version numbers, you'll see that they do not correlate to each other at all. NPM is actually a separate for-profit corporation that produces the actual NPM package manager. Node itself is actually supported by Joyent, which is a different company. Nevertheless, these two things go hand in hand. When you install Node, you get NPM. And when Node developers develop with Node, almost all of them make use of NPM for working with packages. NPM has basically become the de facto standard package management tool. There have been some other tools such as Bower, which itself is actually distributed via NPM. But these other tools have kind of faded away, and NPM has become the standard for working with Node packages in your Node applications. Lots of tools and libraries and stuff are actually distributed by NPM, such as Webpack, Sass, TypeScript, Babel, Phantom.js. NPM supports both just plain pure JavaScript packages as well as packages that have C++ code. When you actually install those packages with C++ code, NPM will actually compile that code on your machine during the installation process through the use of the Node.js package. There is a public NPM package repository web interface where you can actually go search for packages as well as look up all the details of packages, such as the number of downloads, links to GitHub repositories, as well as additional information related to the package. Also, the NPM website provides excellent documentation on all the facets of NPM. Everything from how to install and uninstall packages, perform upgrades, look for outdated packages. There's also extensive documentation on how to use the command line tool, as well as how to actually do development and publishing of packages. Here's a quick screenshot of the NPM public repository website. As you can see, it has a convenient search interface with our find packages there, as well as some basic stats about the package manager. So for example, as of this screenshot, there are 291,000 packages. That's a lot of packages. Also, you can see how many downloads were in the past day. That's 60 million, or in the last week, 1 billion, or in the past month. As you can see, people are doing a lot of NPM installing, and it's a huge package repository. So what exactly are packages? Packages are code libraries, applications, or both.
Also, your packages or your projects are packages as well. So if your project has a package.json file, it is a package that could actually be publicly distributed if you wanted to publish it. All packages don't have to be distributed via NPM, such as an actual internal project that you're working on, or you don't want to necessarily release the source code of it, what have you. Just because you treat it as a package and install other packages into it doesn't mean you actually have to publish your package out to the NPM repository. But if you want to, you can. But almost certainly your project will be installing third-party packages from that public repository. There are packages that literally do everything. Everything from a web application framework like Express, to packages that do unit testing like Jasmine, to packages that do functional programming like Lodash. There's tons of them. And most Node projects, which are also packages, include lots of these third-party packages in their code. So what exactly is a package.json file? Well, a package.json file basically contains information about the package. Things like the name of the package, the version of the package, who the author is, a description. Also, the package.json file will typically detail the list of package dependencies. In fact, this listing of dependencies is actually one of the primary benefits of using a package.json file. It allows you to take your source code and move it from one machine to another or put it up into source control without actually having to move or commit all of the third-party packages. You simply take your code along with your package.json, push it up to Git, and then when you pull it down to another machine, you can then reinstall all of the dependencies based upon them being listed in the package.json file. How exactly do we create this package.json file? It's actually just a text file coded in JSON. The npm command line program actually provides us a very convenient command for creating one. We can actually say npm init at the command line, and it will walk us through a step-by-step interview asking us different questions about certain important values in our package.json file. For example, what's the name of the package, which happens to default to whatever folder it happens to be coded in, or who's the author of the package. If you don't want to answer those questions and you just want to quickly create a package.json file pre-populated with default values, then you can use the -y option when running npm init, and it will actually just create a sample package.json file with all of the default responses to the questions. The advantage to this is that if you don't know quite what the answers are going to be, you can at least get that package.json file there and then start registering third-party packages to be included as dependencies for your particular project that you're working on. So let's take a look here at how to create a new package. So I'm going to open up my Node command prompt here, and I'm going to change to my folder where I keep my projects. And now that I'm there, I'm going to create a new folder for my package. So whenever we go to create like a new project / package, we always create a folder to actually store it in. So I'm going to say make directory, and we're going to call this our first package. I'm going to change into first package here. And once I'm in there, I'm now going to create a package.json file. Now, if I wanted, I could actually just create a package.json file by hand and code in all the various options and properties and stuff that I'd like to have, or I can use npm to do that for me. So I'm going to say npm init. When I do that, it's going to walk me through a little mini interview here. So you can see here we have our first package name. That's kind of the default. It just looks at the actual folder name. You can change that if you'd like. Make sure though when naming your packages that all the characters are lowercase and that there are no spaces. So I'm going to go ahead and accept just version 1, but you could type in something else if you wanted to. You can give it a description. This is my first package. Hit enter. Well, we'll go with the index.js entry point. If you had another file that you wanted to serve as the entry point to your package, you could change that to something else here. We're not going to have any type of test command here, but if you were going to have some type of, a way of running unit tests against your package, you could specify that command there. Git repository if we wanted to actually hook it into to a Git repo. Any keywords we might want to have to describe our package. The author, I'll go ahead and specify my name. And then the license, I always like to do MIT, but that's totally up to you, your organization, and whatever the legal requirements are for the software that you're writing.
It'll then ask you if this is okay. It'll show you what your file looks like. The default is yes, just hit enter. And then if we go in there and take a look at our folder structure, we'll see where we have our package.json file. Now, we can also do this a lot quicker. Instead of going through the step-by-step interview, we could actually say npm init-y, and this will create it for us really fast. And now we end up with a default package.json that looks exactly like this right here. I typically will just do the default one to get up and running, but then when I'm ready to actually publish the package, then I'll go back in and fill in all the blanks with actually the proper information. Make sure if you are going to publish your package, you actually do put down the right information, especially things like the license and the author. That type of information can be really important for people who are considering using your package in their code. Now, to install and uninstall packages, you do not necessarily have to have a package.json file. You can simply say npm install the package, and it will create a Node Modules folder, and your package will be available to you. However, if you want to register that package as a dependency, then you will need a package.json file to actually have that package listed. Now, when packages are installed, they typically come from the public repository. That was the web page that we looked at a little while ago. However, it's also possible to install packages from a local repository, such as many corporations will have a local npm repository server within their corporate network, where maybe they'll have packages that are specific to their organization, but it will also serve as a mirror of the public packages. Especially a lot of financial companies, government agencies, with really strong security requirements, typically require that all of these types of packages and stuff be reviewed by their security team before they're installed. And so you can use a local repository to actually provide those services to you. Now, setting up this corporate repository is really beyond the scope of this course, but we will talk later about how to work with packages locally on our systems for setting up linked packages so that we can use them for development. So to install a package, we basically use the command npm install and then the name of the package that we want to install. If we simply just say npm install package, the actual package name, it will download the package and install it in Node Modules, but it will not register it with the package.json file, even if we have a package.json file. To actually register the package with package.json, we have to use one of three flags. We can use the -s flag if we want to save it as an application dependency. What does that mean? The package itself is actually used for the production running of the application, such as Express, which is a web application framework. When we actually run our web application, we have to have Express present. We can also have development dependencies. These are packages that help us with the development of our program. For those, we can specify -d. An example of a development dependency might be Gulp, the JavaScript task runner. Another one of those is Grunt. These are tools that we use in development possibly, but we would not deploy them to production. Finally, we can have an optional dependency, basically a package that would be nice to have if it's available. Maybe it's a piece of code that introduces a special optimization, but it's only available on certain platforms. Maybe it's not totally cross-platform and you can only use it on maybe Windows but not Mac. But if that package is available, it would be nice to have, and so you can register it as optional, and then npm will install it if it's in fact available. So let's talk about restoring package dependencies. So the big advantage of this package.json is such that if I register the dependency, later on in the future I can reinstall it without having to manually list every package that I want. So let's say you actually go in and delete the Node Modules folder. And then if you go back to your actual package folder and say npm install, npm will see that the Node Modules folder is no longer there. And then you can actually reinstall all the packages based upon the dependencies registered in the package.json file. As I mentioned before, this is incredibly useful when checking out code from a source control, repository, what have you, because typically those Node packages are not committed to those repositories. Finally, when you're doing your install, if you're actually installing the packages in the production environment, you'll probably not want the development dependencies. So if you want to limit the install to just the production dependencies, you can do that by specifying the production flag. Now, there's a new type of dependency that's available called peer dependencies. These basically satisfy a special condition when there is a relationship between two packages, but they don't actually depend upon each other. This situation usually arises with plugins. Take, for example, Express. Express is a web application framework. One of the packages that's commonly used with it is Body Parser. Now, Body Parser doesn't necessarily require Express. It just requires the ability to work with the HTTP module to actually process the request stream, to take the request body and actually do something with it and make it available to the programmer. Nevertheless, you would never install Body Parser without actually installing Express. So the problem is, how do we establish that relationship? We can't say that Express depends upon Body Parser because it doesn't, and we can't say Body Parser depends upon Express because it doesn't really depend upon it either. They're used in conjunction with each other. This is where peer dependencies come in, where a plugin can basically say, hey, in order for me to work, I have to have my host package available for me. In version 2 of NPM, peer dependencies were automatically installed. But in version 3, this was changed, and you actually have to manually install peer dependencies. They're not automatically installed like other dependencies are. We can also have something called scoped packages. Scope packages are basically associated with a particular organization. So let's say an organization has a bunch of packages they've created and they want to kind of organize them underneath their organization. You can use scope packages for this. They're also very useful when working with private packages on NPM. You can almost kind of think of them as like a namespace for your packages. When you go to install these packages, in addition to specifying the package name, you also have to specify what the scope. And that's done with an @ symbol followed by the name of the scope, and then a /, which is then followed by the package name. All scope packages will actually be stored in a subfolder under Node Modules. So you'll actually have Node Modules, then a subfolder named for the scope, and then the actual packages are then installed underneath that scoped subfolder. In addition to installing packages from the public repository or a locally hosted private repository, we also have the ability to install packages from tarballs by specifying either the local file path or a URL. We also have the ability to install from Git. So you can install packages directly from GitHub, Bitbucket, GitLab, and even Gist. Uninstalling packages is very similar to installing them. Instead of saying npm install, though, we say npm uninstall and then the name of the package that we want to install. Now, if we actually uninstall a package, it will actually remove all of the dependencies of that package that are not being used by other packages. Also, if we want to remove a package that's been registered in the package.json file as a dependency, we have to use the same flag that we used to originally install it to actually uninstall it, to not only remove the package but also remove the dependency entry from the package.json file. Let's take a look at how to install and uninstall packages. Installing and uninstalling is actually pretty easy. As long as you have a connection to the internet and you're not being blocked by a corporate firewall or other network security, you should be able to download a package and have it installed. So we're going to come in here and say npm install, and then we can pick the name of the package we'd like to install. So for example, we can install Express. That's a popular web application framework for Node. It's now going to go out over the network and actually fetch the Express package and all of its dependencies. This is what it looks like after it's done doing the installation. If we do a directory listing on our folder, you'll see we now have a Node Modules folder. And if we actually go into the Node Modules folder and bring up a directory listing, you'll see we have a bunch of packages here. Now, if you're using an older version of Node that's using npm version 2, you'll actually only see one package folder in here, the one for Express. Underneath the Express folder structure will be all the dependencies of the Express package. But with npm version 3, they've gone to a flatter folder structure, so you actually see all of the dependency packages listed here in the main folder, including Express itself. Now, we can also change out of this folder and we can uninstall this package. So we'll say npm uninstall Express, and this will actually go into the Node Modules folder, and it will delete not only Express but also all of its dependencies, which are not also dependencies for other packages.
So now if we bring up a folder listing, you'll see we have our Node Modules folder, but I can say dir Node Modules, and you can see it's now empty. Now, when we installed the package that time, it didn't actually register it with the package JSON file. If we want to register it with the package JSON file, we have to use an additional flag, which will actually save it as a dependency. So I can say npm install dash capital S, or I can say dash dash save, and it will actually save this package as a dependency. So now if I say npm install express, and I do a more on my package JSON, you'll see over here Express is now listed as a dependency. So now let's say I wanted to come in here and actually delete the Node Modules folder. So I can say remdir-s Node Modules, hit enter. Are you sure? Yes. Now if I bring up my directory listing, you'll see I only have a package JSON file. But because Express is listed as a dependency, I can simply say npm install, and now it's going to install all of the dependencies of our package. So this is the advantage of registering the dependencies and having the package JSON, the ability to easily reinstall everything, especially if you're moving your code to another machine, like from a Windows to a Mac, or checking out source code from GitHub. Finally, if I want to uninstall a package and actually remove it as a dependency, I can say npm uninstall -s and then say express. And this will actually remove it from Node Modules as before, but also will remove it from the package JSON. In addition to having application dependencies, we can also have development dependencies. So let's say I wanted to make use of the grunt task runner inside of my package. I could say npm install -d or --save-dev, and then I could say grunt. And that will install the grunt package as well as register it as a development dependency of my package. So now if I bring up my package JSON, you'll see I have a development dependency here for grunt. And to uninstall that and remove it from my development dependencies, I can also do npm uninstall -d for that as well, and that will remove it as a development dependency. When packages are installed, they are installed with a version number. This version number becomes critical for determining packages that are outdated, as well as understanding what types of changes are made to future versions of packages. Now, NPM packages use a versioning scheme called semver. Semver, while the actual format of the versioning number is required, the actual spirit of how you increment the version is up to the individual developer. So it basically works out like this. The scheme follows a major, minor, and patch version. So for example, version 1.2.3 would be a major version of 1, a minor version of 2, and a patch version of 3. Now that format has to be followed by the developer, but in terms of actually taking into account what is a major version versus a minor version versus a patch version, this is where developers are encouraged to follow the spirit of semver and increment their package versions accordingly. Semantic versioning is actually an official standard, and you can actually head out to the semantic versioning website, semver.org, and you can read all the details. There's lots of details defining what a major, minor, and patch are, various characters and symbols that are used to specify what types of package version ranges are acceptable for upgrades and that kind of thing. So here are the best practices recommended by NPM. Projects that are going to be initially shared for the public to be able to download should have a major version of 1. Now there's lots of projects out there that don't follow this. People push out projects all the time that have a major version of 0 and then have some type of minor or even possibly only a patch version. However, the recommended best practice is that any package that's suitable for public consumption should have a major version of 1. Any bug fixes or minor changes should always be released as a patch increment. So no major new features, nothing that's going to be not backward compatible should be a patch version. It should only be minor changes and bug fixes. New features, so these would be larger changes, but new features that do not break existing features should be a minor version increment, and changes which are not backward compatible should be released as a major version increment. When installing packages and saving them to the package.json file, the version number of the package is actually saved in the package.json file as part of the dependency registration. Now, there are various semver patterns that can be used to determine what version of a package will satisfy some type of dependency requirement. The default scheme basically allows a package to be continually upgraded up to but not including the next major version. So let's say you install package version 1.2 and later on version 1.3 comes out. Version 1.3, according to the default scheme, would satisfy the requirement for 1.2, but version 2.0, which is the next major version, would not. When you do installations, you can also specify an exact version. So we have an example here of an exact version of 1.1.1. In the cases of exact versions, only the exact version will satisfy the dependency requirement. So let's take a look at patch minor and major increments. Patch increments up to but not including the next minor version are, for example, 1.2 or 1.2.x. Basically, this says any patch release under 1.2 but not going up to 1.3. We could also say start at a certain patch version and then anything up to but not including the next minor version. This is done using a tilde. So we can say tilde 1.2.3, and that would be any version equal to or greater than 1.2.3 up to but not including 1.3. We can follow a similar pattern with minor increments. We can basically say version 1, and that's any minor version up to but not including 2, or 1.x. Any version of 1 up to but not including 2. Or we can have the little caret symbol, and caret 1.2.3 means any version equal to or greater than 1.2.3 but not including 2. This is the actual default one. So if you just say npm install some package name, the actual default behavior is to do the caret. And then finally, we can actually just have a star or an X for the major version, and that will just always upgrade to the latest possible version, regardless of what the previous major version was. But using these rules, we have the ability to control what versions of future packages will satisfy the dependency requirements of our project. Now, to check for outdated projects, we can use the npm outdated command. And we can actually run this in the package folder, and it will actually return back a list of packages which are outdated and could be upgraded. If we actually want to check for just a specific package, we could use npm outdated and then a specific package name. Now, we get back 3 pieces of information when we make this, when we actually issue this command. First, we get the current version of the package which is installed. Next, we'll get the wanted version. This is the highest version package, which still satisfies the actual semver requirements of the versioning number in package.json. And then finally, it tells us the latest. So what is the actual latest version of the package? And this will be the version that's actually tagged latest in the actual repository. And so this could be a completely different major version, what have you, but it'll show us the latest one in case we want to choose to upgrade beyond what the semver rules for our package.json would allow. Now, to upgrade packages, we can use the update command. Update will only update a package up to the max allowed range of the semver configuration in the package.json. We can choose to update all the packages, or we can update them individually by specifying a package name. Also, npm update will also install any missing packages that may not have been downloaded or somehow got deleted from your Node project. Now, if you want to save the new version numbers to your package.json, make sure you use the save or save dev flags. If you don't actually tell it to save, then it will not save the newer version numbers to the package.json file. So let's take a look at how we can update outdated packages. So let's say I wanted to install a specific version of a package. I can say npm install, and we'll do -s, and I'll say express at, and I'm going to install version 4.13.2. Now, at the release time of this video, this is not the latest version. We're actually going to be upgrading this version. But we're going to install this earlier version intentionally so that we can actually do the process of upgrading it. So I'm going to come in here and I'm actually going to install this. And when we install it, we're going to see how this gets registered with our package.json file. So in our package.json file, you can see that it's set up to it basically accept any version up to but not including version 5. So right now we're at 4.13.2 because that's what we requested to have installed, but it could be upgraded to a later version. So I'm going to say npm outdated. Let's take a look at what it says. Here it tells us that Express is currently at 4.13.2. It wants 4.14.0 and the latest is 4.14.0. Now what this means is that based upon our configuration here, it will upgrade to the current version, which is 4.14. It just won't go to version 5. So the wanted value is based upon what you see here in the package.json. So let's come into here and actually open up Visual Studio Code. And we're going to open up a folder here. We'll open up our first package. We'll come in here to our package.json file. Make that a little bigger. And now what we're going to do is we're going to make a slight change to this. Instead of saying 4.13.2 with the caret in front of it, we're going to put a tilde in front of it. And we're going to save that. And then we're going to come back over to npm outdated and run that again. And now you'll see the wanted version is now 4.13.4. That tilde means up to but not including the next minor version. So the caret was up to but not including the next major, so it was willing to go to 4.14. But the tilde means up to but not including the next minor version. So as you can see, you can use outdated, and based upon the settings in your package.json file, it will tell you what's available and what will work for your project. Now in this case, what we're going to do is we're going to say npm update. And if we run npm update, that will actually update all the outdated packages as well as install anything that might be missing in terms of other dependencies that for whatever reason aren't present in the Node modules folder. If we say npm update express, that will simply update express, just that one package alone. So let's go ahead and update our express. And now if we say more package.json, we'll see that it still says 4.13.2, but if we say npm outdated, it now has a current of 4.13.4. So it updated it, but it didn't update the package.json with the newer version number.
Global packages are a special kind of installation. All of the packages we've looked at so far were packages that were installed locally within our project. But packages can also be installed globally. Now, this is very uncommon. It used to be more common, but it's actually become quite uncommon. Typically, the only packages that really have been installed globally are command line executable tools, such as maybe Grunt or Gulp, where you want to just run a Grunt task from the command line. So you install a package globally, and then it's within your path, and then you can just execute it. The challenge with installing packages globally, though, is that on Mac and Linux, you actually have to have super user permissions to be able to update the folder where Node actually installs global packages. This is not an issue on Windows because on Windows, packages are only installed globally to the user, not global to the whole system. But on Mac and Linux, by default, they're installed global to the whole system. In order to solve this problem, you can do one of two things. You can either change the location of the global package folder to something where you have permissions, or you can actually change the permissions of the global package folder itself, the default one, so that you can actually write to those folders. Now, keep in mind, the vast majority of packages are going to be installed local to a project. Global packages are pretty much just for executable programs, and even for those, those have started to even be installed locally within projects and then executed through the npm command using a special configuration in the package.json file. Now, there are a few exceptions. For example, the generator program Yeoman. Yeoman actually creates the project for you. So if Yeoman creates the project for you, you can't really rely upon an executable program installed as part of the actual project itself. So things like Yeoman are still useful for doing global installations, but global installations are starting to become definitely the exception, not the rule. And you never want to install a code library globally. You always want to install code libraries local to every application. To manage global packages, we have to use the global flag. It's basically the exact same install, uninstall, outdated, and update commands, except that instead of simply saying npm install in the package name, we say npm install -g in the package name, or npm uninstall -g in the package name, or npm outdated -g to see the list of outdated global packages, or npm update -g to update our global packages. If you don't include the G flag, then it assumes you're talking about the local project, which is probably not what you want if you're trying to manage the global packages. So let's take a look at how to install packages globally.
To install a package globally, it's basically the same thing as installing a package locally. The only real difference is the addition of the -g flag. So I'm going to come in here and I'm going to install the grunt CLI package globally. So I'm going to say npm install -g and then grunt -CLI. And this will go out and download the grunt CLI package, and you can see that it's actually going to install it to my C users Eric app data roaming npm folder. If this had been on Mac or Linux, you might have run into super user permission problems trying to access the folder where this package would actually be installed. To get around that, you can either change the permissions of the folder or change where your global packages are actually installed. But for Windows, because packages are installed global for the user, you shouldn't have any permission issues. And now that this has been installed, I can actually run grunt from the command line, and we're not actually going to have anything happen here because there is no grunt file, but you can see that I'm actually able to run the executable. So global installs are primarily for installing programs that can be executed from the command line, not for code libraries.
Now, npm itself can actually be configured and updated. To update npm, we actually use npm. We can actually say npm update -g npm, and that will actually update npm for us. In addition to that, we can configure npm. npm supports lots of different configuration options. In the corporate world, probably the most important one is how do you set up a proxy? One of the problems with installing Node packages is a lot of times corporate networks require users to go through a proxy to actually download the packages. Well, if you don't have the proxy configured, you're not downloading packages. So npm provides a proxy, an HTTPS proxy configuration option, where you can actually specify your corporation's proxy server or your network's proxy server, and then you can actually go out over the network and download packages. To do that, you can say npm config set proxy, and then the URL of the proxy server, and then npm config set HTTPS proxy, and then the name of the proxy server, to basically configure this. There's lots of other configuration settings, but this is probably the most important one. In addition to setting the configuration from the command line, you can also use an npm rc file. Now, when you actually set the configuration options from the command line, the default is to write those settings to the user's npm rc, usually in the user's root folder on the system. However, you can also set up a per project npm rc file. So if you want to have different configurations for different projects, or you want to distribute some type of configuration file so that everybody has the same configuration no matter who pulls down the project to their system, then you can add a .npm rc file to the project level as well. And then finally, there's a global configuration file which you can edit to. Now, the commands to actually set up the configurations basically start off with npm config, and then you can do a set, which would basically take a key and assign a value to it. You can say get, which will retrieve the value of a key. You have the ability to delete a key, saying npm config delete and the name of the key to delete. And then finally, you can list out the configuration with npm config list. So let's do a quick demo taking a look at how we can update npm and how to set the configuration for npm on our system. When we go to upgrade npm the first time, we actually need to make sure that we've actually installed it to the global package repository. When you do a normal standard node install with the node installer, it does install npm, but it installs npm with node itself. When we decide to do the updates through the npm tooling, we actually have to first install npm itself in the global packages folder. So for right now, if we come in here and actually look at our npm version, we'll see that it's version 3.10.3. But this is actually not the most recent version of npm. So what we're going to do is say npm install -g npm. And this is actually going to go out and download the latest version of npm and install it into the global packages folder. Once it's in the global packages folder, at that point we can then use npm outdated -g to see if it's outdated, and or do npm update -g to actually update it. So now if I say npm-v, now you'll see we're running version 3.10.5. In the future, I can come back and say npm outdated -g, and if npm is outdated, it will actually show up here. Or I can do updates to it and say npm update -g npm, and that'll actually update it in the future when newer versions come out. Now, in addition to updating npm, we can also configure it. For example, if I want to look at my configuration settings, I can say npm config list. And when I run this, it's going to output my npm configuration. I can also get a single configuration value saying npm config get prefix. And now you can see I have my prefix folder, which is actually where the global packages are installed on your system. In addition to using third-party packages for adding functionality to our applications, we can actually use packages to better organize our larger projects or to create common code libraries that can be shared between different projects. Now, you might think that taking this approach might actually be a little bit difficult, only because you'd have to do the coding, push it to the repository, and then reinstall it. But actually, npm provides a great linking feature where you can have two packages locally linked to each other locally, where you can basically do your code edits in the package that you're linking in, and then those code edits are automatically available in the package that you're doing your primary development in. And so it makes the whole process very quick and very efficient, and allows you to move your project over multiple packages, especially creating, like, let's say, like a shared common code package that you could reuse in other projects, and basically better organizing your application. Now, in addition to doing that, you can also publish packages that you create. And you really have two options here. You can basically push to the public repository for free. That literally, it takes literally 2 minutes to do. It's actually really easy to do. But you can also sign up for a private repository with npm as well. Now, you do pay a price for that, but it's not too expensive. If your organization wants to have a way to have private packages and be able to deploy them to all of the developers, then this is definitely a good way to do that. To work with linking and unlinking, we use the npm link and unlink commands. If we want to link two local packages, we use the npm link command to do that. And if we want to remove that link, we can use the npm unlink command. Now, it's a little bit of a tricky process to go through these steps to actually make this linking work, but we'll walk through that shortly. Now, each of these commands accepts an argument, but the argument depends upon the context of the linking and unlinking. For example, when I want to take my secondary package that has some library code in it, for example, and I want to make it available to my primary package, inside of the folder of my secondary package, I can say npm link without a command option, and it will link that package into the global folder. But when I'm inside of my primary package folder and I want to link in the secondary package, then inside of that primary package folder, I'll say npm link,
and then specify the name of that secondary package, and then that package will be available to me inside of that primary folder. Now, this makes life a lot easier because I can basically edit the code in both the primary and secondary package folders, and the code will run in the primary package folder as though the secondary package was actually like really installed from the npm repository, when really all it is a series of symbolic links or Windows junctions that actually make that package available. npm link creates that link from the current package folder to the global package folder. Then inside of that primary package, I can say npm link and whatever that package, that secondary package name is, and that will actually link it in. Now, if I want to make this two-step process a little bit quicker, I can actually do it in one step by saying npm link from the primary package folder, and then for the option passed in, I can actually specify a folder path to the secondary package folder, and npm will actually take care of both the linking from the secondary to the global as well as from the global to the primary. As I mentioned a moment ago, on Mac and Linux, this is a symbolic link. So if you want to check out the link command for Linux or for Mac, you can go learn about hard links versus symbolic links. On Windows, the link is a directory junction. And so a directory junction enables the secondary package to be in the global folder, and then that global folder with another directory junction linked into the primary package folder. We use the npm unlink command to unlink a package. Within the secondary package folder, we can simply say npm unlink and it will remove it from the global package folder. Inside of the primary package folder, which was linking in the secondary package, we can simply say npm unlink and then the name of the package, that secondary package that we want to unlink from. Unlink is also an alias for the uninstall command. So let's take a quick look at a demo of linking and unlinking packages. So let's take a look at how we can use linking to do development with two different packages. So what we're going to do is we're going to create one folder here called package A, and we're going to create another folder here called package B. There we go. And I actually happen to have two copies of Visual Studio Code open, and we're going to open up the folder for the first one, and we'll come over to Get here, select now, package A, and we'll select that folder. And then for package B, we'll come over here and go to Open Folder, and we'll go to package B. There we go. Okay, so excellent. So what we now have here is we have two development environments, one for package B and one for package A. What we're going to do is we're going to link package B into package A. So we're going to write some code in package B. We're then going to link it with npm, and then we will install it or link it from the global repository or global folder into package A. So let's come into here and let's actually go ahead and open up a command prompt, and we're going to do npm init-y. That's going to create a package JSON for us. The reason we need the package JSON is that we're basically going to need this main file index here. When we go to require this package, the main code that we're going to be pulling in is going to be in this index file. So we're going to come into here and we're going to say index.js. And then what we're going to do is we're going to do module.exports. And then we're going to come in here and specify a function. So we'll create a function called doIt. Excellent. We'll say console.log did it. Perfect. Okay, so now we have something that we can actually like export and then pull into another program. So we're going to save that file right there. We're going to come back down into here and we're going to say npm link. We can actually make that a little bigger and collapse that, and you can see the npm link command. Now notice we're not specifying any arguments. So basically this is going to link this into the global package folder. So if we hit enter, then it's actually going to link it. And if we actually come over here and open up our Windows Explorer and go into App Data, Roaming, NPM, Node Modules, you will see there's package B. So what we want to do now is include package B over in package A. So we'll come over to here, collapse that down, make that a little bigger. We're going to say npm init-y and actually set up a package JSON file. Then we're going to say npm link package B. And this is actually going to hook us into the global folder once again. Then we can actually come up to here and we're going to create an index.js file. So we'll say new file, index.js. And then in here, we're simply going to write a little bit of code and we'll say const package B equal to require package B, and then we can say package B dot do it. Save our file, and now we can actually run this code and take a look at the result. So we'll say node index, hit enter, and you can see it outputs did it. So let's say we didn't want to output did it and we wanted to be able to maybe pass a message in and be able to output that way. So let's go back over to package B and we'll modify our code. We'll say message, and instead of outputting did it, we're going to actually output the message. So we'll say MSG and we'll save that. We'll come back over to here, we'll pass a message. It worked. And so now notice we haven't had to redo any linking. All we had to do is modify package B and then come over and use the new feature of package A. So we'll come into here, run node index, and you can see that it worked. So package linking is really nice for developing two different packages at the same time and using one inside of the other. Now to unlink this, we can actually come in here and say npm uninstall, and then we could do package B. And now package B will be uninstalled, and then we can come over to here and say npm uninstall -g package B, and that will actually remove package B from the global folder. So if we come back over to here, you can now see that it has been removed. We have the ability to publish packages. One of the great features of the npm public repository is that all JavaScript developers can basically share their packages and other developers can make use of them. The only thing you need to actually publish a package is an account. And so you can create an account for free and then you can publish all the packages you'd like to the public repository. Now if you sign up for a paid account with npm, they'll also let you publish packages to a private repository as well. Finally, there's an npm enterprise option. Beyond the scope of this course, this allows local hosting of packages behind a corporate firewall. Once a package has been published, it really should not be unpublished and removed from the repository, especially if other people have started depending upon it. There's actually several famous incidents where people have tried to unpublish popular packages from npm and then kind of basically broke the internet, if you want to think of it like that. A lot of packages which depended upon those packages could no longer be installed because the packages that they were depending upon had been unpublished. So as a general rule, you should be deprecating your packages if they're no longer being actively developed or used, or there's a newer version, what have you. Now, if you create a simple test little package just to see how publishing works, please remove that package once you're done testing. There's no need to leave that package up in the npm repository. But any package that actually really does something, once you publish it, it should be left up there. Now to publish it, after you create your account, you can then use the npm tool to actually log in. And the login can do one of two things for you. It can actually log you in with your existing npm account, but it will also create a new account for you. It's also an alias for the ad user. So if you try to log in with your email address and password, and that email address does not exist in their system, then it will automatically create a new account for you and you can use it.
If that email address already exists, then they'll take the password that you supplied and make sure that it's legit. And assuming your password's legit or a new account is created, you are then logged into NPM and you have the ability to actually publish packages. If you want to know which user you're logged in with, you can just say npm who am I, and it will tell you the user that you're logged in with. To create an account through the web interface, you simply go to npmjs.com/signup, and they have a form for you to fill out, and you can make yourself an account. From this account, you can also sign up for private packages, which are useful if you want to have a private repo for your organization. So let's take a look at how to publish a package to NPM. So let's come into here and actually push our package up to the NPM repository. So I'm going to say npm login. I'm going to put in my username, type in my password, type in my email address. Now I am logged in, and I'm going to say npm publish. So now my package is being published up to the public npm repository, and I can actually come over here to Chrome, go to npm.js, and come over to here, and I can search for package B and hit enter. And there's the package I just published. So I can click on this. I can look at the information, which is quite limited. And then now I'm going to come back over to my Visual Studio Code, and now I'm going to install package B from npm. npm install, and we'll actually save it as an actual dependency, and I'll say package B. So now package B is going to be installed, and so now I can run my program again. So I can say node index, and it will output that it worked. Very, very easy to do to push out node packages. So if you have code that you've written that you'd like to share with others, in terms of JavaScript code, npm or the npm repository is a great way to go. Now this is just kind of a test package, so let's go back and actually unpublish it and remove it. Now, this is not generally recommended when you are when you have a package that's already been out there and people are making use of it. You'll break their code when they go to install it. But since this was just a test run, we can come in here and say npm unpublish, and we can actually remove our package from the repository. Make sure you include the force flag to do this. So we're going to say -- force. And this will actually remove the entire project from npm. And now if we come back over to the web browser and we do another search on package B, you'll see it's now gone. So in conclusion, npm is the package manager for Node. It is run by a private for-profit company, and it is a separate project from the Node project, but the two go hand in hand. The projects that you create themselves are also Node packages if they have a package.json file. And honestly, almost all projects should have a package.json file, if only so that package dependencies can be tracked. And in addition to that, npm itself can be used to manage many aspects of your project setup, including replacing the need for gulp and grunt. Welcome to the Node.js Express REST Services course. My name is Eric Green, and this is brought to you by Wintellect Now. In this course, we're going to take a look at getting started with Express REST Services, configuring a router with Express, extracting data from the URL, working with a request body, as well as JSON Web Token authentication with Passport. This course is going to assume that you have some basic knowledge of Node.js and JavaScript programming. To run the examples on your machine, you will need to have Node.js installed,
You can go download that from nodejs.org. Please install version 6 or later. Now, if you don't understand the basics of these technologies or have no experience working with them, then we encourage you to go watch the Wintellect Now courses, Introduction to Node.js, Node.js Modules, as well as Node.js Packages. What exactly is Express? Express is the web framework that we're going to use to build our REST services. And basically what Express is, it's a package that's used to basically help configure Node's HTTP module. The HTTP module in Node is an excellent module. It's very capable, very flexible, and it's not even all that hard to use. The problem is that using it requires a lot of boilerplate code. So by using Express, we can basically eliminate a lot of the boilerplate code surrounding routing, serving up static files, etc. Now, Express promotes itself as being fast, unopinionated, and minimalist. What does this mean? It's fast because Express only does what you need it to do. It's not bloated with a bunch of built-in software that either has to be turned off or it can't be turned off, and so wastes CPU cycles to simply process requests doing things that don't need to be done. It's unopinionated because it doesn't tell you how to build your web application. It gives you a set of convenient interfaces and allows you to be opinionated yourself about how your web application should be built. It's minimalist in that it relies heavily upon third-party middleware for much of its functionality. You get to make the choice of what middleware you want to include in your web application. Examples of middleware include packages that allow you to handle request bodies or work with cookies, work with sessions, etc. Express is distributed via an NPM package, and it should be installed locally to each project, not globally. To install Express, you can simply type from the command prompt within your project folder, you can say npm install express, and it will install it in the Node Modules folder for you. If you want to check out additional documentation on Express beyond what we cover in this course, you can head over to expressjs.com. They have a lot of documentation, and that's pretty easy to follow, and it'll provide you additional details on parts that we don't cover. So what does Express provide to us out of the box? It basically provides us routing capabilities as well as serving up static files. The routing is going to be really important for REST services because REST services are totally built around the concept of what verb is being used, and are we using a collection URI or an element URI, as well as how do we actually extract out information like an element's ID. So we'll be looking at it from all those different perspectives. Serving static files is not really all that important for a REST service. Most of the stuff that we'll be serving up will be dynamic data. Nevertheless, Express does provide that out of the box. We're also going to be making use of other third-party middleware modules, such as Body Parser to work with request bodies when we do posts and puts, and then of course Passport and Passport JWT for basically working with JSON web tokens for performing authentication. What exactly is REST? REST stands for Representational State Transfer. The concept of REST originated from Roy Fielding's doctoral dissertation from his studies at the University of California in Irvine. And you can actually go read about the whole history of that over on Wikipedia. It's pretty fascinating, but not all that critical for us to actually create REST services for our application. REST is more of a convention, not a standard like SOAP is. Basically, each organization can kind of implement REST web services in their own way. Now, there are certain agreed upon conventions that are followed, and we'll take a look at some of those now. So what are the key concepts of REST services? First of all, we have the client-server concept. There's a client and there's a server. The server, of course, are our REST services. The client is typically a web application or possibly a mobile application consuming those REST services. Nevertheless, the client and the server are basically ignorant of each other. They don't know anything about the implementation of each other because they communicate simply through HTTP, and they don't care about the execution state. So when you interact with the REST service isn't maintaining state about your various transactions. Each transaction is stateless. So you make a request, you issue the request, you get a response, you're done. The next request you make really has nothing to do with the previous request from the perspective of the REST service. Now, your local application might be executing a series of REST service calls, perhaps sending certain kinds of data and doing it in a certain order to achieve some type of end result. From the perspective of the REST service, it doesn't care. Also, we can do caching. So responses to requests can possibly be cached, depending upon how often the data is updated, the type of request that was made,
it is possible when working with REST services to indicate through headers that the content is cacheable. And when possible, this should be done because this can improve performance. Finally, we come down to the interface. This is really the part that most people are really familiar with when they think about REST services. They think about the verbs and they think about the URIs being used. The interface that we're going to be working through is HTTP. REST technically doesn't have to use HTTP, but when we all talk about REST services, we're basically talking about HTTP. And what we're going to be doing is we're going to be using verbs to indicate the action that we want to perform, such as get is to retrieve a record or post is to add a new record. And then we're going to talk about using URIs to indicate which resource or resources those actions are performed on. So what are some of the conventions of REST services that you kind of see across the board? So first of all, we have two types of URIs. We have a collection URI and an element URI. Both URIs are almost exactly the same, except that the element URI ends with a resource ID. So let's look at the collection URI first. We have basically our protocol, our domain, possibly a port, followed by a pluralized resource name, such as widgets, not widget, or cars, not car, or books, not book. An element URI is the same as the collection URI, except that after the pluralized resource name, we have another slash followed by some type of resource ID. That resource ID could be a number, it could be a string of characters. It all depends upon how that ID is being stored in the underlying database. The two URIs combined with HTTP verbs are what provide the interface to all of the REST service operations. And it's these combinations which basically serve as our conventions. The most common operations are as follows. If you say a get, or if you make a get request against the collection URI, that will return all of the resources. If you make a get request against an element URI, that will return one resource. If you make a post request against a collection URI, that will actually insert a resource. If you do a put request against an element URI, that will actually replace or insert a new resource. And then finally, if you do a delete against an element URI, that will delete an existing resource. What's the difference between update and replace? If you remember on the previous slide, we had a put against the element URI, and we said that was a replace. Well, what that means is the original resource goes away and the new resource is added. But what if instead of replacing, we want to do an update or actually update an existing resource in place, maybe changing a few properties as opposed to completely replacing it? Commonly, this is accomplished using the patch verb. So you use the patch verb with the element URI, and it will actually update the resource instead of replacing it. In the process of updating, you only have to send up the actual fields that need to be updated, and those are of course included in the request body. So for put and post operations, the request body is going to be used to contain data to be inserted or replaced. When calling the REST service with delete or get, no request body is needed because the actual data needed to fulfill the operation is in the URL itself. Now, when working with REST services for the request body, you can use XML or JSON, but JSON today is by far the most common. It's very easy to work with in JavaScript, and all of the major platforms for building REST services have support for JSON. Now, one last word about these conventions. All of this has to be coded by you. Unless you're using a third-party library that sets all this up for you, you actually have to implement all of this. You have to write the code that says, okay, for delete, go and delete the record and then send back whatever it is you want to send back. So what this means is it's up to the individual developer to actually implement the convention the way they would like to have it implemented. So you can follow these rules or you can totally break them. It's totally up to you. I've worked in some places where people didn't want to do puts and deletes, so they used post for all of their data modification operations, and then in their URL path they basically included extra information to indicate whether it was creating a new record, deleting something, what have you. So every organization can do this a little bit differently. However, these are the commonly accepted conventions. So we're going to use Express to actually implement our REST service. And what we're going to do is we're going to use the routing capabilities of Express to handle the interface of the different REST operations. And then inside of the actual route handlers, we'll do whatever data operations are supposed to be performed to satisfy those requests. So Express is particularly useful for this because it supports the common REST service HTTP verbs. It gives us the ability to extract element URI IDs from the URL. We can handle XML or JSON request body data through the use of third-party middleware. And we can also do authentication with JSON web tokens through the use of third-party middleware as well. In order to test our REST services, developers commonly use REST clients. REST clients are like web browsers, but they're especially designed to work with REST services. Web browsers typically limit you to making a GET request in the address bar, but with a REST client, you can make any type of HTTP verb request, and then you also have the ability to specify the headers as well as provide a request body in almost any type of reasonable format. Then, once you supply the information, you can use the REST client to execute the request, and then typically the REST client will then format the resulting response data, especially if it's JSON or XML, in some type of easy-to-read format, or you can actually look at the raw response. Popular REST clients include Postman as well as the Advanced REST client. Both of these run within Chrome as extensions. I encourage you to check them out. They make working with REST services a lot easier. So let's do a quick demo on creating a Hello World Express REST service.
So let's take a look at how to build a very simple Hello World REST service, as well as use a REST client to actually load up the data and see the results. So I'm going to open up a terminal prompt here. I'm going to change to my source code folder. We're going to create a new folder here called REST Service. And we're going to go into the REST Service folder. The first thing we're going to do is create ourselves a package.json file, and we're going to do that just in case we want to actually distribute our application as a package, but also so that we can register our dependencies. In this case, we're going to have a dependency upon the Express package, as we're going to be using that to build our REST service. So I'm going to come in here and say npm init-y, and that's just going to create for me a default package.json. I'm then going to say npm install -s Express. Now that we have Express installed, let's go ahead and open up our Visual Studio Code editor, and we're going to open up the folder here. So we'll go into here, REST service, and then we'll say select folder. There we go. Now you can see over here we're going to have a listing of our files, and then we can actually do our editing of the files in here. We'll actually make this a little bit bigger, so a little easier to see. And so now what we're going to do is we're going to code up our Hello World REST service. So we'll come into here, we're going to create ourselves a new file. We'll call that index.js. And then in our file here, we're going to pull in a couple of different things that we're going to need to actually build this. The first is the HTTP module. This is the one that's actually built into Node itself. This is what Express will be configuring for us. So we'll say require HTTP. And we're going to say const express equal to require express. Excellent. So the first thing we need to do is actually create our application object. So we're going to say const app equal to express. And this is actually going to produce the application object that we're going to pass into the HTTP create server function to actually produce our server object. So let's go ahead and do that now. And we'll say http.create server app. There we go. So now we have our actual app object being passed in. This actual server, we're going to set that up to actually listen on port 3000. And we'll just pass in a callback function here to run to see, make sure that we're actually up and running. So we'll say REST service running on port 3000. There we go. Okay, excellent. So now what we need to do is actually wire up our first REST service operation. This is actually really easy to do. We're going to come in here and say app.get, and then we're going to set up a path for this to hang off of. In this case, we're going to be working with a collection of widgets. So we're going to say /API/widgets. So any GET request that comes into this /API/widgets, we're going to set it up to basically return back some sample data. So we're going to come into here, and we're going to have our request and our response objects. And then we're going to say response.json, and then we'll just pass back some widgets. So we'll say name, widget 1, color, blue, size, large, quantity, 3. So we'll have widget 1 and 2, and then red and orange, and then finally we'll vary up our sizes here a little bit and do small, medium, and then change our quantity over here to be like 5, and then we'll do 10. Excellent. So now we have some JSON data and stuff coming back here. And so this response.json is really convenient for working with REST services because it will actually take this object and JSON stringify it and then set the actual content type for the response body to be application JSON. And so that saves us a few extra steps of what we have to do to actually send back responses, and that's really convenient. So now that we have that, we want to actually fire up our REST service here, and then we're going to use the web browser and then a REST client to actually make requests against it. So I'm in Visual Studio Code Insiders, which supports terminal windows. And if I hold down Control backtick, I'll get myself a terminal window here. And then I can say node index. And we have a REST service now running on port 3000. So I'm going to open up Chrome. And I'm going to go to localhost 3000/API/widgets. And if I run that, and of course zoom in here so you can see it, you can see we're actually getting back our widget data in a JSON format. Now, doing GET requests with the web browser to get data is very easy to do, but if we were working with other verbs, using a simple web browser interface like this wouldn't be all that helpful. So instead, we can make use of something called a REST client. So in Chrome, under my apps, I have a REST client called the Advanced REST Client that I like to use. A lot of folks like to use something called Postman. It's totally up to you. I've been using the Advanced REST Client for years, and it works really well. It works really, really well. So I'm going to come into here and say localhost 3000/API/widgets. I have it set to a GET request. If I wanted to do other methods, I could select them here. If I had headers I wanted to specify, I could do that here as well. So now I'm going to click send, come down here, and there's my JSON data. Now this has been formatted for me. If I wanted to look at the raw results, I could also look at the raw results there. Express provides a very powerful router object which we can use to actually set up the routes for our REST service. It has the ability to detect HTTP verbs as well as URL path patterns. Routers really at their heart are really just middleware, kind of like the middleware that we've imported into our project to serve other purposes. What's nice about routers though is that they can be mounted on any path. They kind of exist independently of the application, and then you can include it in the REST service application wherever you would like by mounting it on a certain path, which will then factor into how the route is resolved when requests come in. Now, the route handlers that are configured by the router actually have access to the request and response objects. So your route handler can actually query the request object to get all the data that it needs to do whatever operation needs to be accomplished, as well as having access to the response object to help generate the response that is sent back to the requester. The router object also provides a route method where you can define a URL path, and then off of that method you can then easily set up handlers for all the various HTTP verbs that may be called against that particular route. This is very helpful since when we're working with the collection URI, we're interested in having a route for the collection URI, but then also having methods wired up for GET and for POST. And then for working with the element URI, we're interested in having handler set up for the get, put, and delete methods. Let's take a look at a quick demonstration of how to configure our router, and we'll set up the various routes for a REST service. So let's set up a router to be able to set up our REST service as basically really just another piece of middleware that can then be used with other pieces of middleware. So what we're going to do in this demonstration is we're going to kind of build the scaffolding needed. We're not going to fully implement all of the REST service operations. We have to learn a few more things about Express and its associated middleware in order to build these things out. But in terms of setting up the scaffolding for it, we can go ahead and do that now with the router object. So I'm going to go back to our source code here, and let's collapse that window down there. So to set up the router, the way this works is that we're going to come into here and we're going to say const, and we can set up our widget router. So I can say widget router equal to express.router. Now this widget router, we can configure it to have basically a route on it for like a specific path, and then off of that path set up all of our verbs. So we'll come down here and we're going to take our widget router and we're going to say widget router dot route, and then we can do our /. So the way this is going to work is we're not actually going to hard code in the API part of it, but what we'll do is we'll specify widgets like this, and then that way we can actually then hang off our various verbs we want to set up. So the first URI we have to do is the collection URI. So we have widget router dot route, and we're going to set up a get like this, and we're also going to set up a post. Those are the two operations we do off of the collection URI. Then we're going to set up a second path here, or a second route if you want to use the terms of the function name. And for the second one, we're going to talk about widgets / widget ID. Now we haven't discussed extracting values out of the URL yet. We're going to do that in the next section, but this is what the URL pattern is going to look like. And then for this one, we're going to come in and we're going to have a get, we're going to have a put, and we're going to have a delete. So you can kind of see how we can chain these things one after the other to set up our routing mechanism. Now down here, we're going to take our widget router and we're going to take our variable here, just copy that. And down here, instead of passing in this function, we're actually going to hang the widget router off of our API. We'll get rid of /widgets. And then we're going to change this to use. So the use function allows us to hang a router off of some type of path. So now when you go to access this, it'll be /API /widgets or /API /widgets /widget API. I'm going to take this function right here and we're going to pull this one out, and we'll actually come up and place that directly into the get function of the collection URI. Place that in there just like that, and then we'll take our data here, just indent that in there, and don't want to forget our little semicolon there, and then of course get rid of our closing parens right there. So now we have this widget router with a route set up here as well as a route set up here to start serving up our basic REST service operations. Now, as you can imagine, putting all of this in the same file is really not the best way to do this. So what we can do is we can actually move this to its own file. So on our REST services folders over here, I'm going to create a new folder called routers. And then underneath this folder, I'm going to create a file called widgets.js. And then we're going to move this code that we have here, and we're going to move it over to widgets. So we'll grab our Express code, drop that into there. Then we're going to grab our widget router code,
and we'll pull that out right there and drop that into here. And then what we're going to do is we'll say module.exports equal to widget router, and actually export that out. Remember that Node.js uses the common JS module format. And then we'll come into here, and for a widget router now, instead of doing it this way, we're simply going to say require. And because this is a module that exists within our actual application source code, we're going to use a file path. So we'll say routers/widgets. You do not have to include the JS extension. And so then we have widget router, and we have widget router here. And so now we're starting to build an actual REST service. We're moving our routes and stuff to external files. We're setting up actual paths, and then off of those paths supporting the different verbs. So we should be able to actually go ahead and run this. We'll be able to run the initial, basically the GET request on the collection URI and pull down all the widgets. The other ones won't work yet because we haven't discussed the other things that you need to know to actually make them work. But we do have the scaffolding here being set up to actually build our router system. So let's go back over to our web browser. Actually, let's go back to our command prompt. We have to make sure that we restart our server. Every time we change the source code here, you have to go back and restart the server. So there's our node index. Everything's up and running. We'll come back over to here. We can reload our page, and you can see we get our widget data. For the element URI routes, we actually need to extract a piece of data from the URL, the actual ID of the resource that we're going to be working with. When working with REST services, this ID is typically captured in the path, not in the query string. So if you take a look at our diagram here of a URL, you can kind of see the different parts. We have the protocol, the domain name / IP address, port, path, query string, and then of course the client-side part with the hashtag that's never actually even sent to the web server itself. It's inside the path where we can set up URL parameters and actually extract out the resource ID that we want to do the GET request on, or the replacement, or the updating if we're implementing patch, or even doing the deleting if we want to delete the resource. The query string parameters can be used to pass in additional information, but they're not fundamental to the REST service itself in terms of working with a particular resource. Let's do a little demonstration of how to work with URL parameters inside of our route handlers for the GET, PUT, as well as the delete methods. So now that we have the scaffolding done for our REST service, let's go ahead now and implement the URL parameter down here that we have for our widget ID, as well as hook this thing up to a little bit more reasonable of a data source. So what I've done is I've got a little database.js file over here that has some basic operations for working with a collection of objects. I've intentionally set it up with promises so that we can interact with it in an asynchronous manner, very similar to how you would work with traditional data sources like databases. In order to make this thing work, though, we're going to have to pull in the path module so that we can specify the data file that we're going to use. So we're going to say const path require, and path is one of the modules that's actually built into Node, so we pulled it in there. And then we're going to pull in this database thing that we've created. We'll just call it DB. Now, because this thing is actually part of our application, we're going to reference it through a file path. So I'm going to do /database. Now, notice I'm not going to put the JS file extension. We don't need that. CommonJS automatically assumes this file will end with a JS extension. Now, there is a method on it called connect that we're going to invoke. And this is going to be expecting a database file path, or a JSON file path actually, to load up the JSON file. So I'm simply going to say path.join, and then I'm going to say dir name. This will be the actual file directory of widgets.js, and then we're going to go up a folder, and then we're going to actually specify the widgets.json. There we go. And that will actually load up our JSON file and then give us this DB object. Now, the first change we're going to make is we're going to come down here into our get, and instead of doing this, we're going to drop all that out, and we're going to say DB con is our little connection object, con.getAll, And this, of course, returns a promise. And then we're going to get all of our widgets. And then we're going to say response.json widgets. There we go. Now we have a little asynchronous operation here. And notice that the res.json here is going inside the then function of the promise. You can kind of think of it as a callback if you're not familiar with promises. And so what that means is while our asynchronous data operation is off doing its thing, Express, specifically Node, will be available to actually handle additional requests that come in from the server from other users. And that's the beauty of asynchronous programming. Now, in addition to implementing get, we're also going to need to take care of our get with our widget ID and then take care of our delete. We're not going to implement post or put because we haven't actually worked with the request body yet. We'll be doing that in the next section. So we'll just work with the ones that we can do that don't require a request body. So I'm going to come up here and actually just copy this function right here. Come down here to get. We'll paste that in. Come down here to delete. Now, instead of saying get all, we're going to want to actually just call get, and then we're going to want to pull in this widget ID. Now, it's expecting widget ID to be a number, so we're going to say parse int, and then we'll say request.widget ID, just like that. Actually, request.params.widget ID. So widget ID is going to be available off of the params property on the request object. Down here, we're going to do something very similar. We're going to say delete, and then we're going to grab the parse int there and paste that in. Now you'll notice delete here and here are actually a slightly different color in my editor. In fact, if we make that a little larger, you can see that a little better. And the reason that's a different color is because technically delete is actually a reserved word in JavaScript. It's actually used to remove a property off of an object. But it's also commonly used for function names and stuff like that too. And so the editor is the one making it this other color, but this is perfectly valid JavaScript code in terms of using the word delete in your code as we are here. So let's go ahead and save that, and we're going to stop our REST service and restart it again. So now we have our REST service running on port 3000. We'll open up Chrome, go to localhost 3000, and actually let's go to /API/widgets. And now you can see we have our list of widgets, and then we'll just grab a particular widget. So we'll say widget number 2, and there's our particular widget that we grabbed. And now let's go ahead and do a delete operation. So we'll come over here, open up a new tab. We'll go to the Advanced REST Client. So here's the Advanced REST Client here. And now what we're going to do is we're going to say API widgets, and we'll say /2. So we'll delete the second one. We're going to do a delete operation, and we will send. You can see we get an OK. It actually sends back the widget we deleted. And now if we come back here and load up our list of widgets, we'll see that widget number 2 has in fact been deleted. So in order to support post and put, we're going to need to be able to work with a request body. Now, as mentioned earlier, Express itself does not actually support processing of the request body. You, of course, can write your own code to interface with the stream through which the data of the request body is available, but it's actually easier to use middleware that already does this for us. And in our case, we're going to be using the body parser middleware to actually process JSON content. But the body parser can also process URL encoded data, such as the kind of data that gets submitted with the form. Or if you wanted to, you could also do file uploads using things like Multer. But what we're interested in working with for our REST service is JSON content. And so the body parser can be used to actually process that request body for us and give us an actual JavaScript object in return. So the way that body parser works, it actually looks at the content type of the request. And based upon that content type, it chooses how to actually process the request body. So if the content type is application JSON, then it's going to use JSON parse to basically parse the JSON data and then ultimately populate a body property on the request object with the JavaScript object that was generated from that JSON data. Now the key is we need to make sure that we have body parser loaded on all of the routes that are actually going to need it. If we don't have body parser loaded on a particular route and it needs access to that request body, then it won't be available to it. So in our case, we're going to want to make our body parser configured on the post as well as the put methods so that we can handle data being passed up to create a new resource or to replace an existing one. Now, most REST services today make use of JSON as the preferred data format. Originally, it was XML, but XML is a little bit harder to work with, and especially since we're using so much JavaScript these days, especially in the web browser, using the JSON functions to work with JSON data, which is generated from the JavaScript objects or can be easily translated back into JavaScript objects, makes a lot of sense. So let's do a demonstration of how to work with some JSON data for our post and put REST service operations. So now let's go ahead and wire up our ability to work with post and put with a request body. So we're going to come back over here to our code, and the first thing we're going to have to do is actually stop our server here. And we will come in here and we're going to actually have to install a new package called body parser. So we'll say npm I is short for install, -s, and then body -parser. Great. So now that we have body parser, we're going to need to include this into our project and then set it up to be able to process certain requests. Probably the easiest way to do this is to actually just come up here to our index.js file, and we're going to just pull in body parser. So we'll say const body parser equal to require body parser. There we go. And then we'll just set it up so that basically on all requests to our API, we'll go ahead and just process the body. To do that, we'll just say app.use, and then we'll say /API, and then body parser, and then we're going to set it up to process JSON data. So what will happen here is when we actually make requests where the content type is set to application JSON, body parser is going to set up a property on the request object called body, and we can access the actual request body data on that property as a JavaScript object, which is incredibly convenient. So we'll save that. We're going to come back over to here and we'll go ahead and build out our post and our put. Alright, so if we come into here, we'll grab our we'll actually grab our function right there, copy that, and we'll post. And the way this is going to work is we're going to take our request and we can say insert, then request dot body. There we go. So we have request dot body, and then the result of that's actually going to be the widget that we inserted with its ID. Now, some folks like to send back only the ID, especially if you start getting into the Helios stuff where you start sending back all these different links to the same resource or other resources as described by your REST service. We don't really have time in this course to dive into all of those details. But one of the things I do like to do when I write REST services for real is whenever I'm doing an insert or even an update, I like to return back the updated object. So for example, even though we're sending up this data here in our request and we're inserting it, after we do the insert, there's definitely going to be an ID on the object. There could also be additional calculated fields. So I like to return back the entire thing, and that just saves me from having to make another REST service request to get all of those details. We already have to send back a response anyways, so we might as well include everything that you would need as a result of doing the insert. I also do the same thing on updates as well, because there could be other calculated fields on the object as part of doing the update that I may want after doing the update operation. So we'll go ahead and send back our new widget here, which is going to have an ID. And then I'm going to come down here and we'll do basically the same thing here. So I'm going to take my get operation and I'm going to post that and paste that into my put. And then here, instead of doing a get, we'll actually do an update. Now, a put is basically a replace operation. but we're going to treat it in this case as kind of like an update. If you were going to try to go pure REST service conventions, you'd actually want to delete the original one and then add this one as a new one to it, potentially with the same ID. But in this case, we're just going to treat it as an update operation. As we said before, REST services are a convention, not an actual standard. So you can adjust these for your own organization based upon whatever your particular needs and requirements are. So we have our con update, and then we're going to come into here and just change this to the request.body. Now, technically, we have this widget ID coming in on the URL. Just in case there's a discrepancy between the ID on the body and the ID on the URL, I always do this. I say request.body.widget, actually request.id equal to request.params.id, just like that. So I always override whatever the ID on the actual widget is with the one from the URL. And then in my update operation, it will actually look at the ID on the body and actually use that to perform the update. And then finally we'll return back the one that's actually updated. There you go. So we've now built out our REST service. So let's go ahead and restart our REST service here, and we'll give it a try. So now we're running on port 3000. Whenever I make changes to my REST service operations, I always like to do a GET request first, just to make sure that everything is good in terms of I didn't break anything, major in terms of adding the new functionality. So we'll just do a GET, click send, and we get all of our widgets back. So now what we're going to do is we're going to go ahead and add a new widget. So I'm going to come under raw here, and just to save myself a little bit of typing, I'm going to copy one of the widgets, and I'm going to change this from a get to a post, and my content type is going to be application JSON, so make sure you select that there, and then I'm going to paste in my raw payload. Now this of course is expecting JSON, and we are inserting, so I can get rid of the actual ID that will be added as part of the insert process, and we're going to add widget 4, so we'll put 4, and we'll just make up another color, yellow, and we'll make the size tiny, and we'll set the quantity to be 23. So now we have our properly formatted JSON data, we have our application JSON, we have our post, and we have our collection URI. So now if we click send, we can come down here and we can see we have our new widget with an ID of 4. So let's go ahead and try the update operation. So we're going to switch this over to put, and we'll come in here and change our quantity to be 40, and we'll click send. So it looks like our request failed. So let's see if we can figure out why. We have our ID 4 up here, and we also have our widget that we're updating. Now we did leave the ID off of here in terms of trying to do the update, but it still should have worked because it should have copied the ID off of here and actually put it down here on the object when it sent it to the update method. So let's do this. Let's go back over to our code and let's take a quick look at something here real quick. So we have our ID, request body.id, that looks good. And then we have request params dot, oh wait a second, we have .id, and that really should be widget ID. Not only that, we also have to make sure we do the whole parseInt thing. So let's just copy this piece of code right here, and let's do our integer conversion and put that down there. There we go. And we'll come down here and actually restart our node service. So now that that's restarted, we'll come back over to our client. Now of course, since we restarted it, we actually lost the widget 4 that we had created. So we'll just come in here and we'll delete the widget 4, and then we'll do a post operation, and this should add the widget back. So we'll say send, and there's widget 4 added back. Now we'll switch this back over to a put, and we'll say /4, and then down here we'll actually come in and add our ID :4, and then we're going to change the quantity. Since we inserted it with 40, we'll change it back to 23. And we'll say ID 4, widget 4, color yellow, size tiny,
23. We'll go ahead and do our send. Here's our result, and now we have a quantity of 23. If I wanted to change it to a quantity of 50, I could say 50 and send, and now it has a quantity of 50. And if we actually go back over to our regular Chrome browser and reload, there we go. There's our widget 4, yellow tiny 50 with an ID of 4. So now we have the ability to add new widgets as well as update existing widgets. Next, we're going to take a look at authentication with Passport. Most of the time when working with REST services, we definitely want to have the ability to validate that a person is actually logged in and is allowed to perform the REST service operations they're going to perform. Passport is the common way of doing this with Express applications. It works for both traditional web apps but also REST services as well. Passport's great because it provides lots of different strategies for how you want to do authentication. You can have user accounts, you can do like Facebook, Twitter, Google, other third-party integration, OAuth, OAuth 2, WS Federation, SAML2. We're actually going to use JSON Web Tokens. These are particularly useful when working with REST services. So you can go to the Passport website at passportjs.org, and you can actually look for different strategies that can be used beyond just JSON Web Tokens if there's other ways you want to do authentication with your REST service. Passport typically relies upon Express Session middleware to work with session-based cookies to track logged-in users. This is what you typically find in a standard web application where the user is using a web browser, interacting with the website, going from page to page to page. However, sessions are not required. So for example, if you have some type of API key system where an API key is provided on every single request, the information that actually does the authentication is there, so you don't have to use cookies to track the authentication of every single request. Well, what we're going to do is we are going to do this with JSON Web Tokens. They will be our API key type of data that we'll send up on every single request so that the REST service knows that we've been authenticated against it. Now, to use this strategy, we're going to have to install the Passport-JWT package. This is going to provide us the actual strategy that will then hook into the Passport module for setting up our authentication. Now, JSON Web Tokens are based upon an open standard. It's RFC 7519. You can go read more about it. Fortunately, because we're using this package, we don't have to worry about all of the implementation details. We just have to actually configure it and then start using the tokens. Now, the JSON part of JWT basically means that JSON is the data format to what is known as a claim-based system. So the claim itself is going to be stored in a JSON data format, which makes it particularly well suited here for working with our REST services. Now, the web token part of JWT is the claim itself, and it's structured with a header, payload, and a signature. The header typically contains the type of token and hash algorithm that's being used. The payload contains the claims themselves, and the signature is really just a hash of the header and payload values that we can use to verify the sender. In fact, there's a nice little debugger tool at jwt.io. If you click the debugger link at the top, you can go down to the debugger tool and try out different tokens to see how they get validated and the information that they contain. So let's do a demonstration of doing Passport authentication with JSON Web Tokens. So the last step for our REST service here is to actually set up the JSON Web Tokens. We're going to have to install 2 additional packages for this to work. So we'll come back over to our Visual Studio Code. We'll stop our REST service. We're going to say npm i-s, and then we're going to say Passport, and then we'll say Passport-JWT. And this is actually going to install the Passport middleware as well as the JWT strategy for working with JSON Web Tokens with Passport. Okay, great. Now we've got our Passport package and Passport JWT package installed. So let's go over to our index.js file, and we're going to go ahead and pull these in so we can make use of them. The first one we're going to do is we're going to pull in Passport, and we'll say require Passport. And down here, we're going to go ahead and do a little bit of destructuring, and we'll do strategy. We'll call that JWT strategy. And then we'll also say extract JWT. These are both functions we're going to be using for actually setting this up, and then we're going to pull that in from the require passport-jwt. Now the next thing we're going to need, we're going to have to do some configuration options for JWT for this to work. So we'll create a variable here called JWT options, assign that to an object literal. The first one is the JWT request, and from that we're going to say extract JWT.from auth header. Next we have to specify our secret or our key, so we'll say secret or key, and for this we'll just say secret. Now this value is actually really important. In order to actually decode the JSON Web Tokens, this secret here has to match the secret that's used to actually encode them. So this has to equal the same value that's used to actually make the actual tokens themselves. And then finally, we're going to tell it what algorithms we're going to support. In this case, we're just going to do the JS2015. There we go. And also to match our from auth header here, let's actually change this to JWT from request. Okay, so now we have our JWT options. Now we need to actually register our strategy with Passport itself. So the cool thing about Passport is it doesn't tell you how to do your authentication. It gives you an overall framework and then a kind of a plug-in architecture where you can pick the authentication strategy that you want. And in this case, our authentication strategy are the JSON Web Tokens. So we'll say passport.use new, and then we'll do a JWT strategy. And we're going to pass in our JWT options that we set up above, and then we're going to have a callback function. And the first parameter is going to be the JWT payload, followed by a done function that we are going to invoke once we're done setting up our user. Now all we're going to do for this is we'll come in and say done null, because there's going to be no actual real like super hardcore authentication here. We're basically just going to take the payload and accept it for our purposes. And then we're going to set up an object here, and we'll just do name, and then we'll do the JWT payload. This is going to be the information from the decoded JSON Web Token, and we'll say .name. Great, we'll throw in a semicolon there. So now we have our Passport strategy configured. The last thing we need to do is actually configure our Express application to use Passport itself. So we'll say app.use, and we'll say passport.authenticate, and then here we're going to tell it to use JWT, so we give it the name of the authentication strategy, followed by some options, and we're going to specify session false. The reason we don't need sessions is that basically it's a REST service, so every request is completely independent of a previous request. And so the way this is going to work is that every time you make a request to the REST service, you have to present that token in order for it to work. So what we're going to do now is we actually have to go create a token. We don't actually have a token here yet to work with. And to create a little test token, we're going to go to the JSON Web Token website. So we're going to jwt.io. And on this website, we can actually configure a token to use. So we'll click on the debugger. That's going to drop us down to here. And this part here is the actual encoded token, and this is the decoded part. So this is the algorithm that we set up in our configuration. This TYP stands for type, and that's basically saying JSON Web Token. And then we have our payload data, and then we have our signature, and this is the actual word secret that we're using in our implementation as well. So for the name here, they have John Doe, so we'll just type in a different name and scroll up here, and you can see we have our new token. So I'm going to come in here and copy that. And then what we're going to do is we'll come back over to here, and we're going to start our little REST service up. Oh, looks like we have an error. Let's see what the error is. JSON from request extract JWT from auth. Let's see. Look, I put an equal sign instead of a colon. So let's fix that. And then
start up our service. Now that's up and running. So we're going to come over to here, and this time what we're going to do is we're going to do a GET request, and we're going to get all of our widgets. So if I say GET, and we actually don't need a header for that one, I'm going to do a send, and notice I get unauthorized, and we even get the cookie monster. So now what I'm going to do is I'm going to come back up to here, and I'm going to specify a header, and we can do the little headers form, and I'm going to specify an authorization header, and then the authorization header I'm going to say JWT, and then I'm going to paste in my actual token. It has to start with JWT. If it doesn't, then this will not understand that it's an actual JSON web token. So we'll click send, and now we got an OK, and we actually received our data. So now we've successfully authenticated with our JSON web token. So the key is just always including it in the authorization header, and of course starting it off with JWT and then a space followed by the actual token itself. JSON web tokens are really easy to get up and running with, and it's a nice convenient way for providing some authentication for your REST service. So in conclusion, Express is a Node.js web framework. It makes setting up the HTTP server a lot easier. It has great routing and middleware capabilities that really simplify the creation of REST services. Through the use of middleware, we can have multiple authentication strategies using, for example, JSON web tokens. Also, Express is a very popular, easy to use, and very flexible web framework. Welcome to this course on creating Node.js Express web applications. My name is Eric Green. This is brought to you by Wintellect Now. For our course overview, we're going to take a look at getting started with Express. We'll talk about how to work with static files and serve those up from the web server, how to configure routes, extracting data from the URL, as well as how to work with the request body and cookies, and then finally how to do authentication with the middleware package called Passport. For getting started with Express, this course is going to assume that you have some basic knowledge of Node.js and the JavaScript programming language. To be able to run these examples on your machine, you will need to have Node.js installed. You can go to nodejs.org and download it from there. Please make sure that you install version 6 or later. Also, if you do not understand the basics of these technologies, then be sure to check out the Wintellect Now courses on Introduction to Node.js, Node.js modules, as well as Node.js packages. So, what is Express? Basically, Express is a web framework that's used to configure Node's HTTP module. Node actually has web support built directly into it through the HTTP module. It's a very capable module, and it's actually not even all that hard to use. The problem, though, is that to build anything significant ultimately requires a ton of boilerplate code. And so Express is basically a framework which sits on top of that, which helps you as the developer build a web application eliminating a ton of that boilerplate code, providing all types of capabilities such as the ability to serve static files, to the ability to configure routing, as well as create middleware applications using the router, as well as work with a bunch of third-party types of applications that will help you configure that web server. Now, Express promotes itself as being fast, unopinionated, and minimalist. So basically, Express only does the processing that you need. It doesn't tell you how to build your web application. And finally, it relies upon a collection of middleware to provide the bulk of the functionality. Express is distributed via an NPM package, and it should be installed locally to each project, not globally. To install Express, you simply say npm install Express within your project/package folder, and you'll be up and running with it. If you want to check out the expressjs.com website, you can find out all the additional details that we don't get a chance to talk about in this course, so you can deepen your knowledge and understanding of how Express works. Express will provide support for routing. What do we mean by routing? When requests come into the web server through the use of a URL, that URL has a lot of different parts to it. For example, is it a GET request? Is it a POST request? Is it requesting files on a certain path? Are there query string parameters? Express helps you work with all these different kinds of data to figure out which request handler should actually handle the request. In addition to that, Express will also help you serve static files. It can serve up index HTML files or JavaScript files, what have you. Almost all other functionality, though, is actually provided through third-party middleware modules, such as processing the request body. The popular package for that is Body Parser. Working with cookies. The popular package for that is called Cookie Parser. Using session data is Express Sessions. Handling authentication, Passport is a popular one for that. Because Express itself doesn't bake all of these things into it, you have the ability to pick and choose the middleware packages that will work best for your application. So let's take a look at how to create a Hello World Express application. So let's go ahead and get started here by creating a Hello World style Express web application. I'm going to open up my Node.js command prompt here. I'm going to change to my folder where I put my projects, and I'm going to create a new folder called Web App. So we're going to change into the Web App folder here, and we're going to create ourselves a package JSON file. So we'll say npm init-y. It'll actually go through and just accept all the defaults and produce a file for us. And so now if we take a look at our folder structure, you'll see our package JSON. I'm going to install the Express package. I'm going to go ahead and make that an application dependency by marking that with a -s, so it will be saved to the package JSON. So I'm going to say Express here, and we'll let this install. Excellent, my package has installed. So now I'm going to open up Visual Studio Code. We're going to be using Visual Studio Code for all of our code editing for this project. And we're going to open up our folder here. So we have our web app. We'll select our folder. Over here we have our files. Here's our package JSON file. You can see where our dependency here with Express has actually been registered with the package JSON file. So now let's go ahead and create our initial file for loading up our simple web application. We're going to have to do a couple of different things here to make this work. The first thing is we're going to create a new index.js file. And we'll actually code our Hello World sample application inside of here. So I'm going to come up to here and I'm going to pull in a couple of modules that I'm going to need to get this thing set up. The first one is I'm going to actually pull in the HTTP module. So we'll say HTTP, and then I'm going to pull in Express itself. Now you'll notice here I'm using the const keyword to define these variables. Const basically means an immutable variable. It's not a compile time constant like you might think of in C++ or something. It's actually used to declare variables that are immutable. The variables HTTP and Express are not going to be redefined in my code. They're going to be assigned a value, which is the module being returned, and then they'll hold that value for the entire length of time the program is executing. Therefore, I'm going to declare them as constant. As a best practice, you should really declare all of your variables as immutable, and then only intentionally make variables mutable when you have a specific reason for doing so. Nevertheless, we have our HTTP and Express available. Now, the next thing we're going to do is actually set up the actual application, what we might think of as the web application that's going to be hosted by the HTTP module. So we're going to say const app equal to Express. There we go. And so now we're going to invoke Express because Express is a function object, and the resulting application object is what we're going to be using to actually configure our web application. Now the next thing we're going to do is we're actually going to set up a little server object here, and we're going to say http.create server, and then we're going to pass in app. Now when you go to set this up, you don't technically have to use the HTTP module. You can actually do this without using the HTTP module at all and strictly only using Express. But it's very common when building web applications to have other things like WebSockets want to hook into the actual server object as well.
And so by actually going in here and being explicit about using HTTP and creating our server, we're basically producing an object that can then be used by other things as well in our web application. So now that I have my server, I need to go ahead and actually configure some things on the application. The first thing we're going to be interested in configuring is where our static files are located. So we're going to come into here and we're going to say app.use express.static, and then we're going to list a file folder where we're actually going to have the files that we're going to serve up. So we're going to create a file folder called www. So we'll put our semicolon there. And then we need to actually set up the server to actually listen on a port. So we're going to say server.listen. We'll go ahead and listen on port 3000. And then we're going to set up a callback function that will basically say console.log web server started on port 3000. There we go. Okay, great. So now we have ourselves a little web server here. Now we need to actually create some content to actually serve up. So we're going to come into here and we're going to create a new folder called www. And inside www, we're going to create a new file called index.html. And our index.html is going to be the default file that's served up from this folder. So even if we make a request to the web server, but don't actually expressly say which file we want, this will be the one that's actually served. So let's go ahead and create a quick little web page here. We'll have our doc type HTML. We'll have our little HTML tag, head, title, and we'll say Express applications are cool. Title, and then close off our head. We'll put in a body, and we'll do an H1 there. Everybody loves Express. And actually that's almost kind of true because Express is one of the most popular packages available on NPM. Alright, there we go. So now we have our simple little web page right there. And so the next thing to do is actually start up our web server. So the nice thing here in Visual Studio Code is that I'm using the Insiders edition, which means I can have multiple terminal windows. So I'm going to hold down Control and backtick, and you're going to see a terminal window pop up here. And if I do a directory listing, you'll see there's our files. So I'm going to come into here, and I'm actually going to fire up our web server, although it looks like I didn't save our index file. You'll see the 0 right there. So let's go ahead and save our index file. That way it's not 0 anymore. And then we can actually fire it up. We'll say node index. We now have a web server started on port 3000. So we're going to come over here and open up a web browser. And we'll go to localhost 3000. And now you can see everybody loves Express. There we go. You can click refresh. It'll reload the page. All is good. Now, this little hello world web server is good and useful, but we have a couple of things in here that we probably need to fix. First of all, we're hard coding our folder here and our port number. This is really not ideal. What if we needed the ability to run it on a different port number? Maybe even on your machine, port 3000 is being used by something else. Wouldn't it be nice if you didn't have to modify the source code to actually change the port number or to change the actual folder path? So one of the things that is becoming increasingly popular in the Node development world is to actually come into your package.json file and specify your additional configuration inside of here. We could create another file if we wanted to, but it's actually pretty easy to come in here and specify some defaults. So we'll come into here and I'm going to say web server, and then I'm going to set up a root folder and then the port number. So we'll just call it folder. Remember, this is JSON, so you have to have quotes around the property names. Folder, and our folder value is going to be www, and then our port number is going to be 3000. Now, once I have those values in the package JSON, I now need to actually load this configuration up. So to do that, I'm going to come back over here to my index file, and I'm actually going to do the following. I'm going to say const fs equal to require fs. Now what I want to do is I want to read this file, read the package JSON file, and then I want to JSON parse it so I can extract my web server configuration values from it. Okay, so we're going to come into here and we're going to say const, and we'll say options, and then I'm going to say fs.read file sync. Now, almost always it's a bad idea to do synchronous file operations in Node. There is, however, one exception, and that's on the initial loading of the application, especially when reading configuration files. Until I read the configuration, the program can't run anyways. So using synchronous operations for reading the configuration is kind of an acceptable, okay thing to do. And it's going to make our code here a little bit easier. So we'll go ahead and say read file sync, and then we're going to open up the package.json file, and that will actually read this text out of the file and make it the return value, and then we'll simply say json.parse. Of course, we're not really doing a whole lot here to handle any kind of errors, but we're going to go ahead and assume that our package JSON is in fact legit. If it wasn't a valid package JSON, we'd probably have a lot of other problems before ever getting to this point of trying to read the options. Now, what we're going to do is we're going to take our options here, and we are going to come down here and we'll say options.webserver.folder, and then we'll take these values here and say options.webserver.port, and then we're going to change this to a new template string in ES2015, and we're going to use the little template variable here. There we go. So now, if we collapse this over here, we're going to read in, we're going to require our file system module. We're going to read in our package JSON file. We're going to get the options off of it. Then we're going to set up our web server. We're going to set up our folder for serving files. And then we're going to come down here and configure our port. Oh, and we want to make sure that that says port as well. Okay, so we'll come back over here and open up our window for our terminal. Once you close the terminal window, you can actually, or once you collapse it over here by hitting the down arrow, you can reopen it again by hitting the control and backtick. I'm going to stop my web server. I'm going to say node index again. And you'll see once again I have a web server started on port 3000. I will come to Chrome. I will reload my page. All is good. Now let's say, for example, I didn't want to run it on 3000 anymore, and instead I wanted to run it from port 3010. So I'll make my change. I'll rerun the web server, and now it's running from 3010. And so by taking this approach, I have the ability to configure these options. Now, of course, you wouldn't want to put any sensitive information in the package JSON file, because ultimately that file is going to get pushed up to the NPM repository if you choose to share your code with the rest of the world. But it is useful for putting in options like this. And then I'll come into here and say 3010. And once again, you can see we're loading up our Express website. So now we have ourselves a configurable little hello world web server that can serve up some static content from our folder. And we've been able to use Express now to basically build a little web application. Working with static files. This is actually support that Express has directly built into itself. You can use the express.static function to actually specify the path where static files will be served from. Now, static file handling also supports several options. These options can be passed in as the second argument to the static function call showed on the previous slide. Here are two of those options. One is you can actually change the name of the default file inside of a folder when no file is specified. So typically the default file is index.html. But if you decided you wanted the default file to be index.htm, you could change that inside of your static options. Also, you can specify a function that will allow you to set any additional headers. So if there's headers you want to set in your response to the requester for whatever reason, you can do that through the set headers option. So let's take a look at how to serve up static files. So let's take a quick look at how we can use this static file handler and set some configuration options on it. Also take a look at serving up some additional files beyond just the index HTML. So coming back over here to our index.js, we're going to actually set up some additional files over here. You notice we now have a clouds.jpg, little JPEG file right here. We're going to go ahead and come under ww, and we're going to create a new folder here called images, and we'll move the clouds file into the images folder. There we go. And we're also going to add a couple of additional folders underneath of here. We'll add one for JavaScript. We'll just call that one JS, and then we'll add another folder under here called CSS for some style sheets. And so we're just going to create a very simple file for each of these, and then we're going to let them be loaded up inside of our index.html file. So underneath style, let's go ahead and create a new file, just called it site.css. Then we'll come into here and we're just going to do body, and we'll say font size 100%, and we'll just go ahead and zero out the margin and the padding there. Kind of like a little mini reset. And we're going to save that file, and then under JS we're going to create another new file, and we'll just call this one app.js, and then here all we're going to do is just say console.log test. So our goal here isn't so much to like build client-side content, but understand how the server is going to be able to serve this up using the static module. So coming over here now to our index.html file, let's go ahead and reference these files. So we'll have a link tag here to load up our style sheet. So we'll have href css, which we'll do /css/site.css. Our relationship for this is going to be style sheet, and then we'll close off our link tag. We'll come down here to our body, and we're going to say script source, and then we'll do our js/app.js script. Let's put a slash in front of that. We'll make it off of the root of the site. You may notice I'm using single quotes versus double quotes. That's just because that's how I typed it in. Most HTML folks prefer using double quotes in the HTML and single quotes in the JavaScript, although it doesn't really matter. HTML is happy with single quotes, and JavaScript is also happy with double quotes. So now that we have that, let's go ahead and add a reference here to our image as well, so we can pull up that image. And we'll say source/images/ and we called that thing clouds.jpg. Great. Okay, so now we have an image tag. Our web server here is already running, so we'll go over to Chrome, and we're going to reload our web page here, and we'll zoom out a little bit. Let's see here. Our picture is super huge, so why don't we actually add a style in here for our picture, and we'll say image, and then we'll do a width, and we'll set the width to that to be 200 pixels. That'll cause the image to basically resize itself. Reload it now. Great, now our image is small. So if we actually open up our developer tools here and go to the network tab and reload, we're going to see that using the static file handler, we were actually able to load up our HTML document, our style sheet, our JPEG file, and our JavaScript file. And we can see from the type here that basically this static file handler knows how to take a file off the file system and using the extension determine what type of file that it is. Based upon the extension, choosing the right MIME type and then sending that down as the content type for our static file. So that's actually really helpful. If we were to actually write our own code for reading the file off of the file system, we would have to do that extra hard work of actually figuring out what the content type was when sending back the response. So using the built-in static file handler is very helpful for getting things up and running very quickly. Now, in addition to this, we can also do some configuration options on the static middleware as well. So jumping back over here to our editor, we're going to close out a couple of these files here. We don't need all these files opened up. And we're going to come back in here into index, and we'll go ahead and collapse that. And we can pass in some options here as the second argument to static. So we're going to pass in an object, and we can actually change like what is the actual default file. For example, if you notice here, we don't actually specify index.html. That's just kind of the default one loaded from the folder by Express. But if we wanted to make it a different file, we could say index, and then come into here and say index2.html. So we'll go ahead and save that. We of course now need to create an index2. So we'll copy this, and we're going to paste that into here. And we're going to take that and rename it to index2. And we'll just say alternate index file. Save that. Open back up our window. Make sure you always restart Express after you're done making your changes. So we're going to kill the web server process, restart it. Now when we come over here and reload our page, watch what happens. It says alternate index. We still haven't specified our file, and so it's going to grab the index2.html because that's the new default index that we specified. Now I can still get to index if I actually type in index and I'm explicit about loading up that file, I can get to it. It's just if I leave off the file name, it's going to serve up index2.html instead. We can also set it up so that we could set, for example, some custom headers when sending back static content. There's a set headers option here, and we can actually come into here, and it gives us a bunch of different information. We can access the response object, we can get the path of the file being requested, we can also get the stat data of the file being requested. In this case, we actually just want to set the header. So I'm going to say res.set, which this will basically set a response header on the response object. And then I'm going to give it a name. We'll call this X, and we'll say custom header. And then if I want, I can put, my Express app. Whatever you might want to actually include in the actual header. So we're going to save that, come down here and reload our actual web server application. So we'll kill it and restart it again. And then we'll come back over here to Chrome, and we're going to reload our page. There we go. And now if we come in here to index.html and we go to the response headers, you'll see our X custom header, my Express app. You can also see where Express itself actually adds its own header, X powered by Express. So with the static file handler, we have a fair amount of flexibility in terms of how we want to customize the response, even though it's taking care of the hard work of loading the file off the file system, setting the content type, etc. So the static middleware that comes with Express is extremely useful, and you'll find that you'll use it for most web applications that you work on. Routing requests is based upon several different factors. First, what HTTP method is actually being used? Get, post, put, delete, and there's many more. But those are the common ones, especially get and post. Based upon the method or the verb, which handler should handle that? Express routing can take that into consideration. Also, we have the URL path. So basically, what is the path of the URL? So if you take a look at your URL, you'll have like a domain name, a protocol, a port. Well, after the port, that / based upon the path, Express can basically take a look at that path and determine, based upon that path, what route handler should be used to handle the request. Each handler function is passed a request and response object. This allows the handler function to access information about the request, as well as to help build or generate the response. Also, multiple handlers can handle the same request. A next function is provided in each handler such that if the handler wants to pass on control to the next handler, the next function can be invoked. So let's take a look at some of these routing requests and take a look at how the actual routing works. For example, if we use app.use or app.all, that will match all HTTP verbs. If we say app.get, that will only match get verbs. There are similar functions for post, put, and delete, as well as
all of the other methods that are available for working with HTTP. So let's take a quick look at how we can route requests.
So let's take a look at how we can set up some different route handlers here and take a look at how we can actually run multiple route handlers and kind of chain them together. So up here what we're going to do is we are going to set up an app.get, and we're just going to kind of create a very simple little URL path here that's going to be handled by this particular request handler, and we'll return back just some arbitrary data, and we can take a look at how we can catch these requests and then handle them. So for example, if I want to hook into specifically get requests, so earlier we were using app.use, and this will kind of pay attention to any type of verb unless you do something to make it more specific. So in this case we're going to do something to make it more specific, and we're going to actually specifically listen for get requests, and we're just going to have a get request here for /demo, and then we'll have our function here, and we'll go ahead and say request and response. And for our response, we're going to set this thing up to basically just say response.json, and then we'll just pass back message, and we'll say demo, just like that. And that will allow us to send back some data. And this JSON function, by the way, basically takes a JavaScript object, converts it to JSON text, and then sets the content type of the response to application JSON. So it's really convenient for working with JSON data. And we'll also output to the console here, console.log. And we'll just say handled demo request. So we'll be able to see both in the web browser that this particular route handled the request, but we'll also be able to see that in the console as well. Now remember, whenever you make a change to your Express server, you need to make sure that you restart it. So we'll say node index. And we'll load up a web browser here. We'll go to localhost 3010. So there was our page we had before, but now we're going to put a /demo on here, and we'll hit enter. And when we do that, you see we get our message demo, and then down here we have handled the demo request. Now you'll notice that the static handler didn't do anything. Basically, this get handler right here handled it, and then that was it. So when we said response.json, that basically sent back the data and ended the process of handling the response itself. Now, you can set this up to work with put requests and delete requests and posts and stuff like that, especially if you are building like a REST service. Working with put and delete would be very important. Later on in the course here, we're going to be taking a look at working with post requests. So basically handling form posts and being able to handle AJAX calls and that kind of thing. But for right now, we'll just stick with get. So what if I wanted to be able to configure this thing to have multiple handlers for this /demo? How would that work? So what we're going to do is I'm going to copy this piece of code right here. Let me actually lower that, give us a little more working space. And I'm going to paste that in there like that, and we're going to get rid of our response JSON. But I'm going to change my console log here to be 1 and 2. So in order for both of these handlers to process this request, I'm going to need my next function. So now I can come into here and say next, like that, and this function will process it first, then this function will process it here and ultimately send back our response. So going back to our command prompt here, we'll go ahead and restart our web server. So there's our web server being restarted. We'll go back over to Chrome. I'm going to reload the web page. You can see I get the same result back, but now you'll see where we handled it with our first handler and then with our second. Now you might be wondering, what's the usefulness of this capability? When you work with middleware, for example, body parser that processes request bodies, you can basically use the middleware to handle the request, do some data processing, set up additional properties on the request, or maybe set headers on the response, and then you can have another handler to continue processing that request. So if body parser were to process your request body, you could then use that request body in your own code and actually take that data and do something with it. So you kind of have both parts working together. So in this case, what we could do is we could come into here and say request, and we could actually add a property to this. And let's just say demo data, and we'll just set this equal to demo. And then down here, instead of hard coding demo like this, we'll say request.demodata. The request object passed into here is exactly the same one that's passed into here. And so by decorating this request object with this additional property, we can basically share data between these two handlers. This is exactly what body parser does, except for body parser, instead of calling it demo data, it actually calls it body. And then down here you can then access the body. So let's go ahead and save that, and we will restart our server once again. There we go. And then reload here, and you can see we get the same result, and both handlers did the actual handling of the data. If we wanted to just do change up the value here just to verify that it works for fun, we could kill that there, restart it, and then head back over to Chrome, reload, demo test. So now we have multiple handlers handling the same request, and they're specifically paying attention to a GET request, and we're looking for this particular path to actually handle that request. To extract data from the URL, we have to understand all the different parts of the URL. So here we've got the protocol, in this case http://. We have a domain, www.some-domain.com. We have a port number, in this case 8080. While these are important parts of the URL, these are not overly interesting to Express, because Express is interested about what happens after the port. So take a look at our path. We have /person/2. Express has the ability to look at that path and extract the values out of that path as actual parameter data. For example, that 2 could be a parameter value. And so Express has the ability to extract that 2 out and make it available on the params object so that that value could then be used in the handler for processing the request. In addition to URL parameters, we have query string parameters. So these are the ones that come after the question mark. And so you have the name of the parameter equals and then some value. These are available on the query property of the request object. Now the final part, the hashtag home, is the client-side parameter. This is actually used for anchor tags or for client-side routing for big frameworks like Angular or Ember or Backbone, what have you. That hashtag home never actually gets sent to the server. That's totally used only on the browser side. So the Express then is interested in extracting out path information as well as query string information to understand how best to handle the route. So let's take a look at working with URL parameters and query string values.
So what we're going to do is we're going to come up here and actually wire ourselves up a route that's actually going to have some of this information in it. So we'll say app.use, and then we're going to wire up this route to hang off of this endpoint right here. We'll just call it demo, and we'll say slash, and then we'll come into here and we will do a colon, and then we'll just say ID, and then we'll put in our handler function. There's our request object and our response object. There we go. Now we can actually access the ID parameter off of a params property that will be made available off of the request object. So if we come into here, we can actually just do the following. We'll say response dot send, and then we'll say params plus, then we'll just do json.stringify, and we'll pass in request.params just like that. And just to keep our application consistent, we'll switch those over to single quotes. Excellent. So we'll go ahead and save that now. We'll fire up our application with node index. There we go. We'll load up our web browser here. Localhost 3010. And then off of this, we're going to say demo/3. And you can see there's our parameter with an ID value of 3. Now, let's go ahead and set this up to actually get some query string values. So we'll come into here, and we're going to add one more thing to this. And we'll simply do and then off of the request object here, we can access those query string values like this. So we'll go ahead and save that. We'll restart our web server here and go back to the web browser. We can reload. We'll see we have no query string values. So we'll come into here and I'll put one on there. We'll say name equal to Bob. And now you can see we have a query string value. So Express is going to automatically parse both of these off of the URL so that we can then access them off of the params property and the query property.
Working with the request body requires additional middleware. Express itself doesn't actually have it built into itself how to actually deal with a request body. The request body of a request made to a Node application is available as a stream. Now, you can deal with this stream yourself manually if you want, but there's middleware software that can be used that will do that for you. For example, there is Body Parser, and Body Parser will be used to process URL encoded or JSON content. URL encoded is the typical format when posting like a form to the server, and JSON is commonly used when making AJAX calls. There are other packages, though, that'll help with file uploads. Multer is an example of one of those. It will actually process file uploads and then allow you to save those files to the file system. The way that Body Parser determines how to process the request body is based upon the content type of the request. If the content type, for example, is application JSON, it will treat the request body as JSON and actually run that through the JSON parser and provide you a JavaScript object to work with inside of your route handler. It makes that data available through the body property on the request object. The key to using Body Parser, though, is to make sure that you have it loaded before any routes which need access to that request body data. If you try to load it, later on in the request processing process, all of the handlers that encounter that before Body Parser will not have access to that body property. So let's take a look at a quick demo here of how to work with URL encoded in JSON data from the request body.
So in this video, we're going to take a look at how to pull data from the request body. Now, I have a little web page set up here that's going to allow us to have a form where we can type in some data and then be able to submit the form either using the traditional URL encoded format, which is kind of the standard thing when doing a submission with a form element, or to actually take the data and do it in a JSON encoded format. For both operations, we will be using the XHR object to do an AJAX request. We're just going to encode it differently, as well as set the appropriate content type header. Now, if we come over here and we actually fire up our web server, we'll say node index. We have our web server started on port 3010. I'm going to come over here to Chrome, and we'll load up our web page here. And you'll see I have my form. I've already pre-filled it out for us to make it a little bit easier. I'm going to open up my developer tools. I'm interested in taking a look here at the network tab. And so what I'm going to do is I'm going to go ahead and click send on this, and this request is going to fail because we haven't implemented the actual handling of request bodies in our web application yet. But we'll click send, and you can see there's our contact request, and if we click on this we can actually see the details here. And I'll move this up a little bit, and you can see where we did a post to /contact. And if we scroll down, you can see we have our actual form data here. And if we do the view URL encoded, there it's all encoded. And if we view the source, you can see the traditional URL encoded string down there. Now we're going to come up here and we'll change this to do JSON instead. We'll click send. Here's our request with JSON. Scroll down. Our content type is set to application JSON, and then down here you can actually see we have the JSON data. So now we're going to wire up our Node application to actually be able to handle this. And we're going to be using something called body parser. It's in one of the Express middleware options, and it can handle this this request body data for us, and it knows how to actually transform the URL encoded data as well as the JSON data into an actual JavaScript object. So I'm going to switch over to Visual Studio Code here. First thing I'm going to do is stop my web server, and I'm going to go ahead and install body parser. So this is just a regular Node package, and it'll be downloaded and installed. Great, now it's installed. So we'll come back over here to index.js, and we're going to scroll to the top, and we're going to add a reference to this. So body parser require body parser, just like that. Now we're going to come down here, and we're actually going to wire up the endpoint. So we're going to say app.use, and then we're going to set this up off of contact. Now we'll go ahead and wire up our actual handler function first for outputting the data. So we'll say request and response, and then for this all we're going to basically do is say response.send, and then we'll have some post data here, and then we'll just add that to the end. Here we'll say JSON stringify request.body. So basically, regardless of how we actually receive the data, we'll just send it back to ourselves as stringified content, so we can see the result of our request. So now we have to actually come in here and wire up the actual handling of the request body. So we'll say app.use, and then we're going to come into here and say contact, and then we're going to actually wire up the URL encoded one first. Now, I don't have to specifically do this off of contact. I could set it up so that all requests were actually processed by body parser, but in this case I just want the ones to /contact to be handled. So I'm going to say body parser, and then I'm going to say URL encoded, and then I have to pass it an option here called extended, and this is just going to choose the QS library for doing the actual parsing, and we'll say extended equal to true, and we'll go ahead and save that. Now what I'm going to do is come down here and say node index, and we'll fire up our web server, and then I'm going to come over to Chrome here, and now what I'm going to do is I'm going to switch this back to URL encoded data. We'll actually clear out our previous requests. We're going to click send, and now you'll see it comes back with a status of 200. So if I click contact and come under response, you'll see that here is my actual data. So it actually got sent up doing a URL encoded format, and you can see the data here that came back. So if we actually go back to the headers, you can come over here, view the source, and see that we actually did send it up as URL encoded data, and there's our content type. Now let's go ahead and wire it up to work with JSON data. So we're going to come over to here, and we are going to add another app.use/contact. So now we're going to say body parser.json. There are no options that we have to pass with this one. Now you might be wondering, why can we set up the URL encoded and JSON both on the same endpoint? Basically what body parser does, it looks at the content type of the request body to determine which parser to run. So for example, in the case of the JSON, if it sees the content type is application JSON, then it'll run the JSON function to actually parse the request body. So we'll go ahead and save that. We'll restart our web server, and now we'll come over to the web browser. We'll switch this over to JSON data, and then we'll click send. Now if we come over to here, we can see our response with our data. Come over to headers, you can see where we have application JSON, and then this was actually our payload source here.
Cookies are little pieces of information that we can basically write to the header and can be stored in the browser. Cookies have been around for a long time, and they're incredibly useful. They get a little bit of a bad rap for being used for tracking people for marketing purposes, but they're also heavily used when tracking session cookies for logging into your bank account, or logging into anything really. The most common middleware for working with cookies is the cookie parser. Express has the ability to write cookies out, but it doesn't have any built-in ability for actually processing cookies that are sent up in the request. That's what cookie parser is used for. And so you want to make sure you run the cookie parser middleware before any routes in which you need access to those cookies. When you actually do use Express to write out a cookie in the response, all it's basically doing is doing the set cookie header for HTTP. So let's take a look at how to enable cookies with middleware.
So the first thing we need to do is actually install cookie parser. So we're going to say npm i-s cookie-parser. We'll hit enter and that will be downloaded from the npm repository and installed. Now we're going to come up here right underneath body parser and we'll say const cookie parser. And then require cookie parser. There we go. So now that we have cookie parser, we need to register it to basically run on all the requests. So we'll just say app.use cookie parser and then run the function just like that. Perfect. Okay. So now that we've done this, we're actually going to write a little bit of code to actually set some cookies and retrieve the cookies. So we'll come down here and we'll just add a little app.use and we'll have our function request response next. And then what we're going to do is after we process our cookies, we'll actually have it proceed to the next handler. And the cookies will be made available to us on the cookies property of the request object. So we'll just come in here and say console.log request.cookies. And then we can also set cookies by doing response.cookie. And then we can give the cookie a name. So for example, we'll just say demo cookie and it'll have a value of test. Now on the initial request to our web server, we won't have any cookies. So we'll actually basically output nothing here for request.cookies. But then on all subsequent trips to the web server, we should have a demo test cookie. Now in order to test this, we're actually going to run Chrome in incognito mode so that we'll basically start off with no cookies every single time. So we'll save that. We'll fire up our Node server. Perfect. We'll come over to Chrome and we're going to go over and fire up a new incognito window. And we'll say localhost 3010 and hit enter. Our page loaded up. And then we're going to come back over to here and we can see the output. So you can see on the first request there were no cookies, but then the subsequent request, actually the one for the CSS file as well as the JavaScript file, both had the test cookie attached to them. And if we actually come back over to here and reload the page again and come back to here, you can see we have 3 more tests. So working with cookies is pretty simple, and it's going to be necessary for our next module where we're going to talk about how to work with logins and actually using session-based cookies to verify that somebody has actually logged into the web application.
Authentication is a very common thing done on web applications. The ability to basically have a user provide some type of credentials or maybe work with a third-party site through OAuth or OAuth 2 is very, very common. And Passport is the package that's used in Express applications to do that. Now, Passport is great because it provides a bunch of different strategies for authenticating users. You can do something simple like authenticate a user against a local database. You can hook into third-party providers like Facebook, Twitter, Google. You can hook into also any other type of OAuth, OAuth 2, WS Federation, SAML2 type of provider for authenticating your users. Passport relies on the Express Session middleware if you want to have session-based cookies to track logged-in users. This is common for web applications where the user is actually going to interact with a website and do a bunch of different operations, such as manage their bank account or manage their frequent flyer account or what have you. Sessions are not required to use Passport though. So let's say, for example, your web application isn't something a user really directly interacts with, but is instead like a REST service. And you want to use like an API key, and that API key is going to be used on every single request. In that case, you don't really need sessions because the the information needed to authenticate is actually located inside of every single request. So you can still use Passport for those purposes as well. So Passport is definitely well suited for using for user applications as well as REST services. You can go to the Passport website, and they'll have a bunch of different strategies that can be used, and you can kind of search through them and look for the one that's most appropriate for your situation. So let's take a quick look at a demonstration of how to use Passport authentication with session cookies in our Express application.
To get started with authentication, we're going to have to install some packages. We'll come down here and say npm i-s. We're going to be installing Passport, which is basically the middleware used for doing the authentication. We're going to need to install Passport local, which will be our strategy for how we're going to accomplish the authentication. And then finally, to support the session-based cookies, we're going to have to do express-session. So we'll go ahead and install these. Great. Now that we have them installed, we can actually start making use of them. So up here, the first thing we're going to do is actually pull in the session. So we'll say session equal to require express-session. We're also going to need Passport, so we'll say const Passport equal to require Passport. Then finally, we're going to have to pull in our local strategy. So to pull in our local strategy, we'll do a little destructuring here. Strategy, and we'll call this local strategy like this. And then we'll say require Passport local. Great, we now have our modules that we need to do our authentication. So we're going to come down here and we're going to set up a few of these to do some processing of data so that everything will actually work correctly. So the first one we're going to actually configure here is Passport itself. So we'll say passport.use new local strategy, and we'll pass in some options here. Now, these options are not really required for our login form because we've kind of named things appropriately, but it's very possible you could be using different field names for your form, so I'll show you how to set these things up. For the username field, the default is, of course, username, but you could actually make that be like an email address, what have you. And these correspond to the actual names of the fields on the HTML form that get posted up. So we'll say password field, and then password. Now that we have those options configured, we need to set up our function that's actually going to give us access to the username and password, which is submitted, as well as a done function to call once we're done doing our processing. So it's inside of this code right here is we're actually going to write our authentication thing. We're going to authenticate against like a local database, what have you. Now I actually happen to have a little local database file that we're going to use for our demonstration. If we go to database.js, you'll see it here. Basically what I've done is I've got two users in the system, Bob and Jen, and I have their password stored as a hash value. And then down here you can actually see where I'm doing a SHA-256 hash with our secret value, which is called secret, and then ultimately taking the password and digesting it out to a hex value, where we can see if the password entered in by the user properly hashed out actually matches the hash value found here in the user list. So now we'll come back over to index.js and we'll actually pull in this little database program, little database module, database equal to require /database. And then we'll just simply come into here and say if db.authenticate username password. So if it authenticates, we'll do one thing, and if it doesn't authenticate, then we'll do something else. So if it authenticates, we're simply going to say done, null because there was no error, and then we'll pass back an actual object. So we'll just come in here and say username, and then we'll just pass in the username, and that'll actually be our object. If you wanted to, you could populate this with more information about the user. And then if it doesn't work out, we'll say done, null, and then pass back false. And that will indicate to Passport that the authentication in fact failed.
Now that we have our authentication mechanism in place, now we need to work on how we're going to work with our sessions. Basically, we need the ability to serialize and deserialize our session data on each and every request. So to do this, we're going to set up our sessions here just as a simple map. So we'll say const sessions equal to new map. This just allows us to have a key value pair, and we're going to set it up to where we have our session ID as the key and then the session data is the value itself. So now we need to actually serialize and deserialize our user. So we'll say passport.serialize user, and then we'll have our function which will pass in our user and then our callback function there. And we'll go ahead and do our sessions.set, and we'll actually just key this off the username since that's going to be a unique value, and then we'll pass in our user. And then finally we'll call our callback function null user.id. So that'll actually take care of serializing the user. We also need to be able to deserialize the user. So deserialize user function, and this time we'll actually get the user ID, not the actual full user, because we're going to be deserializing that. Then we'll call our callback function null session.get user ID. Great, so now we have the ability to serialize and deserialize our user. Obviously this would not scale very well. You're basically limited to the users always coming back to this exact same web server. So if you were setting up like a cloud solution or something, this simply just would not work. But for our little demonstration, we can do a little in-memory session storage. Now the next thing we need to do is actually configure Express itself. So first we have our cookie parser already loaded up from an earlier demonstration. We're also going to need to actually grab our body parser here and actually work on all of the requests. Now we could set it up just to work with the login form and the contact form if we wanted, but for simplicity's sake we'll just set it up to pay attention to all the requests. We'll go ahead and comment out this code here from our earlier demonstration. We don't need it anymore. Okay, so we have our cookie parser, we have our body parser. Next we need to actually configure our session data. So we're going to say app.use session, and then we're going to specify some options here. We'll say resave false, save uninitialized true, or actually make that false. We only want to save initialized sessions, and make sure we've got our initialized. There we go. And then we'll need a secret. So we'll just say secret, and then we'll do a secret like this. Okay, so after we've done that, we now need to actually register passport with Express. So we'll say app.use passport.initialize, and then app.use passport.session. There we go. So we'll go ahead and save that. Next we need to go ahead and wire up our login route. So we're going to say app.get, and when we have our /login, we'll set up our handler function request response. And then for this we're simply always going to return back the login page. And so we're going to pull in our path object up here. So let's go ahead and do const path equal to require path. There we go. And we'll save that. So we'll come back down to here now, path.join, and we'll do our dir name, comma, www login.html. There we go. So we'll serve that up. We need to actually also add a login HTML to our page, but we'll do that in a second. So now that we have our handler for actually serving up the login file, now we need a handler from when we post back to the server. So we're going to say app.post/login, comma, passport.authenticate. Tell it the name of the strategy we want to use, which is local. And then we have to set up some redirects. So we'll say success redirect will be the actual home page, and then the failure redirect will be the actual login page once again. There we go. So now we have the ability to actually authenticate our requests by making a post request to the login form. So now we're going to add one more handler in here, general purpose handler. And this will simply just check to make sure that we're actually logged in for other requests. So our request, response, next. There we go. And when we get authenticated, it actually makes the user available as a user property on the request object. So we'll say request.user. And so if a person has not authenticated, there will be no user object or user property off the request object. And we'll simply have them redirect to /login and return. Otherwise, we'll have them go to the next handler. There we go. So now we have the ability to basically check to see if the person's logged in. If they're not, they'll be redirected to the login form. And if they are logged in, then the rest of the actual application will run, handling whatever requests they make. So what we're going to do is we'll come over to here, and under www, here's our index page. So we'll say you made it. And now we need to add a login HTML file. So we'll just come under here, add a new file, login.html. Great. And all we're going to do for this is we'll actually just copy this one over here, paste this in here like this. We'll just drop all of this out. We don't need the CSS or the JavaScript. We'll just put in our form. And our method will be post. Action will be login.html. Actually, just /login. And then we'll come into here, and we're going to put a quick form in here for authenticating the user. And we'll just drop that in like that. There we go. So there's our form. We'll clean that up here real quick. Great. So now we have our form. We can log in, so we'll save that. Let's go ahead and fire up our application, Node index. Great, web server started on port 3010. Come back over to Chrome. We'll go ahead and load this up. You can see it automatically redirected us to the login. I'll type in our user Bob, test, click login. We have an issue here, failed to serialize user into session. So let's take a look at what that issue is. So if we come back to here, here's our problem. We're not using a user ID, we're actually using the user name. And actually, just for consistency's sake, let's change this to username as well. That would make more sense. There we go. Left the S off of sessions. Save that real quick. Now let's go ahead and try this one more time. Node index, enter, Bob, test. Great, we are now logged in. So there we go. And if we come in here and actually stop our web server here, we'll start it again. Of course, we'll no longer be logged in, which is fine. And if we say Bob and we just make up a fake password, we'll just say fake. Click login. You see it redirects us back into the login page. So now we have the ability to do logins with Express using Passport and Passport Local, and then being able to authenticate against a local user database.
So in conclusion, Express is a Node.js web framework. It makes configuring working with the HTTP server built into Node a lot easier. It provides routing and static file delivery out of the box. It does heavily rely upon third-party middleware. So basically, Express is unopinionated, allowing you to include the middleware modules that you want to provide the various functionalities that you need, such as processing the request body, cookies, sessions, authentication, etc. It's very popular, like one of the most popular packages on NPM. It's very easy to use, and it's very flexible.
Welcome to this course on building desktop apps with Electron. My name is Eric Green, and this course is brought to you by Wintellect Now. In this class, we're going to take a look at getting started with Electron. We'll talk about how to configure a development environment. We'll take a look at using React with Electron and TypeScript. Also, we'll talk about using CSS modules with Electron so that we can isolate our CSS for our particular components. We'll take a look at configuring the menu bar. And then finally, we'll discuss debugging Electron applications. So to get started with Electron, this course is going to assume that you have some basic knowledge of Node.js, as well as React and the JavaScript programming language. In order to run the examples on your machine, you will need to make sure that you have Node.js installed. You can actually download Node from nodejs.org and make sure you install version 6 or later. Also, if you don't understand the basics of these technologies, I would highly encourage you to check out the Wintellect Now courses on Introduction to Node.js, Node.js modules and Node.js packages, as well as Introduction to React courses. Electron programming is a mix of standard Node.js JavaScript programming with browser-based HTML, CSS, and JavaScript programming. In addition, you can use many popular UI frameworks and libraries such as React, Angular 1 and 2, as well as many others, to actually code the actual UI portion of the application. If you'd like to learn more about Electron from the Electron website, you can visit it at electron.atom.io. Getting started with Electron is easy. There's a full sample project available on GitHub. Simply clone the repository, change into the folder, and then install the npm packages, and then fire off npm start, and you will have an Electron-based desktop application fire up on your system. And the cool thing about it is it's totally cross-platform. It'll work on Windows, Mac, and Linux. So let's take a look at creating a Hello World Electron application. So let's go ahead and get started with building an Electron application. We're going to use the actual Hello World sample from the website. So we'll go to the Electron website here. We're going to say electron.atom.io. There we go. And if we scroll down here a little bit, we're going to see we have the same quick start instructions that we saw on the slide deck. So we'll simply grab the git clone command here, and we'll copy that. We'll open up a terminal prompt. Let's change to our source code folder, and we'll paste that, and we're going to clone it. There we go. We're going to change now into the actual Electron quick start folder. Here we go. And the last thing we're going to do is actually install the package dependencies and then actually fire up the application with npm start. So we'll say npm install at npm start. Let's hit enter. This will actually go out and download all of the package dependencies that are needed for the program, as well as fire up the sample Hello World application. Great, there we go. Now we have our Hello World application. You can see it says Hello World here. This is actually the UI, and then this is the developer tools, which are automatically opened for us as part of the Hello World application. You can actually see like the elements and stuff like that. You can access the console, network, traffic, that kind of thing. We can also close these if we don't want to make use of them, and then you can see we have our Hello World app. If we come over to View, you can toggle those developer tools to come back at any point. And of course, later on in building this application, we'll be editing the menu bar, so on and so forth, and we can change how this whole thing kind of looks and feels and actually works. Let's go ahead and close this. So let's open up Visual Studio Code and take a quick tour of what the source code looks like. Okay, we're going to come in here and open up our folder, and we'll pick our Electron Quick Start application. There we go. And looks like a standard Node app. We're going to have a package.json file here. In this file, you're actually going to see this Electron pre-built. This is the actual Electron dependency that's downloaded for actually launching our Electron application. It's currently set at 1.2.0. We're actually going to increase that to 1.2.1. And the reason we're going to do this is that later on in the course we're going to do some debugging. And in order to debug Electron, there's debugging both the actual main process, but there's also the debugging of the renderer windows. The main process is debugged like a standard Node application using Node Inspector, and the renderer windows are debugged like a web application using the Chrome developer tools. Well, the problem is, in order to do both, we need a version that we can compile on Windows, because we're going to have to recompile Electron to enable debugging mode. but we also need a version that will support things like the React developer tools, which are a Chrome extension, and be able to run those as well. The 1.3 series, for whatever reason, is not compiling for me. So we're going to go with 1.2, but 1.2.0 is not late enough to use the React extensions. But 1.2.1 is compilable as well as works with the React extensions, so we're going to use that. Now the actual code we're going to be writing should work fine equally with 1.2.1 as well as the 1.3 series. We're not using any functionality that doesn't work with either. So now that we've changed our package JSON value there, let's go ahead and open up a terminal window. And we're going to come in here and say remove dir -s node modules. And that'll actually delete our node modules folder. And then we'll just simply reinstall all of our packages again. So while those are installing, let's actually take a quick look here at some of the other files that we have. The main.js file is the main file that we actually use to launch the application. Make that a little bigger. And in this file, you're going to see where it actually requires Electron. It gives us access to the actual application itself. We have access to the browser window, so we can create new browser windows on demand. We're going to have a variable here for our main window. This basically allows us to maintain a reference to the main window so it never gets collected by the JavaScript garbage collector. We'll skip over create window for the time being and come down here to our app event handlers. We're going to have a ready event handler for our app so that when the application is ready, it will actually run this create window function here. When we actually close all of the windows and we're not on a Mac, then we're going to tell the application to quit. But because on a Mac it's common to keep the application running even if all the windows are open, we're not going to tell it to quit if we're on a Mac. This is one of the important things about working with Electron. You have to start thinking about the conventions of various operating systems and how they behave, and then make sure that our application behaves the way the user would expect it to. And then down here we can add additional code. Later on we'll throw our menu down there, and you can put additional code which will be used to configure the main process. Now up here, the create window here will actually create that main window that you saw with the hello world. So we're just specifying some dimensions. There's an actual index.html file that had the hello world content in it that got loaded up. This told it to actually open up the dev tools when it loads. We can actually come in here and comment this out if we don't want the dev tools to automatically load up. There we go. And then finally, when the main window closes, we want to make sure we set main window to null so that things get properly garbage collected. The actual index file looks like this. It's just a standard web page. It's got hello world there in the title, hello world in the H1, and then other information. But this is where it starts to look a little bit different. You'll notice that in this web page, we can actually access process information. And basically with this, in your web pages, you basically have access to Node. So you can do like a combination of web page programming as well as Node programming. And then finally, we have our renderer file here, our render.js. This is going to be JavaScript code that we can run on the client side portion of this in the actual web pages. So if we open up this file, we'll see that it's currently empty, but we'll be adding a lot of code to this.
Now that we have our Hello World application up and running, it's time to go ahead and configure our development environment to take advantage of some of the more sophisticated JavaScript development libraries out there. We're actually going to go ahead and set up our project to utilize TypeScript along with its type definitions so that we can have strong typing and good solid ES2015 support in our application. We're also going to use some additional application libraries like Bootstrap for styling and layout, Moment for outputting our dates and times, CSS modules for basically allowing us to isolate CSS to particular components, and then finally we're going to use React as our component system for building the components in our application. We'll also talk about our package JSON configuration and wiring up some script tasks and stuff that we can use for starting up our application and performing other project administrative tasks. And then finally we'll talk about a good TypeScript React code editor. We're going to need to install some npm development dependencies. The first one is the Electron prebuilt. Now this one is actually included in the starter project, and it contains the compiled Electron framework. Now the starter project as of right now comes with 1.2.0, but we're going to be upgrading this to 1.2.1 to fully support debugging
towards the end of the class. Also, we're going to need TypeScript. This is going to provide us strong typing and allow us to use ES2015 modules. While most of ES2015 is actually implemented in Chrome's V8 engine, in order to use the modules, we still have to use a transpiler, so we're going to pull in TypeScript for this. Next, we have the typings. These are actually the strong typing libraries that we're going to be using to support strong typing for the various JavaScript libraries that we're going to be utilizing. Finally, we have the Electron DevTools installer. This is going to allow us to add Chrome extensions to our debugging process when debugging our Electron application, such as using the React extension for debugging React components. This is incredibly useful, and we'll take a look at this towards the end of the course. Now, to work with TypeScript, there comes with a command line tool called TSC. This command line tool will actually compile all of our TypeScript files into JavaScript files. We can compile it one time, or we can also tell it to watch for changes to the files and then compile them again. To do this, we're going to turn that on with the W flag, which turns on watch mode. In order to properly work with TypeScript, we're going to need a tsconfig file. In that tsconfig file, we're actually going to configure it to recognize JSX, which is what we'll be using for React, use the common JS module format, which is what the result of our ES2015 module transpiling is going to be, and then finally our ES version target, which is going to be ES5. Non-JSX TypeScript files should be named with a plain.ts extension. JSX files should be named with a .tsx extension. That .tsx tells TypeScript to actually look for JSX content. Now, the editor we're going to be using is Visual Studio Code, and it actually provides great syntax support for both TS as well as TSX files. For our type dependencies, we're going to be loading in two types of definitions: global definitions and module definitions. The global definitions will be loaded into the global namespace, whereas the module definitions are not. So the global definitions that we're going to be looking at are Electron, Moment, as well as Moment Node. In order for Moment to work for us, we actually have to have the Moment node typings as well, and then of course the node typings. For our module definitions, we're going to be pulling in the React and React DOM so that we can get strong typing when working with our React components. For our application dependencies, we're going to be making use of Bootstrap, React, React DOM, Moment, as well as our CSS modules require hook. The CSS modules require hook is going to enable us to basically enhance the require function so that we can use CSS modules. Last, we need to configure our package.json file. We are going to set it up to run various commands. For example, npm start will actually run our Electron program, and this is actually pre-configured for us with the actual starter program. Next, we're going to use npm run tsc. This will actually perform a one-time compile of our TypeScript files. We'll set up another command called npm run tsc:w. This will compile the TypeScript files as well as tell it to watch for future file changes. Now, when the compilation occurs, the TS and TSX files are transpiled into JS and .map.js files. What's really nice about these map files is that later on towards the end when we're doing our debugging, we can actually set our breakpoints in the TS and TSX files because we have these special source code map files. After installing all of these packages, a post-install task is going to be executed installing the various TypeScript typings. The typings actually get installed through a separate installation system. So let's take a look at how to configure the development environment.
So let's go ahead and get started with some additional configuring of our project development environment. We're going to be adding TypeScript so that we can get some strong typing capabilities, as well as ES2015 module syntax. Because we're using V8, the V8 engine through Node as well as Chrome, we already have access to almost all the standard typical ES2015 features. But modules are still not yet implemented in V8, plus the TypeScript is really nice for the strong typing and the great code completion that you get with it. Also, when using that combined with Visual Studio Code, the development experience is really outstanding. Additionally, we're going to be using React for our UI components. So we're going to include some stuff for working with React. We'll be using Bootstrap to be doing our actual CSS layout and some styling. So let's go ahead and get started with installing some of these packages and then doing some additional configurations to bring this thing to life. So let's go ahead and get started with installing some of the packages that we're going to be needing. We're going to say npm install -s, and we're going to be installing Bootstrap, and we're actually going to be installing the version 4 alpha, so at 4.0-alpha.3, and we'll install Moment, and we're going to install React, React-DOM, and then we will install our CSS modules require -hook. So those are our application dependencies. Let's go ahead and add our development dependencies. npm install -d, and we're going to be installing TypeScript, typings, and then finally the Electron DevTools installer. We won't be using the DevTools installer until the end of the course, but we'll go ahead and install it now. Excellent. So now that we have those installed, we need to go ahead and set up our TypeScript configuration as well as our typings configuration. So to set up our TypeScript configuration, we'll come over here and create a tsconfig JSON file. So tsconfig.json. And we'll just paste our configuration into here. Get rid of all these extra spaces. There we go. And you'll notice here we're actually going to be enabling JSX for React, and our target module output here is going to be for CommonJS, which will work nicely for our Electron application running in a Node environment. Next, we're going to need our typings JSON file. So I'll come in here and actually create a new file called typings.json. Go ahead and paste this into here. There we go. One nice thing about Visual Studio Code is you can actually use this little format code and it'll actually clean it up really nicely for you. So we have our global dependencies. This is Electron, Moment, Moment Node, and Node. And then we have our non-global dependencies, React and React DOM. And basically this will give us the strong typing capabilities when working with these various libraries. So we'll go ahead and save that now. Now what we want to do is actually come into here and we're going to change our main.js file. We're going to rename it from a JavaScript file to a TS file. And then for our renderer, we're going to rename it from a JS file to a TS file. And we're almost done. We have to do a couple of little commands here on our package JSON. So you can see here we already have a start command for firing up the Electron application. This Electron is actually located in the .bin folder underneath of Node modules. We're going to add 3 additional commands here. The first one is going to be post install. This will actually do the typings install. So these typings that we have listed in typings JSON will actually get installed as part of the actual installation of our packages in the future. We have the tsc command. This is actually going to do the TypeScript compilation. This will do a one-time compilation. And then we also have tscw, and this is actually going to do a compilation and then watch for file changes. So when we're doing regular development on our projects, we'll actually use this tscw to actually watch our file changes and actually recompile our TypeScript code for us as needed. So we'll go ahead and save that now. We're going to come into here, and what we'll do is we're going to go ahead and install those typings. Now I can actually reinstall everything if I want to, or I can do the following. I'm actually going to say node modules bin .bin /typings install. And this will actually go in here and actually install the typings that are missing. So it'll actually go in there and install them. You'll now see that I have a typings folder over here. And now what I'm going to do is actually I'm going to run my actual TypeScript compiler. So I'm going to say npm run tsc. So now you'll notice I now have a main.js file and a main.js map, as well as a renderer.js and renderer.js map. Later on when we do our debugging, we're actually going to be able to use map files so that we can actually set our breakpoints and stuff like that inside of our actual TypeScript files. So this is actually incredibly useful. Now be careful when you're editing. You don't actually want to edit the JS or map files. You only want to edit the TS files. And later on we'll introduce something called TSX files for working with React. And for those, also make sure you only edit the TSX, not the JSX files.
So let's go ahead and test our project and see if the whole thing still works. And we can say, let's see, we'll say npm start. And once again, we have our application. And notice this time, the developer window didn't automatically open up for us. So far, so good. We've actually been able to upgrade our development environment to leverage TypeScript. And we've also installed a bunch of different packages for doing various things in our UI. You have your choice of any number of UI frameworks and libraries, or no framework or library if you prefer, to actually build the UI stuff in your application. For our little demonstration app, we're actually going to be using React and the React DOM to basically build our components. Now, these are going to work the same way in Electron as they do in traditional web applications. And we're actually going to be using TypeScript so that we can actually have strongly typed component properties and state. Finally, the ES2015 Modules syntax is going to allow us to easily organize our component files. And the nice thing about TypeScript is it fully supports JSX. So let's take a look at how to use React with Electron and TypeScript. Okay, so let's go ahead and wire up our first React component. We're actually just going to do a Hello World React component and take a look and see how that works using TypeScript along with Electron. So I'm going to go ahead and close our window here. And the first thing we're going to do is actually fire up the TypeScript compiler, but we're going to fire it up in watch mode. So we're going to say npm run tsc:\w. So now we're firing up TypeScript in watch mode. And I'm going to come over to our renderer, and the first thing we're going to do here is actually change this to a TSX file. We're actually going to be using this with React. So in order to use JSX, our renderer has to be named TSX. So there we go, there's our new TSX file. So now we're going to come into here and actually begin the process of building this out. First thing we're going to need to do is actually import React. So we're going to say import React equal to require React, and then we'll say import React DOM equal to require React DOM, and this is going to load the React modules from the Node modules folder. So we're going to go ahead and create our class Hello World, and this is going to be extending the React.component. Now, when you work with React and TypeScript, you basically have to specify the types for the props and state that are going to be used with the component. React.component is actually a generic type. So for this, what we're going to do is our props we're going to define here. And we're not actually going to really have any props here, but I'll show you what this looks like. We'll say props, and then we can come into here and say props like that. Or if we wanted to, for example, we'll do this with the state, we could simply have just passed in an object like that. There we go. So now we have our props with actually no properties, or if we wanted to have a more simplified syntax, we could just pass in this object literal like that, like we're doing for the state. Now later on we'll actually have props with properties and states with properties that we can take a look at in terms of working with TypeScript. So we're going to go ahead and implement our render function. As you can see, everything is pretty much the same normal stuff that you would do when actually doing React programming. We're going to say return, and we'll just have an H1 here saying Hello World React. Close off our H1, and then of course down here actually use our React DOM and actually render this out. So we'll come into here and say Hello World, and then we'll do our document.query selector, and we're actually going to search for the main element. So let's save that. You can see our TSX file was automatically compiled. One last little change on index here. We're going to actually take all of this content out, and we'll just simply replace it with main. And that will be where we're actually going to launch our Hello World component from. So now that we've done all that, we actually need to run our Electron application. So we're going to open up another terminal window here, and we'll say npm start. And this is actually going to fire up our application, and you can now see that we have Hello World React. So now that we have Hello World working, let's go ahead and actually begin to build our application. So what kind of application are we actually going to build? We're going to build a very simple start and stop timer. We're going to have two buttons, one that says start and then another button that says stop, and then we're going to have like a little stopwatch timer kind of running, and then basically you can start it and then it starts at 0 and then begins incrementing, and then after a while you can stop it and it'll stop at whatever it stops at. So we're going to have to be building a couple of different components for this to work. We're going to actually have a component for the actual time display. We'll have another component for the actual start and stop buttons. And then we'll have an actual application component that wraps both of those and ties the entire thing together. Now right now we're going to set it up to just start and stop based upon the buttons. But in future demonstrations we're actually going to wire that up to the menu as well as up to some accelerator keys, so we can start and stop it not only from the start and stop buttons but also from the menu and the accelerator keys. So let's go ahead and get started. First thing we're going to do is actually close all of our open windows. We're going to come into here and we're going to create a new folder. So make sure you're actually highlighting something in the main level root folder. If you have like node modules or typings highlighted and you click new folder, it will actually create the new folder in there, and that's not where we want it. So we're going to come into here and we're going to create a folder called components. There we go. Now inside of our components folder we're going to create a couple of files here. So we're going to have one called timer clock.tsx. We'll have another one called timer controls.tsx. And then the final one's going to be called timer-app.tsx. And so it'll be this timer app is the one that we're actually going to reference inside the renderer TSX file. But the timer clock and the timer controls will both be contained inside of timer-app.tsx. Now you'll notice the automated compiling here has already tried to compile the TSX files and basically produced a JavaScript and a JavaScript map file for us to make use of. So let's go ahead and build out our timer clock first. First thing we're going to have to do is actually import React. So we're going to say import React equal to require React. Then next we're going to be needing a UTC object here from the moment library. If you've never used moment before, moment is really nice for working with dates in JavaScript. And so we're going to use its formatting capabilities to actually format our actual stopwatch timer. Next we're going to need to set up some properties for our React component here. So I'm going to say interface timer clock props, and we're going to have a property on there called current, and it's going to be of type number. Now we're ready to actually go ahead and build our component. So we're going to say export class. We're going to be exporting this component out because we'll actually be requiring it into the timer app. And we're going to say timer clock. There we go. Extends react.component. We'll specify our timer clock props and then our open and close curly since we have no state to work with here. Next we're going to go ahead and implement our render function. So there's our render. We're going to return back a div with a class name of row. We'll actually be loading Bootstrap up into our application here so we can make use of the nice Bootstrap layout capabilities. So there's our closing div tag. Next we're going to add another div here. We'll say class name equal to call md12 text -xs.center. There we go. And then we're going to go ahead and actually output our time here. UTC, and then we'll have this.props.current. Take a look at that IntelliSense there that's available to us in Visual Studio Code.
and then we're simply going to say dot format, and then for our format we're going to specify hours, minutes, seconds, and then milliseconds. Excellent. So there is our first component, and it looks like we're actually missing a div tag here, so let's go ahead and add another div. That's one nice thing about Visual Studio Code. It instantly showed us that we were missing that closing div tag. Saved us a whole lot of debugging time in the future. So now we're going to come into our timer controls here, and let's actually go ahead and first collapse up this render function first, and we'll go ahead now and build our timer controls.tsx. So timer controls are going to be similar here to our timer clock. We'll import React, and we're going to say require React. Then we're going to go ahead and set up our interface for our timer controls props. So timer controls props, there we go. And we're going to have a start function, a stop function, and then a Boolean here for whether or not the timer is actually on. Perfect. Okay, so now what we're going to do is actually build our components. So we'll say export class timer controls extends. Once again, react.component. We'll specify our timer controls props, and then finally pass in that empty object. Here we go. Let's go ahead and build out those buttons now with our render function, and we're going to say return div of our closing div here. Then we're going to have class name equal to row. Put our semicolon down there. Next, let's go ahead and do our div class name, call XS12, call SM6. So what this is going to do is that for extra small screens, we're going to actually have our button take up the full width of the 12 columns. For small screens and larger, it's only going to take up 6 of the available 12 columns. So basically, on small screens and larger, the two buttons will be right next to each other. On extra small screens, the buttons will be on top of each other. And we'll say text XS center. This will just center the buttons for us. And we'll close off our div there. Go ahead and wire up our button here. So we're going to say button disabled, and this dot props dot timer on. That way if the timer is activated, the button will be disabled. Notice we're disabling it based upon the property value of the timer. So it doesn't matter how the timer is actually activated. If the timer is on, the button itself will be disabled. This will be important later on when we start using the menu and accelerators to actually turn the timer on. We're not specifically hooking into the button click event. Instead, we're hooking into the status of the timer itself. We'll go ahead and specify our class name here. Once again, these are from Bootstrap. So button-primary. There we go. We're going to wire up the onClick function that we were going to pass in here through our properties. So this dot props dot start. And then finally we'll specify some start text for our button itself and close off the button tag. Perfect. Okay, so now we have our button, and let's actually collapse this over here so we can see that text a little easier. We'll go ahead and copy this, paste that down there like that, and then we'll go ahead and finish wiring up the rest of this. So we're going to take that out. We'll just change this to danger, not because it's a real danger, but it'll make it a nice red color. And then we'll give it a stop here, and then we'll say stop, and we'll go ahead and save that. There we go. So far so good. We have our TSX for timer controls and TSX for timer clock. Now you'll notice we're still over here on the command prompt for starting the application. But if we wanted to check to see if any of the compilation was failing, we could actually come to the first window here once again, and it would have errors listed here if there was anything wrong. As you can see up here, we did actually have some errors when we were working on our code. If you remember earlier,
we didn't have a corresponding closed div tag. But now you can see there's actually no errors here in any of our code. So far so good. So we've got our timer controls and we have our timer clock. The last part is the actual timer app, which is going to tie the two pieces together into a single component. Okay, so let's go ahead and import React as we've done before. So require React. We actually need to bring in our timer clock. And we'll just bring that in here from our timer clock dot tsx. And in fact, actually, we can actually leave the tsx part off there because we won't actually be loading up the actual tsx file itself. We'll actually be loading up the resulting JavaScript file. So it's important to leave that off, and then we'll have our timer controls dot slash timer controls. Perfect. Okay, so now that we're pulling in our two components and React itself, we can go ahead and build out the timer app component. It was actually configure the state for this. So we'll actually be maintaining state in our timer app. So we'll have interface timer app state. And for this, we're going to have a start time, which will be of type number, start time, and stop time, which will also be a number. And then we'll have our timer interval, which will be a number as well. So now we'll go ahead and build our component. We're going to say export class timer app extends React dot component. Now this time we don't have any props, so we're going to pass in the object in for props, but for state we'll basically say timer app state. So now we can have a strongly typed state for our component. Now this component has a lot more going on in it, so we're going to go ahead and build this out. To save a little time, I'm actually going to copy and paste some code. The purpose of this course is to talk about Electron, not necessarily talk about how to work with React. So we'll paste that in there. And all this constructor is going to do is actually initialize our state as well as bind up our start and stop timer functions. There we go. So we have our start timer and stop timer there. And then finally we'll paste our render function into here. So there you go. You can see where we're actually including our timer clock and timer controls. We're going to pass in the current time to the timer clock for displaying the current time. And then we're passing in our timer on as well as the start timer and stop timer functions that can be activated from the timer controls. So now we have the basic functionality here for our little timer application. All we need to do now is actually update the renderer so that we'll actually use timer app instead of hello world. So we'll come over to here and we're going to open up the renderer TSX. And for this, all we're going to do is actually come in here and delete all of that. And then we'll say import timer app equal to actually from. And then we'll come into here and we're going to say dot components slash timer dash app. And then we'll take timer app right here, copy it, and paste it. Now, before we can actually fire this thing off, we actually need to make one little adjustment right there. Okay, great. So let's go ahead and actually rerun our program and see if our timer application is going to work here. So we'll go ahead and switch back over to our second command prompt window. We're going to say npm start, and assuming all the TypeScript compilation updated everything, we should have a timer application. So we have start. If I click start, the timer starts running. If I click stop, it stops. If I click start, it starts over again. And then if I click stop, it stops. Now, of course, it's not a very pretty application. So in the next demonstration, we're going to take a look at using CSS modules to isolate our styling to its particular components. So with the rise of component-driven development, not just the HTML and the JavaScript need to be componentized, but the CSS as well. Now, when using bundlers like a Webpack, you can basically have the CSS be required into the JavaScript part of the application. And this will allow you to basically load the CSS for each individual component. Well, you can certainly use Webpack for Electron, and actually a lot of the boilerplate project starters do. For our particular application, we're not going to use Webpack because we don't really need all the capabilities of it. We just simply want to be able to modularize our CSS. So to do that, we can actually use the CSS modules require hook package. And what that's going to do is going to extend the capabilities of require to allow us to import our CSS files directly into the component. And basically this is going to set them up to be namespaced. And so when you apply them to the component, they'll actually have a class name that is definitely unique within the overall structure of the application. And that way the CSS doesn't bleed in from one component to another. Now this hook is going to do two things for us. It's going to provide us unique class names which are scoped to the component. It will also load the styles associated with the unique scoped class names into the style tag in the header of the main document. Now it's important to make our file system or file structure easy to understand and follow. So the component CSS file should actually be stored in the same folder as the corresponding component.js file. This will make it easy to find the CSS files associated with the component and vice versa. While we're not using Sass or less, both of those could be easily configured to transpile the CSS for us as well. So let's take a look at a quick demonstration of how to use CSS modules with Electron. Now that we have React wired up for our Electron application, we actually need to go ahead and turn on those bootstrap styles that we referenced in the earlier video. We also need to add some component styling for the two components that we created, the timer clock as well as timer controls. So the first thing we're going to do is make sure we have our TypeScript compilation process running. So we'll say npm run, and then we'll do tsc w, and that'll run the TypeScript compiler and watch our files, make sure things are being properly compiled. There we go. So now it's watching for file changes. And the first thing we're going to do is we're actually going to add a reference to Bootstrap. Now when you work with CSS in an Electron application, or really a large-scale web app using components, you can basically have global styles which get loaded up kind of like in a link reference to just a general style sheet, and those styles will be applied to the whole page. But you can also load up styles that are specific to a component. So what we're going to do is we're going to use Bootstrap as a global style so that we can basically reference the Bootstrap classes from anywhere, and then we'll set up some component specific styling for our actual components. So I'm going to come over here to our index file, and we're going to open that up. And right here in our head section, we're going to add a link tag to load up Bootstrap. So we'll just paste this in right here. And you can see we have Bootstrap installed as a Node module. If you remember from our development configuration, we set up Bootstrap and downloaded it actually as an NPM package. So we're referencing it right here. And now Bootstrap will apply to the entire application, so we can basically reference the Bootstrap classes from anywhere. So if we want to try that out, let's go ahead and open up a second command window, and we'll say npm start. And this will fire up our Electron application once again. And it looks like I didn't save my file, so let me actually stop the Electron application. Let's go ahead and make sure our file is saved, and then let's go ahead and run it again. And now you'll see we actually have the Bootstrap styling. So naturally it's very important to make sure you save your file. If you don't save your file, then it won't be the changes won't be included when the application runs. But now we have our Bootstrap styling and everything looks okay. But if you notice here, we're going to make this thing really small, and when it gets small you'll see the start and stop button are kind of stacked on top of each other, and there's really no gap here between them. Also, what if I wanted to make my timer number here, the clock text, actually a different color? So what we're going to do is we're going to include some component styles that will actually do that for us, but the component styles won't be global. Instead, they'll be localized to these particular components. So let's go ahead and do that. So to set this up, we've included a CSS modules require hook package that we've downloaded. What this is going to do is basically override the default implementation of require and allow us to require CSS files into our application. So let's go ahead and do that now. So we're going to come down here to our render TSX file, and we're going to add some code to this to support this. The first thing we're going to do is we're going to say require, And then we're going to say CSS modules require hook. There we go. This is actually going to return back a hook function that we can invoke. Now, if we wanted to, we could actually assign this to a hook variable and then invoke that variable as a function object. But to save a little bit of typing, we're actually just going to invoke it like this. So this is the hook function that we mentioned earlier. On this, we're going to set up a process CSS option and make the S and the S lowercase. And then we're going to assign a function to this, so we'll use a little arrow function here. So we'll say var style equal to document dot create element, and then we'll say style like that. Excellent. Then we're going to assign to the inner HTML of our style tag the actual CSS content being passed in here. Put an equals there. And then finally we're going to say document.head.append, and then we'll add our style. And this will actually be append child. There we go. So now what's going to happen is when we actually set up our component styles, the scoped classes that will be created will actually be used to populate the style element that we're adding here. So now let's go ahead and add our first set of scope styles to our timer clock component. So we'll come into our timer clock TSX, and we're actually going to need to create a new style sheet. So we'll come into here and say new file, timer clock.css. There we go. So we're going to call this class clock display, and we're going to go ahead and set the text color to blue. There we go. And then we're going to require this CSS file inside of our timer clock component here. So we'll say const styles equal to require, and then we'll specify the relative path. So this will be timer clock.css. So great. Now the next thing we need to do is actually make use of this inside of our React component down here. Right now we're just simply assigning this piece of text to this class name, but we're actually going to change this into an actual JavaScript expression. So the first thing we're going to do is wrap our string in curly braces. So now that we've wrapped it in curly braces, we can actually treat this as an expression. So now we're going to come into here and we're going to put in backticks. Backticks are the new template string capabilities of ES2015. It allows us to have like multi-line strings and stuff like that, but more importantly, we can actually do variable interpolation. So we'll come in here and I'm going to actually pass in a variable, and then up here I'm going to reference my styles. I'm going to paste that in there like this, and then I'm going to say clock dash display. There we go. And so now this expression will be evaluated and it will grab the scoped class name. So the scoped class name isn't just going to be like clock display. It'll have additional stuff in front of it to basically scope it so that it's unique to this particular component. And then the CSS we have here will get loaded up with the properly scoped class name into that style tag that we set up in renderer.tsx. So we'll go ahead and make sure all of our files are saved. We're going to come in here and run our Electron application again. And now when it loads, you can see we have blue. So if we come over to View and toggle the developer tools here, I'm going to click on this and highlight the number, and you see there's that scoped class name. So it's underscore components, timer clock, and then clock display. And then if we scroll up to the head, you'll see where our code added a style block here. In fact, let's make that a little bigger. Make our application size here. So now you can see here we have our style tag with our components, timer clock, clock display, color blue. So that's basically the way this whole scoping mechanism works. Now eventually when web browsers actually support true web components, creating scoped CSS will actually be part of the way HTML, CSS, and the DOM actually work. But right now we can use polyfills like this to basically simulate the same concept of scope CSS and actually make use of it in browsers today. So the last thing we're going to do is go ahead and set up some scoped CSS for our actual start and stop buttons to set up a little bit of space here between them when things are collapsed. So now let's head over to our timer controls. And the first thing we're going to do is go ahead and create a CSS file, timer controls.css. There we go. And then here we're going to create a class called control container. And we're going to have margin top will be 5 pixels. Margin bottom will be 5 pixels. Great, so there's our CSS. And then we're going to come in here and actually require that in our timer controls. So we'll say const styles equal to require. And then we'll do /timer controls.css. We'll go ahead and save that. And now down here, we're going to have to make a couple of changes. So just like we did before, we're going to have to come in here and convert this over to be curly braces. And then we'll have to switch this to backticks to make it a string template or a template string. And then we'll do our interpolation with our $ curly brace. And we'll say styles. And then we'll say control-container. There we go. And we can simply just copy this piece of text right here. And we'll paste it down here and just copy over this one since they'll both be the same. There we go. So now we basically have our scoped CSS for our timer controls. And we have it set up here with our class name using our template string and our string interpolation. So we can go ahead and save that. We'll come back down here and run Electron again. And so now we have start and stop, and we're going to come in here and actually collapse this. And now you can see we have our space between start and stop. There we go. And so now using this scope CSS, we can basically create CSS for our individual components. And we don't have to worry about the CSS for one component conflicting with the CSS for another component. Just like any other desktop application, configuring the menu bar in an Electron application is extremely important. Now, the starter Electron application actually comes complete with a starter menu featuring many of the common application commands. However, in our case, we're going to replace this standard menu with a custom menu that's been specifically tailored for the timer application. Now, the timer menu is not going to be anywhere near as fully complete as the starter menu. It'll show how we can use commands to perform whatever operations we need to perform in the application. Now, when building out full menus, you can create as many commands and submenus as you would like to perform whatever the operations are that are needed for the application. Also, we can register accelerators to provide hotkey support for our application as well. So to work with the menuing API, there's two primary classes, menu and menu item. We're going to use these for creating menus as well as the items that go in those menus. Now, 5 kinds of menu items are supported out of the box. The normal menu item, which is kind of think of like some text that you click on, a separator for logically dividing a menu into parts, a submenu, which then can contain additional menu items, the checkbox, as well as a radio button. As mentioned before, accelerators can be configured for all of these menu items. And finally, we have the menu object, and it's got 2 really useful static functions properties. You can actually build a menu from a template, which is what we're going to do, so you'll define the whole menu using an object literal. And then you can also set the application menu. This is the actual function that replaces the default menu with the new application menu that we desire to use. The one tricky part to working with the menu with Electron is how to actually communicate from the menu to the actual web page where our components are. The actual menu itself runs on the main Electron process for our application, while the individual windows actually run on their own renderer processes. In order to actually allow them to communicate, we're going to have to do inter-process communication, and that's where the IPC renderer object comes into play. It's going to allow us to asynchronously communicate from that main process where the menu is to the renderer renderer process where the web page is running. Now, the way this works is that the web page registers an event handler to listen for IPC events. Then the main process sends events to the web page. In the case of our demo application, we're going to wire up a start timer and stop timer events, and they're going to be registered with the component did mount and component will unmount event handlers of the timer app. So basically, when the component mounts, we're going to register the event handlers, and then when the component unmounts, we're going to unregister those event handlers. So when you click on those menu items, it's basically going to fire off those events, and then our timer app will be able to respond to it. So let's talk about Electron processes. Basically, the main process is the Electron application itself. Each window is a separate renderer process and is accessible through inter-process communication from the main process. Also, these renderer processes can communicate back to the main process via IPC as well. Now, because the main menu runs on the main process, it has to use this inter-process communication in order to communicate with the renderer process. Now, the reason we have all these processes is because JavaScript itself is single-threaded. Therefore, we need a process to basically run each instance of JavaScript that comprises our Electron application. If we only had one instance of JavaScript running, we could run into all sorts of problems in our application. By each window, via its renderer process and the main process having its own JavaScript thread, the application is able to run more smoothly. So let's take a look at how to configure the menu bar. So let's go ahead and add a menu now, a customized menu to our Electron application. Now, our menu is not going to be as big and sophisticated as the actual starter one. What we do want to do is actually go ahead and set up a start and stop timer menu option, and then be able to actually trigger the start and stop action on our timer app component. So to do this, the first thing we're going to do is actually open up our main TS file. This is where we're actually going to be pulling in the code to actually work with the menu. So we're going to come up here to the top, and so we'll make a couple of changes here to our code. So first of all, we're going to switch this const electron. Actually, we're going to switch it over to the ES2015 module format. So we'll actually come in here and change this to an import. And then instead of actually importing all of Electron, what we're going to do is we are going to say import from, and then we're going to come into here and we're going to pull out certain things. So we're going to pull out app, we're going to pull out the browser window, and then we're going to go ahead and pull out the menu. So now we can work selectively with these different objects off of the actual Electron object itself. Down here for our app, we're just going to say app. But now, so we don't have a variable name collision, we're actually going to change this to be my app like this. And then we can also benefit from some of the strong typing features of TypeScript. We're going to go ahead and define this as a type of electron.app. And then we can put our semicolon in there like that. So now we actually have a myApp variable. Because we're loading browser window here using this destructuring type mechanism with import, we can actually completely get rid of this constant. We don't need that anymore. We'll keep the main window variable because that's basically our handle back to the main window. And then we'll scroll down to here and we'll go ahead and set up our menu. So we're going to be using the template approach to creating our menu. So we're going to say const template, and we can actually give this a type if we want. We'll say type any, and we're actually going to set this up as an array, and inside the array we'll have an object. And first we're going to go ahead and set up a label here called timer. There we go. Then we're going to go ahead and configure ourselves a submenu. This submenu will actually point to an array, and then our first submenu item is going to have a label, and it's going to be called start. So this will actually start our timer. Then we're going to go ahead and set up an accelerator, and we're going to say command or control plus T. So we'll just choose that as our hotkey. Then we're going to actually wire up the handler for actually running some code when you actually click the menu item. So we'll do click, and then we're going to have item, and then we'll have the actual focused window. This is the window that currently has the focus in the application. This is the actual window that we intend to start and stop the timer on. So we'll say focused window dot web contents, and then we're going to send it a message. This is that inter-process communication, so we'll send start timer. So we're going to have to basically wire up our focused window to know how to respond to the start timer event. Very good. Now we can actually come in here and wire up our stop submenu item. So we'll just simply copy start here, and we'll paste that, and then we're going to change this to stop. And then our accelerator for this, we'll just go with Y since Y is right next to T. And then we're going to send the stop timer event. So we'll go ahead and save that. So now we've set up our little menu for our timer application. There's one last thing we actually have to do to kind of complete this. We have to take into account that our application could be running on other operating systems other than Windows. We have to take into account working with other operating systems, and the Mac menuing system is a little bit different. It's got more system menu types of things built into the actual menu bar for applications. So let's go ahead and copy over some code that will take care of that for us. So this code right here I basically got off the Electron website, and it just has the basic standard services menu for the for individual applications. So we're simply just going to push this on here like this, and then down here to complete this, we'll go ahead and build our menu from the templates. We'll say const menu.build from template, and we'll pass in our template, and then we'll say menu.set application menu, and then we'll pass in our menu. There we go. So now we have our menu set up. But we have one more thing we have to do. We actually have to wire up our timer app component to actually respond to the actual inter-process communication that we're going to be sending across start timer and stop timer. So let's go ahead and scroll up here to our timer app. And we're going to come down here, and we're actually going to set up two component lifecycle events. The first one will be component did mount, and the second one will be component will unmount. We can basically use component did mount to register an event handler for the inter-process communication, and then component will unmount we can use to unregister that event handler. Now in order for that to work, we're actually going to have to scroll up to the top here, and we're going to have to import the IPC renderer object from Electron. There we go. And we'll simply copy that right there. And we're simply going to come into here and say IPC render on, and then we'll say start -timer. Then we're simply going to have it run the start timer function that we've already configured in the constructor with bind. So we'll copy that, paste there, and we'll stop our timer with that as well. So stop. And then we're simply going to copy this down to here. I'll make sure we get rid of our T there, or get rid of that T, and then get rid of the T here. And then for this, we're going to actually unregister the event listener using the remove listener function. There we go. And then once again, we'll say remove listener. So we'll go ahead and save that. We'll come back down here. We should be able to run our Electron application now. And so now we have start and stop buttons work there. We have our timer menu. I can do start. I can say stop. I can also use my keyboard shortcuts, my accelerators. Start and stop. So now we have full keyboard support. And notice that when you actually start it from up here, the start button here gets disabled. Because we're using components and we're actually basing all of our UI stuff off of these properties passed down through the components, even though we didn't click the start button, because the timer was actually turned on through the properties, the disabled feature of the start button was activated no matter how the timer itself was actually started. So working with the menu is actually pretty simple. Really the hardest part is just understanding the inter-process communication between the actual main process where the menu is, and then actually communicating with the window that you actually want to do the operation on. Once you master that, building menus with Electron is pretty easy. Now, debugging Electron applications can be a little bit tricky. We really have two different parts that can be debugged. We have the main process as well as the renderer processes. Now, the main process is just a standard Node.js application, and we can debug that using something called Node Inspector. The renderer processes, though, are the actual web pages. And so to debug those, we're going to use the usual Chrome developer tools available on each of those pages. Now, in order to debug the main process, we're going to have to recompile Electron to support debugging. In order to do this, we're going to have to install the Node.js package. However, the Node.js package requires certain build tools to be present on your machine. We're running all of these demonstrations on Windows, so we have Visual Studio installed. But if you were going to do this on Mac or Linux, you'd have to make sure that you had access to a C++ compiler as well as a make tool. For the case of a Mac, you can install Xcode, and then for Linux, you can install GCC and make. Additionally, Node.js requires Python to be installed, so you'll need version 2.7 series in order for this to work. There are some alternate configurations you can do, and if you visit the Node.js site on GitHub, you can read about those. Now, once the build tools are actually installed, once you have Visual Studio installed and you have Python, then you can go ahead and install Node.js and Node Inspector locally. Now, Electron needs to be rebuilt, which we'll demonstrate, and then the Node Inspector is launched. Once Node Inspector is launched, you can actually open up the Node Inspector window by visiting the http://127.0.0.1:8080/debug, and then you can read the rest of the URL there listed. The actual Node Inspector uses Chrome's debugging tools to actually allow you to debug Node programs. Once you have those tools opened up in the web browser, then you can go ahead and run your Electron application. In this case, because we're going to be running our Electron application from our root folder, we're going to say Electron, then we're going to turn on the debug flag, and that debug-break means to set a breakpoint at the very first line of executable code. We're going to tell it to point at port number 5858, and then that dot just means run the actual program from our local folder where we're actually executing Electron from. Now, most of the common Chrome developer tools are available through Node Inspector. You have to be careful though, don't try to inspect the process object. This is known to cause issues where Electron will basically crash. Finally, all of those source maps that we produce from TypeScript, all of those work. So you can actually view the TypeScript code and set your breakpoints directly in there, and that will map directly back to the JavaScript code which is actually being executed. Now, to debug the renderer process is a little bit different. We don't have to actually recompile Electron to do this at all. All we have to simply do is tell the window that we want to look at to open up its development tools. Now, by default in the sample application, it actually opens up those dev tools automatically when the application runs. However, when you're developing your application, you may not want to have those tools always open up. So it's advisable to actually set up a menu item or some other mechanism by which you can actually launch those dev tools when you need them. Now, all of the usual developer tools that you would find with a traditional web application, those are all available here. I mean, after all, you are running Chrome basically. A lot of developers like to make use of the various Chrome extensions that exist for the various UI frameworks and libraries. React and Angular definitely have their own sets of tools as well as others do. You can actually use these tools when debugging the UI portion of the application. Electron does not support all the Chrome extensions that exist, but you can actually see a list of the ones that they do at their website. So to use these extensions, we actually are going to have to run a little bit of code, but this code is going to have to run after the ready event of the application has been fired. There's basically two ways in which we can load up extensions. We can either use the direct API of Electron, or we can use something called the Electron DevTools Installer package. If you want to use the actual API of Electron, it's available through the browser window.add_devtools extension, a static function property, and to that you're actually going to be passing it the path to the extension on your local system. It's a little bit more work. The Electron DevTools Installer package actually makes it a lot easier. In order to actually use Add DevTools extension, you will have to make sure that the extension itself is installed in Chrome ahead of time. So just open up a regular Chrome browser on your machine, go and find the extension that you want, and then install it. Then you'll actually have to go find the path to the extension, which I'll demonstrate here shortly, and then from that path you can load up the extension. The installer package is much easier to work with. It will actually go and download and load up the extension developer tools for you. As part of our demonstration, make sure that you're using Electron version 1.2.1 or later in order to use the React Dev tools, which are the ones we're going to actually load up. There is a much newer 1.3 series copies of Electron out there. The reason we're using 1.2.1 is that it safely compiles on my Windows installation. And so for all the things that we're demonstrating here, having it compile on my Windows installation is important if we want to be able to do the debugging, not so much of the renderer, but of the main process. So let's take a quick look at debugging Electron applications. So now that we have a basic Electron application up and running, we've taken a look at how to work with components, how to integrate some CSS, as well as how to use the menuing system. Let's go ahead and talk about how to debug an Electron application. Now, it's actually not that difficult, but the thing we have to keep in mind is that we actually have two parts to the application. We have the node part, and so for the node part, we're going to use the traditional node debugging tool called Node Inspector. And then we have the client part, and for the client part, that's actually a web page. So we can use the standard Chrome developer tools, but we're also going to take a look at how we can incorporate the React Chrome extension for actually doing our debugging. So the first thing we're going to have to do to actually make this work is we're going to have to install two packages. So I'm going to say npm i-d node-gip and then node-inspector. So this is going to install these two as development dependencies, and we're going to use them for our debugging of the node part of this. This is also called the main process. Now what Node.js is going to do for us, it's basically going to recompile the Electron application in debug mode. And then Node Inspector will be used as the actual debugging tool so that we can set breakpoints and watches and observe the console, things like that. Great. Now that we have those two things installed, we actually need to go ahead and begin the process of actually building this thing. Now to do this, if you actually go to the Electron website, we'll go ahead and load up our browser here. So we go to electron.atom.io. If you go under the docs here, you're going to see where they have some instructions on how to debug the main process. Now, the instructions in here basically work on a Linux or Mac environment. So what I've done is I've taken these commands and I've actually adapted them to work with Windows. So let's come into here and we're going to create a new file called debug.bat. For this debug.bat, we're going to copy in some code. So we're going to paste that in there, and we'll actually go ahead and collapse this down on the side. And let's turn on the word wrap, and I'll tell you what's going on here. So basically we're going to use node pre-gip, and what it's going to do, it's going to download the Atom shell and basically rebuild it so that we have the necessary debugging symbols. Then here it's going to do the same thing again, but this time hook in the V8 profiler so that it can work with Node Inspector for doing the profiling parts of our debugging process. Then we have this set electron run as node. This is actually going to set it up so that we can actually debug it with Node Inspector. Now you have to be careful here. Once you set this environment variable to true, if you try to run npm start without turning it off again, the actual Electron application will not run. You actually can only set it to this environment variable like this when you're debugging with Node Inspector. But when you don't want to debug with Node Inspector, you have to basically turn this off again. Otherwise, if you just try to run it as normal, it'll crash. And then finally, we're going to fire up Node Inspector itself. So we're going to come down here, we'll save our bat file. Now, in order for all of this to work, by the way, you have to have the prerequisites installed. Since we're on Windows, make sure you've got Visual Studio with the C++ compiler. You can use the Community Edition. You don't have to actually use the paid-for version, but you do need that C++ compiler, and you're also going to need Python, the 2.7 series, not the version 3 series. So we'll come into here, and we're going to actually run our debug bat. And now this will take a little bit of time to run. It's going to be downloading some things, doing some compiling and processing, but when it's all said and done, we should have Node Inspector up and running in terms of the server process. Then we'll have to launch the actual web browser to load up Node Inspector for actually doing the debugging. Okay, great. So now we have Node Inspector running behind the scenes. Now we need to actually open this up with our web browser. To do that, we'll come back over here to our instructions, and then down here you can actually see the URL for loading up Node Inspector in the actual web browser. So we'll just copy that and we'll paste that up in here into our address bar. And so now we should see Node Inspector load up. Now we haven't actually started running our Electron application yet, so there's nothing to debug. We're going to come over here and actually run our Electron application. So here's the command to start it. The important part is this debug-break. This is actually going to set a breakpoint on the first executable line. So we'll go ahead and copy that right there. We'll jump over to here. We're going to open up another window, and we'll say node modules /bin /electron. We'll paste in our flag, and then we'll start it from the current folder. We'll hit enter. Now you'll notice it'll wait here because our debugger has a breakpoint on the first line. We'll come back over here to Node Inspector and reload it. And we'll give it a second here, and then we're actually going to have our breakpoint here, which is excellent. So we'll just come up here and actually collapse all of that code right there. And we'll go ahead and run this. And there's our actual application. Perfect. So let's come into our main TS file here. And then inside of here, what we're going to do is we'll actually set a breakpoint. Let's do it right here on our start menu command. So we'll do our focused window, web content, send, start timer. And then we'll come back over to here. We'll go to timer and we'll do start. And then you notice it didn't start, but we have a breakpoint being hit. Now you can only actually debug stuff here that's actually in the main process. Don't try to debug any of the components or anything like that. You can't debug that here on the inside of Node Inspector if you want to think of it on the server side in terms of like a traditional web app. You can't actually do that with inside of Node Inspector. For that, we're going to use the client-side debugging tools. But for anything that's part of this main process and any files that's included by main, you can actually do the breakpoints, you can do watch expressions, you can look at the call stack, all types of stuff, and you can debug this part of the application. But the key is you've got to have a debug build, and for that you need some type of C++ compiler, and you need Python installed. And then of course installed Node.js and Node Inspector. So now that we can debug the main process side, how do we actually work with the actual web page side of it, the actual UI stuff that we've been working on with React? So we've already seen the actual Chrome debugger tools and stuff earlier. So we already know that we can debug things that way. But one additional cool thing that we can do is we can actually use some of the extensions in Chrome. Now, in order for this to work, the first thing you're going to have to do is actually make sure that you have the React developer extension installed. So I'm going to go ahead and close up Node Inspector here, and I'm going to come under to my menu here, and I'm going to go under More Tools, and I'm going to go to Extensions. Now down here, you can see I have a bunch of different tools here installed. But the one that we care about right now is the actual React developer tools. So you need to make sure you have this installed to do what we're going to do next. And we're actually going to set it up so that the React developer tools will actually show up in the developer tools for debugging our application on the client side or in the web page itself. So now that I actually have that installed, what I'm going to do is I'm actually going to close my window here, and I'm going to close our application. Go ahead and close the program. And we don't want to search for a problem. We know what the issue is. We're basically killing it in the middle of its debugging. So I'm going to come back over here to window 2, and I'm going to go ahead and kill Node Inspector. There we go. And so what we're going to do now is we're going to add a little bit of code into our program to preload some things. So now what we're going to do is we're going to open up our main TS here. And inside of our create window, we're going to paste this piece of code. Now the reason we're pasting it inside of create window is this code has to run after the ready event for the application has been fired. So we'll go ahead and paste this code here. And what this is going to do is actually load up our extension. Now you might be wondering, where did I get this path from? So first of all Chrome extensions are going to be installed inside of your app data folder inside of extensions. The next thing is, where did I actually get this value from? So if you actually load Chrome back up and go back to your extensions, so go more tools, extensions. If you turn your extensions to developer mode, it'll actually give you additional information. It'll give you this ID value. So if I uncheck developer mode, notice the ID value goes away. But if I have developer mode checked and I scroll back down to my React tools, you see we actually have that ID value right here. So using that ID value, you find the right extension folder, and then inside of that folder, you'll actually see this version number here that you need in order to load it up. Now, technically, you only have to do this one time. If you add it multiple times, it's fine. It doesn't give you an error or anything. It doesn't blow up. But technically, once you add it the first time, it should be there for all subsequent uses. So I'm going to go ahead and save that. I'm going to say npm start, and this will now fire up for me. The problem I ran into here is that that environment variable is still set that we talked about from the actual server side debugging. So let's go ahead and just kill this command window, and we'll open up a new one, and we'll say npm start. So now I'll get my actual application, and I don't have any developer tools here. So, and I didn't actually leave a menu item to turn them on, which actually would be a pretty smart thing to do. But for our purposes, I'll just close this, and then I'm going to uncomment my dev tools there. And so now when I start it up, they'll just be automatically opened. So we'll fire it up again. There's our dev tools. And now let's go ahead and make this take up the full screen. And we'll come over here, and you'll see there's our React developer tools. So if I click on those, it'll connect to React, and you have access to the full React developer tools inside of your application, which is actually pretty cool. So this is very helpful for actually doing your development. Now, this is one way of loading up the tools, and it definitely works. But there's actually an even easier way using another package that's available. Now, this package, if we go back to Visual Studio Code and go to our package.json, this package we actually installed at the outset, the Electron DevTools installer. So what I'm going to do is I'm going to come into here, and I'm actually going to comment out this piece of code, and I'm going to add some code that will use that DevTools installer to actually install the React extension for us. Now this thing will actually go out and download it for you and everything. It's a full service type of operation, and it actually works with more than just React. If you're using things like Angular and stuff like that, it'll download Batarang and other extension tools related to other UI frameworks you might be making use of. So here we have our require, and let's actually collapse this so we can kind of see it all in one line. So we're actually going to require in the package, we're going to bring in this install extension function, which is actually the default export. We're going to specifically specify the React developer tools. This will actually install the extension and give us some kind of output in terms of the result of the actual installation process. So let's save that, and then come down here, and we'll kill our development process here, and then we'll actually restart this npm start. There we go. And now if we come into here, you'll see there are our React developer tools. And of course, they were already installed previously, but you could use either approach for actually installing these. But there you go. So now you have the ability to do the node or main process side of debugging in terms of debugging your actual main process of your Electron app. And you also have the ability to do the client side or the UI debugging of the web application part, and then even utilizing a tool like the React extensions to actually debug the React portion of this as well. So in conclusion, Electron is a cross-platform desktop application framework built on Node.js and Chromium. It's totally cross-platform in that it runs on Windows, Mac, and Linux. Applications are built using HTML, CSS, and JavaScript. They have access to all the local system resources and can tie into the operating system's underlying UI system. Finally, the applications can be distributed through popular distribution channels such as the Windows Store.